Welcome everyone to the very first Azure Developers.net Day. I am Haley Huber, Program Manager for Azure Developer Experiences, and I'm so excited you're all here with us today for a full day of building, optimizing, and deploying .NET apps to Azure. We have folks from all across Microsoft that build the products that you know and love, including .NET Azure App Service, Container Apps, Functions, and so much more. And they are here to share with you the amazing things that they've been working on. As I've mentioned, we have a packed day full of .NET and Azure goodness. I will be here all day asking your questions live to the speakers. And with me to help out is James Montemagno.
Hey, Haley, it is so great to be here. I cannot wait for all of these amazing sessions that we have lined up for everyone. As Haley said, I'm James Montemagno. I help lead our developer community team here at Microsoft, and I'm super thrilled to be here with so many of you that have joined in to see all of the amazing things that you can build with .NET and Azure. Not only build, but also optimize and, of course, deploy and scale your applications for everyone. Now, there are tons of sessions throughout the day, and they're all going to be available right here on the new Azure Developers YouTube. So subscribe and stay up to date. So jam on that subscribe button. And of course, hit like at any time. You got to say those things. They'll also be on Microsoft Learn at learn.microsoft.com under the events tab. So go ahead and check out that for all other events too. So Haley, what do we have in store for folks?
All right, James, we have a wide range of topics for all .NET devs. On the .NET Developers.net Day event page, you'll see the full agenda. We have organized the day into multiple topics, including app dev, cloud native, data services, serverless, and productivity. So no matter what you're building, there's something here for you.
That's right. There's all sorts of stuff from start to finish. So whether you're new or looking to learn about Azure services for .NET, there's something for you. Now, additionally, we have put together a full learning resources guide over on Microsoft Learn. This will give you everything you need, whether you're just looking for some documentation or videos or full training modules. Everything that you need is right here. This is going to be on that same event page or at this aka.ms. And we'll continue to share this throughout the day and, of course, put it on the videos that are shared later on YouTube.
There's so much going on with Azure Developers. As James said, be sure to follow us on YouTube or Twitch to stay up to date with all of our latest streams that's happening with our community stand-ups from the team each week, and on all of our socials to see what's new and coming up with Azure. With that, let's kick off the day with the one and only Scott Hanselman talking about how the real 10x developer is the tools we used along the way. Over to you, Scott.
Hello, hello, hello. Hey, friends, how's it going? Thanks for spending time with us today. There is a lot of exciting stuff happening right now in the .NET space, especially in the cloud. And I was thinking about this term 10x developers and how much I dislike it. How we create this mythology around what someone who is a 10 times better developer than another person is. And I was realizing what a completely mediocre developer that I am, and how I have been able to succeed in my career because of the tools that have made me better. And they've made me more successful, and they've made me happier. So I'm going to go ahead and share my screen here, and we'll drop into the command line. I like to drive stick shift sometimes, and I'll spend some time in Visual Studio, but I wanted to go and explore a couple of things because I was realizing in the creation and maintenance of my websites and my blog and my podcast over the years. These are small sites that I have. We've got hanselminutes.com right here, and then I've got my Hanselman homepage, and then I've got my blog. These are all .NET applications, and the website's now been up for, gosh, 20 plus years, and I started in .NET 1 and then 1.1, and now we're moving into 6, 7, and 8. Sometimes people can feel a little bit overwhelmed. And I'm running all of these sites kind of on the side, doing my own thing, and I'm using Azure to do it. And in the process, I'm feeling really productive, both in the development of it, but also in the running of the site. And it's actually the tooling and some good practices, some good best practices that have allowed me to be successful. And I'm realizing that I wasn't using the tools enough. For a while, my websites here that were running in Azure were not very well run. They were not very well source controlled, and I wasn't taking advantage of some of the opportunities that I had to me. First thing that I had happen was, for example, on the Hanselman, it's podcast site, of which there are now, gosh, almost 900 episodes of really cool people, including a great show this week where we talk about Visual Studio Code that we're going to see a lot of folks using with our Azure developers day to day. The website, I didn't feel like I could trust it. I didn't know what was live in production. I didn't know which version of .NET I was using because I was using app service. I wasn't paying really close attention to it. And I wouldn't update the site for a couple of weeks. And then I would go, gosh, when was the last time I deployed? Or what's in production right now? And then if something went wrong with the site, I never really felt like I could understand if it was me or not. So I made a couple of interesting changes that I think I might want to share with you. First, I did something that Damian Edwards suggested. Down here in the footer, you'll notice a couple things. Now, I don't necessarily recommend this to everyone, but I think it's an interesting tool. I'm putting in the version of .NET, the runtime, in the footer, and I've also got down here the commit hash for my GitHub kit, my git commit, and the actual log from Azure DevOps. So I went and took this website and I made sure that I had that code in Git and GitHub. I hooked it up with, in my case, Azure DevOps, although some of my other sites use GitHub Actions. And then by putting this information here, which helps me. Now, some people might say you shouldn't put that stuff there. That's actually behind passwords. That's behind passwords. And maybe that's a security problem. So if you wanted to, a best practice would be to have an if I'm logged in or if is admin. I understand that the folks that work on Stack Overflow do similar things like this. So if you are an employee of Stack Overflow, you would see a different website than if you were not, and then you would see additional diagnostics information. So imagine a footer on your website that shows diagnostics for you. And I'm calling this diagnostics in this case because it's helping me better understand my system. So on this one, I've got .NET 6, and I'll be upgrading to .NET 7. And then this commit, I can go and right click on, and I'm going to use Edge. I have two different profiles. I've got personal and I've got work. I'm going to right click on that and say open as work. And then when I pull that over here, you can see that just last week I made a small change, and I can go directly into GitHub, see that I made just a little text change on a Razor page. And that's the commit that's currently in production, which is really cool. And then if we look at this link here, that build, go ahead and open that, and that's going to take me over into Azure DevOps. We'll do a quick login, and I'm going to see the actual results of the build. You can see it was a 2-minute and 25-second build with a published artifact. That's the thing that actually got published on the site. And then we'll click down here in jobs. And then this is where things really get fun. So down here, I'm actually seeing, remember, I got here from production, the pipeline that ran. And I've recently set up Playwright. So in Playwright, I'm going to be doing testing in Azure DevOps as well. So you can see in my Azure DevOps where we're bringing in the .NET Core SDK. In this case, I am explicitly using .NET 6 as I get ready to make my move to 7. I go and install Playwright at the command line. So I'm using XUnit and NUnit to do my regular unit testing, and then I'm also doing Playwright testing, which is cool. We'll go and build those tests. I go and run the Playwright tests, which goes and does headless testing in the cloud, test it, publish it, and then the publishing here is going to go and publish into a zip file, and then that zip file is the artifact, right? So we've produced a build artifact in Azure DevOps, and then we're going to push that over to Azure. Now in Azure, I used to make the mistake of one app service plan equals one app. And I thought that that was obvious, that I should just have one app service plan to one app, but I realized I was giving money away. I didn't want to waste money. This is a side website. I'd like to make it as cheap as possible. So I realized that I want to look at my CPU percentage and my memory percentage in Azure portal, and I want to treat what's happening in Azure differently than I would treat a physical machine. If you were on a physical machine that was constantly at 40% CPU with memory memory pressure or memory percentage almost 70%, you might say, this machine is working too hard. I need more headroom. I'd like to see that CPU down here in the 10% range, or maybe I want my memory pressure under 50%. But that is an old way of thinking. That is a non-cloud way of thinking. The cloud is just a funny word for other people's computers. And I would very much like this machine to work hard because I'm renting it. It's that same reason that you drive a rental car differently than you drive a car that you bought with your own money. You tend to abuse a rental car. So I'm going to be okay with that CPU percentage. And I'm looking at this and thinking, how many websites can I fit in this Azure App Service? So what I've ended up doing is saving a ton of money by, and it's counterintuitive, I know. I used to have multiple basic plans with one app per, and now I have actually a premium plan. I've got this P1 V2. We'll go ahead and click on that and look at the hardware for that app service plan. So you can go in here and see these production plans. So rather than a bunch of $25 plans, for me, I switched to this plan, which is premium, and I'm thinking, oh, wow, this is going to be expensive. Well, it's 3 times more than basic, but I'm actually running, go ahead and look at our resource group here, a ton of stuff in there. So when we click on the app service plan and look at that, we've actually got 4 individual websites running on the premium. So I've got the blog, I've got the homepage, I've got the podcast, and I'm actually running Azure Friday. So now, for 3 times the cost, I'm running 4 times the website. So I'm actually saving $25 a month, and I'm getting way, way, way better perf, and arguably have a little bit more headroom there and could probably run another small site. So all 4 of those sites are running happily on that app service plan. And that was a big move for me. That was a big deal. Now, I also want to point out here that runtime stack is being managed, right? Not on the app service plan layer, but actually on the app by app. So let's go and look at that, and we'll go and take a look at configuration. And then I'm going to hit general settings. And you can see here, we've actually got .NET 7 ready to go, which is going to make it nice when I switch one of my sites from 6 to 7. And all my sites are different right now. If we look at the home page, You can see that I'm powered by 6014, that runtime. But if we look at the podcast, we're on 6015. So that little bit of context gets me more confidence about like what exactly is going on right now, what's in production. It also calls out the difference between the SDK and the runtime. And I'm seeing those numbers go up as I watch new versions of .NET roll out for my applications. Sorry if you're seeing my mouse jump around a little bit, my friends. We've got a little bug here in our screen sharing that's causing that to happen. So my apologies. So here I'm going to swap out to the command line. As I was mentioning, I like to drive stick shift, and I've taken the Hanselman site and I've gone and made a Docker file. So I'm going to just go ahead and open that up. I could open it up in Visual Studio. I could open it up in Visual Studio Code. In this case, it doesn't really matter that much. And I'm going to just show you this Docker file. We'll go ahead and we'll zoom in a little bit there. You can see that we've got .NET SDK 6. So we're doing a multi-stage build. The first stage is going to be to build our application. We're going to build it, and this is really interesting. We're building it inside the Docker container, right? So we didn't build on our Windows machine. We're building inside of Docker. We're copying our code into there. And then that build happening inside the Docker container, which means I could theoretically do everything in Docker if it made me happy, maybe using some of the remote extensions for Visual Studio Code. And then I'm actually going to install Playwright, which is my tester. That's happening inside of that Docker container on another layer using a building. I'm going to test everything. We're going to test everything, publish it into a folder called out. So this is multi-stage. When we say multi-stage, it's a multi-stage Docker if you have those words from multiple times. So at the very top there, we started at the .NET 6 SDK. We did all of our work, our building, our testing. We published into that out folder right there. Okay. Then we're moving now to the ASP.NET 6 runtime. Now this is important. Notice that I called it as runtime, but up here it's very, very different. That's because there's no reason for me to go and ship the SDK, the DLLs, the libraries that I don't need. I don't need to ship the compiler. There's no reason to put the C# compiler inside of a Docker runtime. I'm just going to use the bare minimum. And you can decide how bare minimum you want to be. We've got a bunch of really cool stuff happening in the Docker space right now with what are called chiseled containers that have as little surface area as possible with our friends from Canonical and Ubuntu. You're going to see a lot of really interesting innovations where Docker containers get smaller and smaller. .NET in .NET 7 and 8 get smaller and smaller as we include things like AOT. And that's going to allow me to have even more density. We're going to see both on disk sizes go down, and then I could potentially think about my memory footprint, and the less libraries and less stuff that's happening in memory, the smaller and smaller my application's runtime gets. Now I can publish more densely and maybe fit another website or two into that. And remember, I've already paid for that Azure App Service. So if I can fit another website in there, that's just free. That's just free money. So then we publish that and we have our opening entry point. So that's a pretty basic multi-tier, multi-stage Docker file. And then we go back over into Azure. I've got choices. It's Azure App Service. When I make an app service, as you'll recall, we can go and make a web app. We've got choices. Those web apps can be done as code, where the build happens up in the cloud, as a Docker container, as a static web app. We can choose Linux or Windows. Lots of different choices. Also, switching over to Linux in the cloud saved me some money, which was pretty cool. It was about 30% cheaper. So how did I test that? How did I go from Windows over to Linux? Well, if we switch back to the command line here, I can say .NET build. Here we are on Windows. I'm building on .NET 7 because I'm going to start testing. You can see in my prompt, we've got the current folder. We've got my current Git branch. And then I've put the version of .NET in this folder. .NET 7. I'm on a preview of .NET 7. And then for those that are paying attention, I've also got my blood sugar right there, because when I'm working, sometimes I lose track of what my blood sugar is, and I like to keep up on that. So here I'm in Windows doing that build, but I'm also using WSL, and I'm using the Windows terminal. So we see Ubuntu appearing right there in my dropdown. I'm actually going to pull that down. I'm going to hold down Alt with my left thumb, and then with my right hand, I'm going to click on Ubuntu. So I'm going Alt, click. Now look, on the left now, on the left, we have PowerShell on Windows. And now on the right, we've got Ubuntu. Look at that. So here I just did my .NET build. Over here on the side, let's go into another folder. And this is an important thing for you to think about if you're using WSL yourself. You're not going to want to use the Windows file system. If you're on Linux, you're going to want to use the Linux file system. So how do I move stuff between these two folders that are really the same folder? Well, I treat it like a different machine. So I'm going to use a git pull. I'm going to bring that information down just like I would anything else. So here I am on WSL running Linux on Windows. I've just done a pull, and I brought this down. And there's that change that we just saw. There's that change that I made last week, that small razor page. And then you'll notice I'm using the same prompt. I'm using Oh My Posh. And I really like Oh My Posh for .NET developers because you can see the version of .NET, but you can also put your Azure subscription there. Or maybe if you work for one of the Azure government or one of the sovereign clouds, you can actually see which Azure that you're currently logged into. So having a nice prompt is cool. And in this case, I'm sharing my prompt between Ubuntu and WSL. So here we are on 6. I'm going to type in .NET -- version. Let's go ahead and zoom in and do that again. I can see I'm on 6.0.1.1.3. Then I can type .NET -- info. And you can see we are on Ubuntu Linux. I'm on Ubuntu 22, so not too old. x64, and then we can see the location of the SDK. So this is confirmation. If anyone thought we were running this out of C program files, whatever, no, we're not. We can also, if we want to prove it, go which.net, and we can see that that's in userbin.net. Well, if I switched over into Windows, I could type where.net, and it would tell me it was in program files. So that's .net on the Windows side, and this is .NET on the Ubuntu side, which means that I could then go .NET build and build that now freshly brought down version of .NET, which is cool. So check that out. So that just came down. Now remember that Docker file. I'm running Docker. I can run Docker on Windows in both Linux and Windows because Docker Desktop shares that context. And that's really cool because if I bring up Visual Studio and I open up the Hanselman its website, we're going to have a couple of different options. And that tooling is going to make things more possible than ever before. So here is the website inside of Visual Studio. When I pull this down, check this out. We've got Kestrel, or just running the project directly. We've got IIS Express for folks that are still using IIS in Windows. I have that option. And then I've got WSL. I can go and hit F5, and I'm in Windows running Visual Studio 2022, Visual Studio Senior, Visual Studio Proper, the big one. Look at all this great tooling. I've got my Git support over here. I've got a lot of tests that are happening. All the new folding stuff. Check this out. This is really cool, actually. So this is something a lot of people haven't turned on yet. Look up here in the corner. You see my line numbers? You know how sometimes you start scrolling and you lose context and you're like, where am I? Watch. I'm scrolling down in Visual Studio. See how the line numbers just went 1 and then 10? So if I'm right here on setup or right here on test, look, I'm on line 39. But I know I'm in this method on that class, on that namespace. Isn't that cool? That's an option you can turn on in Visual Studio right now. I'm on Visual Studio Preview. It's the public preview of Visual Studio Community. You can use this as well. But I wanted to point out that WSL support is built right in. Now I'm going to go back out to the command line here, and I want to just remind us that I can say Docker images, and we can say Docker PS and see that nothing is running. I made a little batch file. I used to call them batch files because I'm old, but they're really just PowerShell scripts. And these PowerShell scripts are not very fancy. Why would I make a PowerShell script called Docker build? Well, what it's doing is it's using what's called a shebang or a hash bang. That's a hash, that's a bang. And that's saying in Linux, I want you to go and look at the environment and use PowerShell. So PowerShell isn't in this context being used as a shell, it's being used as a scripting language. That line, that first line is ignored on Windows and it's used on Linux, which means I can use these scripts on both Linux and on Windows. So that means that I can go Docker build. Actually, this is assuming I have PowerShell on this new machine. I hope I do. I do. This is a brand new computer that I just built with Damien a couple of days ago, so bear with me. So this is the first time on this new machine that I've ever run this Docker build. So this is going to be interesting to see if this works, because the whole point of Docker is for these things to build reliably, isn't it? So what we're doing is we're building each of those layers. You can see that we're doing a .NET restore right now. So that's going to be a network dependent thing. So that's going to go as fast as NuGet possibly can. That .NET restore looks like it's done. That's coming down pretty fast. And I can actually look at the task manager if I want to see what's happening. You can see that Docker is doing that network work, bringing that information down. Now we're going to do the build. The build is happening inside of the Docker container, already done. The publish is happening. Look, so now Docker images, there's the podcast 6 seconds ago. Okay, now we'll say Docker run from Linux. Go ahead and pop that up. And then look at that. Now, let me open up another Ubuntu over here. I'll say Docker PS. There it is. Sweet. Satoshi, 10 seconds ago, from port 8000 to port 80. I've got my application running. And then if I wanted to, as my finale, say Docker test. We've already done the first layers. So you can see here that all of this work already happened. So that just jumped immediately to the next stage. And in this context, it's going to then install Playwright, finish my tests. And if I feel good about this, I could then check it in. It'll go and run in Azure DevOps or GitHub Actions. And because it's in a container, I have the choice of how I host it. And then if I bring it over again to Azure, I've got the choice of doing it on Azure Web Apps, Azure App Service rather, in a Docker container, or exploring other options. All in this case slapped into a single Linux plan, working nicely, working hard, and I feel good about it working hard because I'm saving money. See if I can fit some more in there. And in fact, I have a couple of plans. If we go to my app service plans, got my blood sugar, I got my Linux, I got my default Windows Server farm. And in that one, I'm actually using a basic pricing tier, and I've got 6 sites like babysmash.com and some of those smaller sites, which is pretty cool. So I'm feeling pretty good about that. Let's run back over here. We can see that we're just installing Playwright. I'll let that finish. It's probably going to take longer than we have time for. But we've got a whole fun day planned for you, my friends. Lots of cool demos from lots of cool people that are going to be showing you how the maybe the real friends are the tooling that we made along the way. There's a lot of great stuff, whether it be Visual Studio Code, or whether you like to drive stick shift. So I'll bring James and Haley back to come and hang out with me.
Awesome. It's always great to see how you code, Scott. It always inspires me and a lot of people. I shared your article to Oh My Posh, which is great. I always inspire to have a terminal like you one day. I think you answered quite a lot. When I grow up, I want to be just like Scott's terminal. A lot of good questions came in from the chat. We do have another minute or two, but I think you actually answered a few of them, but you did answer specifically why and how you develop not only with WSL, but from Windows with multiple tools. Of course, you could do that on a Mac or on Linux machine, wherever you're at. Someone was asking, you decided to host on Linux App Service, which you did answer. You can double down on that and double click, if you will, Microsoft phrase. But is there any, they were asking specifically about, like, if they're running on different operating systems, are there any gotchas, like they're different OSs, you know?
That is a fantastic question. Right. So they're asking, you develop your apps on Windows. Why do you host them on Linux plans? So I'm hosting it on, I'm developing it on Windows because I like Windows. I enjoy I enjoy Windows. And I feel that it is the year of the Linux desktop on Windows. I'm finding that as a shell, Windows works great. I can run my Linux apps. I can run my Linux GUI apps. But I am developing on Windows, but I'm developing on Linux on Windows. So in fact, I compile and test on Windows. I compile and test on Linux using WSL. So I know that it's going to run because I ran it on real Linux on my Windows machine. That is not an emulator. That is real Linux. By the way, if you bring my screen back up, I want to show you two things very briefly. You can see that my tests pass, both my unit tests and my Playwright browser tests all passed running entirely in Linux, so that I know this site will run in production because I just did it on Linux. So Windows, as my favorite place to do development, gives me all of that flexibility, and it gives me choice. So to the individual's question, if I move it to a different host, if I want to run it on Windows, if once I got it running on Docker and on Linux, my choice is opened up, and I can even bring up a version of the Hanselman podcast website. You can go ahead and unshare my screen now, and I could go and bring it on a Raspberry Pi Kubernetes cluster. I have proven that my website runs on Linux well enough that it runs on Raspberry Pi, and I can scale it across my little cluster. And what are the gotchas? Don't call the registry. Don't use backslashes, right? Don't call Windows APIs. So what you do is you write portable code, and we actually have the .NET Portability Analyzer that allows us to go and do that across multiple versions, as well as across multiple operating systems.
I love it. Scott, John has this great thing about the Playwright was running ASCII art progress bars rule. I think that is 100% correct. Here's a good one, actually, from Shaul is, do you have any tips on being a presenter? And I know that you do.
The way that you are trying to be a good presenter is try to be as empathetic as possible. And as I'm making my moves, as I am going here and going there, in my head, I'm thinking, James is watching and he's saying, well, so what? Now that seems like an aggressive thing to say, so what, so what? But each moment, each step, oh, you're running on Linux? Well, so what? Well, hang on, that's in an Azure App Service Plan. Well, so what? So that moves the conversation forward because I'm thinking, well, what is someone who's not at the command line? I know that you're not a command line person. We joke about that. That's fine. Some people like the command line. Some people like Visual Studio Code. Some people like Visual Studio. So I'm trying to think about all of those different people and then making sure that as I build that presentation through line, you remember all of the callbacks. I'm rolling backwards and I'm going, and that relates directly to what we talked about 30 seconds ago, which relates to what we talked about at the very beginning of the talk, which is all about using the tools that make you happy and make you feel productive.
Yeah, it's fun to watch through the process, because as folks are coming in and asking questions, you're asking those questions to yourselves and answering them as well. And you don't even know what people are asking, but that comes up naturally because what would they ask? Additionally, may I recommend Hanselman.com, scroll to the bottom under speaking, there is speaking videos and presentation tips on there. I will say, before I joined Xamarin over 10 years ago, I did take Scott Hanselman's masterclass before it was called the masterclass in presenting. I was way back in the days, like coffee scripts or something like that. It was really fun.
We did that on Pluralsight, and I'm actually going to be at Pluralsight Tech Days next week on the 20th. So check out Pluralsight Tech Days. It's going to be free. And actually bring up my screen real quick to John Galloway. You know, people are talking about 3D, VR, but let me tell you, give me a nice ASCII progress bar and I'll be impressed. So John Galloway and I are very excited. If there's any kind of ASCII art at the command line with emoji, I've got blog posts on how to do that work inside of .NET, so we can bring you ASCII progress bars.
Awesome. Well, Scott, thank you so much for your presentation. And I got to go get my terminal all up and looking awesome. Thank you so much. Have a great day and see you later, Scott. Awesome. Well, we have so much in store for you. Head over to learn.microsoft.com, hit events. There's the Azure Developers .NET Day. We'll bring up a banner on there for all the agenda. We have amazing sessions all throughout the day. And up next is one of my favorite people in the world, Mr. Mark Downie, talking about diagnosing complex code issues in Azure App Services. Over to you, Mark.
Thank you. Hi, good people. My name is Mark Downie. I'm a program manager on the Visual Studio Production Diagnostics team. And today I'm privileged to talk to you about diagnosing complicated code issues in Azure App Services. We're going to be exploring some of the diagnostics tools and the apps that we've kind of developed for you in both Windows and Linux scenarios. I'll be diving specifically into auto heal scenarios. I'll be looking at the improved collection and observability that's going to be powered by .NET Monitor for Linux. I'm going to be showing techniques on how to connect analysis directly to my code. So I'm actually thinking about it from a very code-centered perspective. I'm also going to show you some techniques about diagnosing dumps in the portal and actually in Visual Studio as well. Again, just a deep dive here we're going to do. So why is production diagnostics so hard? This is the kind of thing that I'm here to talk about. Why is it so hard? It's because, frankly, we spend weeks, months, and years sometimes in the very best IDEs, Visual Studio Code, whatever your flavor is. And we have every tool at our beck and call. We can set breakpoints. We can look at call stacks. We can look at parallel stacks, memory tools, profiling, watch windows. Every kind of tool is at our fingertips, and it's all code-centered. And because it's code-centered, we have an immediate idea of what the problem might be. However, when we go to production, we're kind of left without any of those tools handy for us to use. And so that abstraction layer that exists between us and production becomes problematic. And so we then tend to have to think about things in terms of, well, is there a log for that information? Or is there a symptom about that information? Like it feels slow or it's using too much memory. Either way, today I'm going to want to talk to you about the techniques we use to kind of make sure that we have all of those tools at our fingertips to make diagnosing in production environments as easy as it is when you're in your local machine. So we're going to start by jumping over to the portal here. And in the portal, I have two resource groups, one for Linux, which I'll talk about later, and one for Windows. And I'm going to go ahead and jump into my App Services app for Windows. And along the left-hand side, we have a series of tools. And I'm actually going to start with what I think of as table stakes. We should always have a really strong log game, essentially. This is, we no point in talking about complex issues if you don't have the basics in place. And so we're starting with logs. So this is a log stream, essentially, which is basically the logs that are coming towards my site right now, as my site is managing requests from customers. Like log streams is the place to start. If you don't have a logging game, you're going to solve most of your problems, frankly, with logs. Once you can enable that with the app service for log, and you can switch those on here and get an immediate log stream. The other part of logs that is important, this is a kind of a grow-up story for those of you who have managed your own servers in the past. You also have the ability to query your logs. So rather than simply do a Control F on some massive note text file, you actually can literally query for the kind of data you want. Again, table stakes, we have to start here. Further from that, kind of a step up from logs, right, would be your metrics, right? And you have, and I think Scott showed this earlier, you have metrics as well. So I can start saying other things. So when somebody tells me my site is slow, I need to kind of necessarily compare that to something in my head. That could be slow compared to what? So maybe I can go down and look in here and see response times. Select response times. Right, and that's going to show me average response time over time. I now have a better sense of when the customers are saying slow, what that means. I can start using a combination of logs and metrics to form a hypothesis on most problem spaces. This is where I start, but for some class of problems, frankly, this isn't good enough, and that's kind of where I wanted to talk about today. I wanted to talk about the class of problems that are a little bit deeper than logs. There's probably not enough information there for me to really get back to those developers and get them working and get them fixing things for me. And there's a class of tools that are in the portal underneath what is called Diagnose and Solve. And if you click on that particular tool, you're brought into the Diagnose and Solve blade. And inside the Diagnose and Solve blade, in fact, it's immediately saying I have a couple of risk alerts. Let's kind of look at those first. The two risk alerts it's kind of suggested, one of them is a health check, right? If I could literally set up on my app a endpoint that literally says, I'm good, right? It's a really quick way for app services and the entire diagnostics infrastructure on your PaaS offering to check if you're in a healthy state. And the moment you know you're not in a healthy state, you don't return 200 to this kind of request for information. The other thing it's suggesting, again, depending on your app and what it needs, it's suggesting, hey, mate, this is on one instance, so it's kind of doesn't have any backup. Do you want to kind of spread this across multiple instances? Great suggestions. I'm going to keep going into this Diagnose and Solve. Here we go. Okay, but there's a bunch of other tools I kind of want to show. Specifically, there's a availability and performance tool, which is great for web app down, web app slow scenarios. You have a configuration management tool to check if you can misconfigure your app, security configuration as well. And the one I want to focus on today is the auto heal scenario. Auto healing is a fascinating idea that allows me to think about what kind of action I can take if my app isn't performing correctly. So there's actually two types of auto heals here. There's a proactive auto heal, meaning this is something that the platform, the App Services Diagnose and Solve team is providing for you. And in this instance, what it's basically saying is, in some known bad scenario, we're going to take some mitigating action for you on your behalf automatically. And again, this is an opt-in, so you decide whether you need it or want it. So for example, the symptom might be if my app is using 90% or more of its memory for a long period of time, why don't you go ahead and let me know and go ahead and restart my app? Or I could say, if 80% of my requests here are taking too long, then the platform will say, you're in a known bad state, so let me go ahead and restart for you. So that's proactive auto healing. This is kind of free for you. The one that I think is interesting for me, however, especially as somebody who likes to look at diagnostics in production environments, is the custom auto heal scenario. Now, I can define what is bad for me. I can define what is slow for me. I can define what is too much memory for me specifically. So in this particular example, I am using request duration as the trigger. And I'm saying here, if 20 requests take longer than 15 seconds during a minute period, that's a bad situation and I need to do something about it. And you actually have options about the actions you can take once you're in that particular situation. You could simply recycle your application. That could be one option if you're not sure what the problem is. However, I would like to think about how I can mitigate the problem permanently. So what I could do, seeing as I'm not getting the information from my logs and I'm not getting any additional information from my metrics, I could take another kind of diagnostics artifact, a much more richer, much more feature-rich diagnostics artifact, and that can either be a memory dump or a profile with threads, right? So think of about a memory dump as if it were a breakpoint at some point in time in your application. So you've stopped the application and you want to take a look at what all the kind of tools you have in Visual Studio. This is like taking that memory snapshot, that breakpoint moment where I can kind of investigate what's going on. And a profile is the similar kind of thing, but it's something over time, right? But these aren't necessarily easy to kind of look at and investigate. And so what we do within in the platform is start analyzing for you. So this is an existing set of sessions I've already taken. This is a memory dump I captured a couple of days ago on my application. And this is the report it's created. Now, some of you at this point are saying, give me the memory dump. I'm good. I'm a WinDBG guy. I know all the wizardry and you would be good to go. But for those of us who need a little bit more coaching in this area, we have a report that's going to tell you the top line information that's going to be valuable here. So right here in the portal, you can start your diagnostics on a really deep artifact, right? So I'm going to open up the report for this dump, and it's picked out for me from that black box. It's picked out all the kind of data I want to kind of get started with starting to analyze this. So for example, I'm looking at this and I'm seeing I'm on an x86 machine. I actually do have the heap present in this memory dump. So that means I have all the objects on the heap inside this memory dump. I can see how long the application was up before I took this memory dump, and I can see why it was collected in the first place. There's actually inside here a bunch of findings, a couple of information it sees that might be important to you. So for example, the other findings, if I wanted to see what kind of inbound calls were being made to this application at this moment in time, I can do so there. I can see if there's any pending work items in my thread pool queue. I can see the unique call stacks that have been run in the process as well. All this is a list of information that's going to help me form a stronger hypothesis of what the problem is in my production environment. Again, I think some of the problem we have is that we're not in a very code-centered mindset when we're diagnosing problems in production. So I'm going to show you the one with the big red X next to it, because I think that's probably going to be important for our analysis. And if we look at this, it's telling me that this particular method is the sync over async is giving away the problem here, is synchronously waiting on a task.result, and this is causing thread pool starvation. And your app may experience the following symptoms: underload, slow web requests, loss of throughput, and request timeouts. Now, if you go back to the symptoms I set up, the auto heal symptoms I set up, I was saying, hey, if this is slow, if this takes 15 seconds over a minute, I want to know why. This is kind of pointing out the why of the slowness, right? And in fact, it's pointing out the sync over async anti-pattern. What I love about these new tools is that if I click on this link, it's kind of, you can see a link and it's showing me some anti-pattern examples here. If I click on this link, it brings up a call stack. With a call stack, I am much more in tune with what I've been seeing in Visual Studio. We use the call stack in the bottom right all the time to see how deep down the rabbit hole we've actually gone, right? And in this call stack, I can do similar things to what I would do in Visual Studio. I can look at just my code. I can take that off and I can search the call stack for the namespace that I'm most interested in, and that's buggy demo web. That's my application running here. So this is the kind of causal problem, but I'm still kind of a bit divorced away from my code at this point, and I think we could get a bit closer. And in fact, that link here is inviting us to click again. So I'm going to go ahead and click that link and see where it takes me. And in fact, what it does is it brings up GitHub. So I've gone from being in production with a problem on slowness. I've captured an artifact. It's told me, hey, we think this is what the problem. And then furthermore, it's told me, hey, this actually is the code that we think is connected to this particular problem. And if you look at the kind of pattern here, I have a piece of code where I'm calling .result here. If we go back and look at what we originally were talking about here, it was suggesting that there is an anti-pattern. If you're using a .wait and .result, this is a problematic anti-pattern. Now, David Fowler has a fantastic article on this on GitHub where he talks about the sync over async anti-pattern. It's a great article of what to avoid. And I've obviously fallen into that trap. But what's great here is that it's pointed out the problem and it's pointed me back to code. I could now just simply hit the period key. And now I'm in github.dev, right? This is kind of VS Code in the browser. Now that I'm in GitHub for browser, I can hit Control-Shift-P, bring up the command palette, and create an issue saying this is sync over async. Hit enter, and I am now opening an issue on my site, and I've referenced the information. And hopefully right now you're saying, well, how in the world did I make the connection from what is my portal and my production environment to GitHub and some code there? And that I can answer really succinctly. In my project, we are relying on a technology called SourceLink. And technology enables source code debugging And this was kind of made popular around NuGet packages, where developers wanted to make sure that, hey, if you are using my NuGet package and you have a problem, maybe you want to debug into the package and see the details of the package. Well, that same technology can be applied to your production code. Let's say you are you want to kind of investigate an issue and you have debugging tools. You can use those same debugging tools to get information about your commits directly in GitHub and, frankly, other source repositories. And I'm going to show you how I did that. So I'm in the csproj file. And in the csproj file, I am showing you a series of entries. First one is publish repository URL. This means that when I build, it's going to grab the repository URL as part of the build, and it's going to include symbols, the PDB files, and it's picking the format for the PDB files. And then in the last portion here, what I've done is I've included a package reference that says, hey, my source file is in GitHub. And it's packaging this information, this metadata together in either my assemblies or my PDB. And so when it builds, it knows exactly the commit that is all the commits and all the information associated with this build. So when if I go back over to GitHub here, you can see I'm not only just looking at a specific class file, I'm looking at a specific commit of a flat class file. So I actually can track down literally the developer who created the problem all the way from my production analysis. We're not only doing this with this report, we're developing multiple other analyzers as well. So I have an analyzer here that is around exceptions on the heap. What our customers were telling us is that they want to know at any given moment which exceptions are what the list of exceptions that they may have at any given moment, and could we capture just a list of exceptions? And we actually can do that. So this diagnostics report again has got the list of exceptions that are on the heap, because I've got some kind of problem I'm trying to track down. Maybe my customers are seeing a bunch of HTTP 500 errors, and they think there's an exception and they want to get more details on the list, the kinds of exceptions that are being generated. And I can click on this exception type. This is actually a system object disposed exception. And I'm going to click on that type there. Let's go ahead and click that again. And again, I've got that rich call stack feature. This is familiar to me as a developer. I now know, I kind of feel a bit more comfortable about where this code exists. In fact, I can again click on this link because again, I've got source link enabled. And I know exactly where the source code is for this. And in fact, I can quickly see I've kind of closed this before actually reading it. I've got my code right next to my production diagnostics scenarios. And again, I think that's just a much richer experience for us as we try to resolve issues. So this is all Windows so far, but these experiences are existing in Linux. So we're building up this same set of experience before. So whatever platform you prefer, whether Windows or Linux, we have similar scenarios. So I'm going to go ahead and go back to the portal here and click on the Linux app services app. And this time I'm going to, in fact, what I want to do is go to the Kudu experience here. We've been improving the Kudu experience. If you've kind of developed for app services for Linux and app services for Windows, you would have probably seen a few differences in the list of tools available. So I'm actually going to show you how that has been improved. I'm going to go to Advanced Tools and click here, and this will bring up the SCM, the kind of Kudu experience. And this is kind of not as feature-rich as the Windows, but we're building this out as people are choosing Linux more and more. So I'm going to go to Process Explorer, and this entire experience is being powered by a new tool we've been developing here, a .NET Monitor, and it allows me to see a list of all my .NET processes. So in the same way I can do this, been able to do this for years with Windows, we are now building a set of tools to allow you to do the same things in Linux. So choose whatever works best for you in the scenarios that you are working on. But you can go ahead and start profiling. You can start collecting memory dumps that you think are valuable for you. So for example, just through the click, James already said that he didn't want to do anything from the CLI. This is perfect for him. User experience, just go ahead and click collect dump, and that will start collecting the dump for you and allow you to download. All the auto heal scenarios are also available for you in Linux as well. So I've started downloading that dump, but in the grand tradition of Blue Peter, which was a TV show we used to watch when we were younger, I'm going to go ahead and grab a memory dump I had before, if it will respond to me appropriately. Let's go ahead and all right, let me grab that. And in C drive, dev, let me see, and okay, all right, here we go. So I've got a Linux dump. You can see it's a Linux dump. It doesn't have an extension on it, so I've got it from some Linux environment. In fact, Windows doesn't recognize it as anything, right? But I'm just going to go ahead and drag and drop that into Visual Studio. All right, and Visual Studio immediately recognizes it. It didn't need an extension. You don't need to add an extension to it. It immediately recognizes it as a .NET dump, a Linux managed .NET dump. And you can see I've got similar information to what I was showing off in the portal. I've got the name of the dump, the last write. I've got a heap present, meaning I can look at objects on the heap, the managed heap. This is the CLR version that this is from. Just in case you don't trust me, this .so is the shared object. That's Linux for those folks who are informed on this topic. But those are shared objects. This is genuinely a Linux dump, right? These are module paths to that. So what can I do now that I have this memory dump? Remember I said that this is basically like you being at a breakpoint while you're debugging an app. So you've just basically gone to your production and get me that breakpoint and let me look at what's going on. So what could I do here? I can start debugging the managed memory. I think I already said it has a heap. So I should be able to look at the objects on the heap. So I get to see all the objects here. I've got a list of buggy demo data records. I can look at this from a generational view. We've been making some changes to the memory tool here. So I can literally say, okay, I want to see generation 2. Actually, I want to see large object heap and pinned objects. I can kind of just look at this. Again, this is kind of features available to you in Visual Studio that you've probably taken advantage of. But now I'm looking at this directly from a Linux environment. What else can I do here? So not only can I look at the heap, I can start as if I was debugging. So I said this is kind of like you're at a breakpoint. So let's look at what that breakpoint would look like. So if I look at my list of threads, these are all the threads that are running code. Some code, or that some of this may be my code in each of these threads. I'm currently on the main thread 73, and you'll probably recognize this is the program file, program CS for an ASP.NET Core application. But what I want to do is kind of take a quick look at the parallel stacks window. And the parallel stacks window gives me an overview of all the threads and what they are running, right? So each thread has running code on it, and that's my call stack. So each of these nodes represent a call stack to me. But I know that this is actually a task-based application. So I'm going to go ahead and switch this view to tasks. And now I'm seeing that actually I have another problem with this particular dump. In fact, if I hover in this area, it's telling me that this is a deadlock. I know that's kind of small, but this is actually a deadlock. All these kind of red icons on the left represent a deadlock. I can double click on any of these frames and it takes me directly to code, right? So I grabbed a dump from Linux. I pulled it onto a Windows machine. I then started looking at the code that each of the threads are and each of those tasks have and where they're positioned. Now I kind of can use the call stack window. I can use the command window, immediate window. I can use all these tools that I've grown accustomed to really, really quickly. So hopefully today I kind of demonstrated a couple of things. Basically, auto heal is your friend if you're in a situation that you can describe as slow. If there's a situation you can describe as too many errors, you can use auto heal to kind of walk through that scenario and produce something that will help you make connections to code. You can also start that analysis directly in the portal using a memory dump, and we'll analyze that. And in fact, we're going to be doing some analysis for traces in the Linux environment in the next few weeks and months. We also showed you how to connect these diagnostics findings to your code in GitHub or wherever you are hosting your code. And also I've shown you the improved collection and observability powered by .NET Monitor. And as I said, we plan to do more updates for trace analysis in the near future. I'll hand back over to James.
Thank you so much, Mark. Yeah, I agree with Tony here. It's a great tool for debugging and improving the application. Maybe we'll have to use this for the cursor issue. So just so everyone knows, like the cursor issue is a thing with sharing screens. Just today, we were working to get that resolved. But great session. We have a bunch of questions, and I think we have a couple minutes, and so we might be able to get some answered here, if that's cool with you, Mark.
Absolutely.
Awesome. So we'll start with Jay's question. Does source linking and diagnostics work if you obfuscate your code?
That is a very good question. I don't think it will. I think the point here is that the PDB is going to have enough information to make a direct connection. I think if you've made explicit changes so that you can't make that connection back to your source because you're trying to protect the intellectual property, then this probably wouldn't work for you. Yeah, so I don't think that would work in that scenario. I think if you're obfuscating your code, you've kind of made the decision that you don't want to you don't want to make that connection.
How about Awald here? Does the issue link back to the prod debug artifacts so folks reviewing your fix can examine the context there as well?
That's a really good question. So I think what I'm hearing there is that could you also link the diagnostics artifacts you're collecting, like the dump or the trace? That would be really, I think that'd be a great experience. In fact, I think Awald is giving me some good ideas to present to my team. No, I love that idea. The idea of being able to, because ultimately what you want to give a developer is as much information so that they can be strong, can feel confident about the fix that they're making. And often I think the problem with what we have with production diagnostics is that you're left kind of guessing because you're not at the break point and you're not your confidence level. So the idea of being able to kind of save the session information, maybe as a snapshot, even smaller snapshot, and maybe allowing them to rehydrate that is a great idea. Thanks, Ewald.
Jeremy says, awesome presentation, Mark. And he also asked a question on, is this similar to debug diag to show the issues from the memory dump, like sync over async?
It's same principle, yeah. Debug Diag is a great tool developed internally here at Microsoft, and I think a lot of people have access to that tool as well. Debug Diag is fantastic for trying to help you orient yourself in a memory dump. And basically, I think of memory dumps as a mystery wrapped in an enigma. You kind of almost, like, it's tough to know where to get started if you're not used to it. So tools like Debug Diag that Jeremy is bringing up here are fantastic for giving you that initial opening step. And they have a bunch of analyzing in here. And we've kind of just used this diagnostics analysis report as kind of another iteration of that. How can we help customers get started with this thing? We know there's rich information in there, but we also know it's sometimes a bit difficult to kind of get the steps to get into that information and then share it with other people. So yeah, Debug Diag is a great tool. WinDBG is a great tool if you have it and are good at it. But also diagnostics analysis is in Visual Studio and in the portal now.
We will have time for one last question here before I pass it on to our next session. So is it possible to change web app config without restarting?
I don't believe it is. I think the configuration files are stored in memory. And so ultimately, when it sees a change, it is essentially instructed to update to what you've changed it to. So I think there's two types of resets that happen. There's a soft reset that can happen, meaning your customers should not see significant downtime. But I think for a certain class of configuration changes, a hard reset is essential. Maybe the changes, I think a hard reset is essential for some scenarios. And so I think there's really not a way around it. What I would suggest, if there's things that you're changing that regularly, maybe you should consider putting them in a different type of configuration file or a different file altogether away from your configuration so you can read it when you need it. Yeah.
Awesome. Thank you so much, Mark. I really learned a lot through your session. Have a great day.
Thank you.
Just a reminder for everyone, you can check out the agenda here to see what's coming up next. And please like, subscribe, and follow, as I gotta say, to Azure Developers on YouTube, on Twitch, on Twitter as well, because we're all over there. And ask your questions live, and so during the sessions, we will get to them at the end. Up next, we have highperformance.net with gRPC and Linux App Service. And so I'm going to bring up Byron here to walk us through this. Hi, Byron.
Hey guys, hello everybody. Just taking advantage that there's that fresh question about restarting your app when you're changing config. The recommended way to do that is you have staging slots. Usually you can make the change in the staging slot. That way any restart happens on the staging slot. You don't see it in your production app, and you can do the swap from staging into production, and that's a live swap. You don't have the downtime associated with the config change. So, if you're in a dev environment where you have your own app and you're making changes, go for it. Do it all directly in production. But for real production scenarios, that's the way to do it. Sweet. So now we can jump into actual highperformance.net with gRPC on Linux App Service, and I have Jeff here with me, who's going to be helping us out. We're going to talk a little bit about App Service, set some context. I know that you've seen it in a bunch of demos already today, but I want to make sure that everybody is thinking about it in the same mindset. And then I'm going to talk a little bit about how we use .NET on App Service itself to improve and power the platform. And then we're going to go into gRPC and the demo, and that's where Jeff is going to help us out and get this thing going. Okay, so let me get my slides up and ready. And then Haley, whenever you're ready, I think we can start sharing my screen. Okay.
Good to go.
So let's say that you're hosting a cloud application. It could be like car ownership, and this is like the silly little analogy that we use. So you have several options, right? On the one hand, you can buy the car and operate it, and if the engine falls out, it's your responsibility to go do something about it. And we think of that as infrastructure as a service, right? So nobody wants to wake up on a Wednesday after Patch Tuesday to go reboot a bunch of machines and apply security fixes. But if you're on the IaaS world, that's sort of the stuff that you need to do on top of the code that you're writing for your application. At the other end of the spectrum, you have things like software as a service. Think of it as like Office, right? You don't necessarily go and tweak Office, you just use the app. And somewhere in the middle, you have platform as a service, which is what App Service provides you, right? So the whole mantra around App Service is let the developer focus on their code, and we will handle the infrastructure and the platform so that your developer efficiency is on writing the code for your business that you care about and maintaining that and not applying patches, etc. Common scenarios is, we have everything from digital marketing, transaction, line of business applications, small applications, large applications. I think the largest engagement in which I've personally had something to do with is we hosted the CBC app for the Canadian elections, which did, billions of requests, and it had over 5 million concurrent users. So, it can go from hosting a side project to hosting, large world-scale applications over hundreds of instances and billions of requests. So, whatever it is, we can handle it. Now, we have this really close relationship between the .NET team and the App Services team, and we use a lot of .NET to build the App Service infrastructure in itself. One of the latest things that we've done is we've ported a bunch of code that was in our what's called the front-end role. So I'm getting into the weeds here of the details of how App Service is built, but it's important to understand. So the Azure load balancer is when your browser sends a request to Azure, that's the gateway into the data center. And then the gateway into App Service is this thing called the App Service front end. You can think of it as a proxy that then directs the request to the actual VM where your application is hosted. And we're going to go and we're going to zoom into that. So the way this used to work is we had IaaS and we had a bunch of homebrew technology that was built by the team, because a lot of the people that work on app service used to work on IaaS before. So we were very familiar with IaaS. We were able to extend it and build those homebrew modules. But over time, it gets harder and harder to maintain if we're the only ones that know about that code, and if we're the only ones that can go debug and fix it. So that's part of the motivation for adopting some of the .NET technology that is out there with .NET 6 and .NET 7. Specifically, we were looking at YARP and Kestrel, and we were able to basically remove and replace all of the code that we had in the front-end role with the new Kestrel and YARP modules, and take advantage of .NET 6 and all of the perf improvements that are built out of the box with that. A lot of people don't know that this actually happened. So this is something that we did at the platform level, where we went and we updated each and every unit of scale of app service across the world transparently, without you even knowing that this happened. On our side, the benefit is that it's a lot easier to debug and fix issues. When we were seeing that demo from the previous slide, from the previous session, where people were taking memory dumps and analyzing the code. The difference here is when we had to fix something with http.sys on IaaS, we had to take a memory dump of all of Windows. Whereas now we can just take a memory dump of the .NET process that is hosting our code. So it's really easy to narrow down and debug issues on the front end now. This also enabled us to build a bunch of new features, one of which is what we're going to demo now and what we're going to talk about, which is enabling us to provide support for gRPC at a platform level. Some other work that we're doing in this area is we're actually, again, from previous session, you saw a lot of demos on Kudu. We're working towards unifying the code base of Kudu, that we have one version of Windows, one version in Linux, and we're trying to get everything together, all running on .NET 6. So that's some of the stuff that the team is doing internally to use .NET 6, provide the benefits of .NET 6 forward into the customers. And then one final remark, because of the performance increases that we got from .NET 6 and moving to YARP and Kestrel, that means that we can run at scale with less of a footprint on the data center. This translates to several things. One, it's a greener service, because we need less machines to do the work that we were doing before. And it also allows us to have less capacity constraints, where we're not using machines for infrastructure roles that we could be assigning to customers for use for their code. So those are some of the benefits that we saw by moving to .NET 6. Okay, so let's change gears and let's start talking to gRPC on app service. Jeff, you want to take it away?
Sure. Just start on the next slide.
Here we go.
Yeah. All right. So if you're not familiar with gRPC, it's a remote procedure call framework that streamlines messages between your client and server over HTTP2. And it does this by opening up a gRPC connection or channel between that client and server, which allows you to implement different types of calls. So you can do client streaming, server streaming, and bidirectional streaming as well. It also does this by using protocol buffers, which is where you define the service, and then that enables you to do language agnostic implementations. Now, how does it work on app service? First, the app will be configured to allow HTTP2 client request. Then that request is forwarded to the worker via the proxy. And lastly, app service requires an app setting port number that only listens to HTTP2 request. If you're familiar with app service, you can kind of tell that these look like config values that you'll need to set for your app to work with gRPC. And this is a list of the gRPC calls that are supported. So unary, server, client, and bidirectional streaming. Okay, and now we're going to show the demo. We're going to show a deployed application, unary stream example, and then also a server stream example. So if we can just switch to my screen. Right, all right. So here we already have a gRPC service application that's deployed on app service. And if we browse to the URL, it shows us a message saying that communication with gRPC endpoints must be made through a gRPC client. And then it gives you a link to go ahead and show you the instructions to create that client. But we already have one created locally. So we're just going to grab the endpoint and then go to our local client in Visual Studio. And we're going to paste that endpoint in the gRPC channel. And now the client knows where to actually create that connection. So if we start the app, and it's just a simple console app, and it gives us a message, hello from app service.net day. So yeah.
In this case, this was an example of the unary scenario, right? Where you send one request and then you get a response back from the server.
Yeah, exactly. So what's happening here is the client is sending that request, and then the deployed server is actually listening for this request on a specific port number that we set, and then it returns this message.
Awesome. And then can you show us some of the stuff that you did to configure the web app? Because you had to do something on the app service side, right?
Yeah. So if we go back to our web app, and if you remember from that slide, I noticed that, or I mentioned that there's 3 config values that you need to set. If you go to your configuration, in your general settings, under platform settings, you'll see HTTP version and HTTP 2.0 proxy. So the first setting that you have to set to 2.0 will configure the app to allow incoming HTTP 2 request. And then the second one that you'll set to on is going to make sure that the front end forwards that traffic to the worker. And
so here's where we're seeing the actual changes that we did on the front end that enabled this traffic to flow.
Yeah. And then there's one more that we have to do. It's set the application setting to this HTTP 20 only port. This makes sure that your app has a specific HTTP 2 only port that it's listening for. And that's how that connection is made. In our case, we have a value of 8585. And if you actually go to the log stream for the application, you can see that it's listening to 8585. So that's how you know that your gRPC server is ready to take requests.
So in this case, the ports that are publicly exposed are still going to be 80 and 443. But then as the traffic comes in, it gets routed to the local port, which is 8585 on the particular VM where the traffic is being received, correct?
Correct. Yeah, and
Awesome.
that's a port number that we define.
Cool. And then is there anything that you have to do on the client code or on the server code that was special for this scenario, or did just the templates that come in with Visual Studio, was that enough?
Yeah, so in this case, the server code was one that we used from a templated Visual Studio gRPC service. If it's your first time going through this process, you're likely going to use this template. And there's a couple things that need to be addressed. First, you'll go to your properties and launch settings, and you want to make sure that this launch browser property is set to true. And essentially, this is going to make sure that your browser is launched properly, and it shows us that initial message that your client needs to be a gRPC connection. So that's one thing that you need to do. And then the second one is actually in the app settings. This Kestrel configuration code doesn't need to be there. App service is already aware that your protocol is HTTP2, so you can remove that. If you left it in, it might cause an issue with your launched browser. So we like to comment that out. But that's all you need to do on the code side. And then you can deploy to app service, as long as you have those 3 config values set.
Awesome. And then you said that we support 4 of the scenarios. Can you show us another one?
Yeah, so we support server streaming, client streaming, and bidirectional streaming. We have a server streaming example that we can show. And here, this is a server streaming client that is currently pointed to a gRPC server stream app that's already deployed. And it's simple. It has a for each loop that just continuously keeps that connection open. So it'll send a request to that gRPC channel, and then the server will stream requests back. So let's go ahead and run it. Right. And so what's happening here is the client is sending a request through the channel. The gRPC server is then streaming replies over a single gRPC connection until that loop is finished. And the reply coming back from the server is hello from app service.
Awesome. So in this case, instead of making 1 request for every line there, we make 1 request and we let the server send back, whatever data as it's happening. Yes. And the benefit here is that I have less overhead, right? Because I don't have the overhead of establishing the connection, having the conversation, terminating the connection, then starting it again.
Yeah. Yeah, so that's the server call, and that's the end of this particular demo. If you want to use these code samples, we do have a link at the end of the deck that will have the link to the repo, so you can try these out yourself as well.
Awesome. So let me get the slide up, and then maybe we can show that. And I think we have a couple of things here. One is we have the blog for gRPC with .NET that goes into a lot more detail than I can cover during a quick session. That's the heavy lift blog. We have the how-to articles that were written by Jeff, where you can go get the sample code and play with it. I guess one thing that we forgot to mention is this is currently supported only for if you're hosting your web app on a Linux. It can be either bring your own code or bring your own container scenario. We know that there's interest to support this on Windows. We need to do a little bit of work to actually update the OS on all of our Windows workers, and App Service is a huge service. It takes us a little bit of time to go roll that across the world. It's something that we want to do. It's in the backlog. We'll get there. And then we have the link to the App Service team blog. This is a blog that is put together by the actual engineers on the team. So you're getting the unfiltered real content here. And then finally, we have the App Service Twitter handle. You can use it to interact with us. And I'm going to take advantage. I'm going to plug in that we also have a tech community, a monthly community stand-up for App Service. We've had 1 episode. We have the next episode happening tomorrow. So follow us on AC App Service and get all the details about that as well. So with that, I think we can switch over to Q&A.
Awesome, thank you. So we have a lot of questions on why gRPC versus something else. So I can start just listing some if we want to talk about that. So we have why gRPC instead of WebSocket or just a normal conventional REST API.
So let's start with the REST versus gRPC. In general, I think they solve different scenarios. REST, the biggest benefit of REST is that it's human readable. So it's very easy for you to just curl something from the command line and see the conversation and see what's happening. The side effect is that it doesn't support streaming. It doesn't support the bidirectional streaming. And you have a lot of overhead of 1 request, 1 response, it gets complicated when you need to do batching, etc. So I would say if you're exposing an API that is going to be publicly consumed and you don't control the client, REST is a good idea if you're willing to pay the overhead of the conversation that is happening over REST. gRPC is more geared towards the better examples are the streaming and the bidirectional streaming scenarios where you don't want to have the overhead of the connection, and you have a lot of data to move back and forth, and you control both the server and the client. That makes it so that it's a lot more efficient. You can throw more bytes over the wire that are actual payload versus the overhead of the connections. Jeff, I don't know if you want to add anything to that.
No, otherwise it's, if you have to communicate over HTTP2, that would be a scenario, or if you need, to get that higher performance.
Yeah, and on the WebSocket side, we do support WebSockets on App Service. I think the difference here is around the platform support that exists, and how easy is it to write a WebSocket application properly versus how is it to write a gRPC application properly. Honestly, I think perf-wise, they're going to be similar. I don't think there's going to be a huge difference going with gRPC, but the community support and you're not alone when you're writing the gRPC app. I think that's what it comes down to.
We are putting the demo repo that Jeff showed into the chat as well, so you have access to that. But those are all the questions. If you all have many more questions, please put them in the chat, and we'll make sure we get to them. But thank you so much, Byron. And yeah, as you had mentioned, we will be having another live stream. And so what can we anticipate learning tomorrow?
So that one's going to be a different direction from what .NET developers would probably expect. So we're going to be talking about WordPress and App Service. So this is PHP. And WordPress happens to be one of the most popular CMSs in the world, and people use it to host and run large-scale applications. And being able to host WordPress on App Service at scale and with an out-of-the-box configuration that will scale with your needs is basically what we're gonna go talk about.
Awesome. Well, we want to make sure that everyone gets a chance to go grab some coffee or take a 5-minute break. And so we're going to break for 5 minutes before we end our app development segment of .NET Day. Thank you so much, Byron. Thank you, Jeff, for the wonderful demos. This is awesome.
Thank you, everybody.
Thank you. Hey.
Join us back in 7 minutes to start the next session. Thank you. And welcome back. I hope everyone had a chance to get their coffee or just a quick break for the next session, which will be the last one in the app development section before we move on to cloud native. So I'm going to welcome Nikita, who's going to be talking about identifying performance bottlenecks with Azure load testing. Hi, Nikita. How you doing?
Hi, Haley. I'm doing good. How are you?
I'm great. Thanks.
Yeah, so today we are going to talk about identifying performance bottlenecks with Azure load testing. And let's see how to do that. So first of all, why is it required, right? Azure load testing helps you identify performance bottlenecks, but why is it required for you to identify these performance bottlenecks? So as we know, performance issues are very performance issues result in a lot of revenue losses. Like, for example, as you can see here, Amazon says that it has lost almost $100 million in revenue in just 1 hour of downtime in the Amazon Prime Day sale. And we've seen a lot of examples where by having some performance issues when there's a lot of load during peak season, for example, a Black Friday sale or holiday shopping season, a lot of customers face a lot of issues if there's not enough performance and if their websites cannot handle the load that is required at these peak events. So performance testing is very important for you to make sure that you're able to give your customers the right experience that they would want from you. So Azure load testing helps you generate high scale load and also identify performance bottlenecks. Uh, so let's see how Azure load testing and what are the key value propositions that Azure load testing offers and how you can use it to load test your applications. Um, so you can prepare your application for the production environment and make sure it is able to handle the high scale load with ease. So you can get started with Azure load testing with no code experience, and you can just start running tests and test your application. And you can also use your existing JMeter script. Now, Apache JMeter is a widely used open source tool which you can use to load test your application. So you can only just run your load testing scripts, which are the JMeter scripts on Azure load testing, and it runs with ease. You don't have to manage any infrastructure. All of that is taken care by Azure load testing. We provision all the VMs that are required for you to generate the high scale load, and you don't have to worry about provisioning, deprovisioning, or managing any of the infrastructure. You can optimize your performance at scale by looking at all the analytics and metrics that are provided to you by the service. So you get a single view of both the client side and the server side metrics in a dashboard, and you can very easily correlate what happened and during the test and what went wrong for you to identify if there are any issues that you could resolve. While we talk about load testing for a very specific event during a peak season, it's also important to catch these performance issues very early in the development lifecycle. So, leveraging the shift left strategy, it's important that if you identify these even before the issues go into your production, that's the best way where you can catch these performance issues and avoid any regression. So it's good that you are able to also integrate Azure load testing into your CI/CD workflows and make sure that the code that goes into your production environment is the quality that you want it to be. So how do you do this in Azure load testing, right? So you can generate high scale load very easily without having to manage any infrastructure. So you can just provide your JMeter scripts or just provide a URL for a URL based test, and this engines are provisioned by Azure load testing, and these engines are used to generate load to your application. Now, your application might be deployed anywhere. It could be on-prem, it could be in any other cloud, or it could be on Azure as well. If it is on Azure, then you get a very a comprehensive dashboard with all the server-side metrics as well. So what we do is, if, for example, your application is on app service or Kubernetes, and you have a database, you have a storage account, we pull all the server-side metrics from Azure Monitor for these application components, and we provide you a single view dashboard for all the server-side metrics as well as the client-side metrics that JMeter provides. That makes it very easy for you to correlate and identify if there was any performance issues when the load increased, or if there was any breakpoint that your application reached. It's very easy for you to test if your application is on Azure. So you get this frictionless testing and a single view of your metrics. So talking about metrics, you get deep actionable insights and recommendations. You would be, after the test, you would be able to identify which part of your application is a bottleneck and is causing any performance issues. You can go and make sure that you, for example, increase the SKU or increase the course if it's a VM, and make sure that it's able to handle the load that you expect it to experience, right? So you can also compare your tests across time and see how, if there was any regression, how your performance changed over time in different test runs. Coming to the CI/CD integration. So you can, we have integrations with GitHub and Azure pipelines. You will be able to add a small task in your workflow, existing workflows, and make sure that you can set some pass or fail criteria. Based on the pass or fail criteria, the pipeline or the workflow is passed or failed, and this makes sure that you can take some action based on the results of the load test. For example, if your load test did not meet your expectations or the thresholds that you have set, then you can fail the pipeline and make sure that you don't promote this code into production. You only promote when it meets your performance expectation. So that automation can be done by integrating into a CI/CD workflow. Let's take a look at a demo of Azure load testing and how you can do this in Azure portal. So today I'm going to demo a .NET podcast application. So this is a simple .NET podcast website which you can explore. There are a bunch of podcasts here. You can go and listen to podcasts. So we are going to load test this application today. So getting started with Azure load testing is really simple. You can just give the URL. For example, since this is a website, I can just say create a quick test. I can give the URL of the website. I can say how many concurrent users I expect. For example, if I say I want to test for 50 concurrent users and I want to test for 120 seconds, I can give a ramp up time for the load to ramp up gradually, and I can just say run test. So that's how easy it is to get started with Azure load testing. While this is very good for you to get started, experience how Azure load testing works, you can really unlock the potential of the service when you have an existing JMeter script. I have also prepared a JMeter script for this website. So looking at the JMeter script, this is what the test script looks like for this website. So as you can see, I'm testing 4 different pages. I'm testing the podcast page, the home page, the discover page, and the search page. I can add requests for each of these and load test all of these during my test. Now I can also add a CSV data set configuration. So basically I can provide input data to my request from a CSV file. So this makes sure that you can have a input data configured and you can provide that at runtime to the request. While that is how I can provide data, I also can write some custom code which can extend the existing functionality of JMeter. So here, for example, I have written a custom function, which is and basically a function which grabs the environment variable. If it is present, if it is not present, it uses a default value. So for my here, I have given a environment variable for the URL of the page that I want to test. And so this function is a custom function that I've written. And I can use the custom function as well. So any custom code as well can be used with JMeter and Azure load testing. So this is what the test plan looks like. Now, let's see how you can run this test plan in Azure load testing. So you can just say upload a JMeter script. So you can create a test by uploading your existing JMeter script. So we will name this as .NET podcast JMeter test. And I go to test plan. Now this is where I upload all the files that I require for my test to run. So I say select, and I have my JMeter script. So this is the JMeter script that we just saw. I say upload, but then we had bunch of other things as well that we had configured. Since we saw we had configured a CSV input file, I can also select the CSV input file here. And when I select a CSV input file, I can also choose to split these between engines. Now, if I have multiple engines that I want to scale out and generate high scale load, then I can always split the CSV files into these engines so that each engine has a unique row. This is helpful. For example, if you have a login scenario, then you don't want credentials to be repeated across different engines. So you ideally would want to split your CSV among these different engines that you are using to generate load. We also saw custom function. Now, custom function in JMeter can be written and uploaded as a jar file. So I have written my jar file and I can just say upload here. And when the script runs, then this jar file is used to execute the custom function. So I have uploaded all the files that I need for my test. So going ahead, I can now I can just create a test, but let me configure some more additional parameters. So we saw a custom function which grabs the environment variable. So I'd like to set my environment variable. Now I want to set the environment variable to the for the web app, which is the URL of the test website that I'm testing. So we saw the .NET podcast website, and this is a publicly accessible website. But I have a version of it which I've deployed, and this version is not publicly accessible. So I have configured access restrictions on this website. So you can only access this from a virtual network. So let's see how to do this private endpoint testing using Azure load testing. So so I will grab this and I'll say, yeah, so I say this is my .NET podcast, which is a private network, private endpoint. So I'm going to load test this private endpoint now instead of the publicly accessible one. So I provide this as the web app URL. And now I can also provide secrets. Secrets are if there are any sensitive parameters that you want to provide. For example, if there are any login credentials, there's any authentication token, you can always provide that in a secure manner by storing the key, the secret in a key vault and just providing the secret identifier here. Since I don't have any secrets in my in my test. I'm going to skip this. Coming to certificates, now some websites require you to have client-side certificate for authentication. My website requires a certificate, so I'm just going to give the certificate name. Similar to the secrets, the certificates also are stored in Azure Key Vault, and they are securely fetched and provided to the JMeter engine when the test is run. So I can provide my certificates as well here. Now coming to load. Load is where you can actually uh, scale out and basically generate very high scale load. So as you can see, you can generate, you provision from 1 to 45 engines, and each engine uh, will multiply the number of threads that you have mentioned in your JMeter script. For example, if I have said mentioned 100 threads in my JMeter script, you can multiply that. For example, I say 5 engines, then it multiplies across these 5 engines, and I get 500 virtual users running requesting running requests on my application. So that's the load that I'll be able to generate using this engine. So this is the beauty of having it in Azure load testing, where you can just scale out just by one click, and you don't need to manage all these 5 engines that you need to generate the load that you want. So it's as simple as selecting how many engines you want here, and Azure load testing takes care of provisioning, deprovisioning, and managing these engines for you. So once I select the number of engines, now remember we said it's a private network. So we can select if it is a private or a public network. So I have a private endpoint that I'm testing, so I can always select private, and I select the virtual network is which has access to the to my application. So this is the demo podcast VNet, which has access to the website that we saw, and then I select the subnet, which is configured for access to the application. So it's as simple as selecting the VNet and the subnet here, and you would be able to test a private endpoint as well. Coming to the test criteria now, I might have some performance expectations for the application that I'm testing. For example, I might say that for my application, I don't want the response time, the average response time, to be greater than say 10 milliseconds, right? So this is where you can define your test criteria. So you have a bunch of metrics that you can select from. Say, for example, I say my response time, and you can select if it's average, minimum, maximum, or any of the percentiles. I'll say average. If it is greater than say 1,000 milliseconds, then I won't like to fail. Now you can also specify this for a specific request. As you can see that I have 4 requests in my JMeter script, and I want to set this for my podcast page. So you can always select which request you want to set this uh, test criteria for. And similarly, you can do that for any of the test requests that you have, and for any of the metrics that you want to do. What happens at the end of the test is, once the test run completes, we evaluate if this criteria is true, and if it is true, then it would fail your test, giving the test result as failed. This means that you can go and look into what failed and why it failed. This also helps in an automation scenario where you would, if, for example, if you have integrated in a CI/CD pipeline, then you can always fail the pipeline and make sure that you take proper action before you deploy your code into production. Coming to monitoring, now this is where if your application is hosted on Azure, you can view the server-side metrics for your application. So I have a demo podcast application, so I would just say I'd select the resource group, which has all my applications. So I have app service, storage account, and I have SQL DB. So I select all of these, and that's it. This is all that you have to do for you to be able to view the server-side metrics of how your application performed during the test. So once you have all of this, you can go ahead and create a test. And once the test is created, the test run starts as well. For this demo purpose, I'll take you through a test that I ran some time back. So this is the same test that we have configured just now. So this is a test run. As you can see, this test run ran with 5 engine instances, and the test result says failed. The test status is completed, so it is done. Now you can see that I have statistics for how my application performed during the test. This was a total load that was generated. Those were the total requests. It ran for 6 odd minutes, and the response time for the 98th percentile was 96.61 seconds. The close to 4 or 5% error rate, and this was the throughput of my application. Now, I had set certain test criteria while configuring. As you can see, I set the response time, average response time shouldn't be greater than, this is my threshold, which is 10,000 for the podcast page. The actual value was quite more than that, and we'll look at why this was so high. So we can see that this criteria did not pass, and the other one was error percentage for the um, aggregate requests, and this was below what my threshold was, so this passed. As since one of these has failed, the test result has failed as well. So this helps me identify that there was something wrong, and maybe I'd have to go and dig deeper into what went wrong. So let's try to understand what might have gone wrong. As you can see, this was the load that was generated. The response time also kept on increasing as the load increased. At certain point, there started errors we were reported, and we can see which error type. These are 500 errors, so there was something wrong in the application side. And at a certain point, as you can see, when the load really ramped up to the highest peak, we also see that the throughput really reduced. So my application was not able to handle that many requests. So I can go now and look at the server side metrics for the components that I had configured. As you can see, uh, the app service, this is my app service plan. This all looks fine. The requests, uh, I can see the CPU percentage is low, the memory was low. So it doesn't look like my app service was a bottleneck. So let's look at my DB. So I had a DB SQL Server database for my application. And as you can see, at certain point, as the load increased, my SQL Server database CPU percentage really uh, shot shot up, and as you can see, it was 182, more than like 150, 184%. So this is something that is not really a good sign. So maybe this could be an issue. As you can see, there was not much other issues with my say storage as well. So this is how I can identify that maybe there was an issue with my SQL DB, and I can go and look into what can be done. Should I increase the cores, number of cores? Should I upgrade my SKU? And I can take action based on this. So this really helps me identify where exactly which component is creating the bottleneck, and I'll be able to fix that, and I can run a test again and see if that solves the issue, and I'm able to get a much better response time and throughput for the load that I'm expecting my application to experience. So in this way, you can test your application, identify where exactly which app component is causing the issue, and you can identify exactly what is the bottleneck, and you can fix that and make sure your application is able to handle the load that you want it to. So yeah, here I'm switching back to the deck. Here, these are some resources that you can take a look at. So you have the product page for Azure load testing. We have documentation with a lot of how-tos, tutorials that you can refer to. We have blogs that we regularly publish with scenarios that would be interesting for you to see if that is your requirement, and use those scenarios as well. And we have a feedback forum. We'd be happy to listen to what you feel. If you have any issues, concerns, any feature requests as well, we'd be happy to take that. You can also explore Playwright testing for web UI testing. So you can explore the documentation, the Discord, and the Twitter for Playwright. And yeah, over to you, Haley.
Thanks so much, Nikita. That was awesome. That wraps up our app development segment of the .NET on Azure Day. And so we're going to be moving into Cloud Native next in just 4 minutes here. And so we can bring up the agenda again here to look at the rest of the day. So you can follow the agenda on the link here. We have covered the diagnosing complex code issues with Mark. And then we moved through the high performance with Byron and Jeff, and we've moved through the next one. And so we will be moving on to the cloud native, learning how custom reverse proxies for .NET containers with YARP works with Miha and Karel next. So we are looking forward to that. Please follow all of our social medias and YouTubes here, as we had mentioned previously. And I saw a couple comments in the stream here. We do have a live stream with Byron tomorrow on App Service. And so each month we host several different Azure services, live streams, just product updates, what's new, what's happening. And we are always looking for feedback and to connect with the community. So it's a great way to learn who's developing these products and services, get your feedback, listen to. We are always happy to answer these questions live and really connect with you and understand what you're looking for and answer questions on how to use these services so you can really get the most out of it. Because our goal here is to make sure that these products serve you and they work best for what you are doing. And so if we are not reaching those goals, please let us know, and we're going to keep improving and getting better. All of the links to our social medias and Twitters and streams are on the link tree linked here below. So please check that out so you can get connected with us and with all the developers working here at Microsoft. Let's bring up the resources next, just to reference here. Oh, perfect. Thanks, James. So we can check out this site here if you'd like to learn more resources. We've linked a lot of things throughout the decks here. So all of the recordings will be available, posted in the next coming weeks. So if you miss a session, it will be available, as I'm sure some people might have lunch breaks or things like that. But everything is available on our YouTube here. And so there's lots of resources at this link below. So you can access all of the great demos and things that we are sharing today. Anything else you want to add, James? Sorry.
No, I think you're great. Let's maybe just head over to Karel and Miha, if that sounds good to you.
Yeah, we can get started early here if y'all are ready.
Awesome.
All right. Hello, everyone. My name is Karel Zikmund, and together with Miha, we will be presenting today about YARP and custom reverse proxies for .NET containers, how you can do them with that. So let's get started. So what's YARP? It's an acronym. There's two actual explanations. We like the yet another reverse proxy. You can as well call it YARP is a reverse proxy, the typical one. We're on GitHub.io where you can check us out. And I'm gonna as well very shortly answer the question, like, why would we build yet another one? Like, even especially in the name. Actually, the key reason is that we wanted to deliver, we saw the need from customers to actually have something highly extensible in a reasonable way, code first, via code, very customizable, and we don't see any reasonable offering out there. So that's where we try to fill in the place, and using .NET and C# for that. We're open source, so you can find us on Microsoft/reverse proxy. And overall, our reverse proxy is a layer 7 proxy, which means that we terminate the requests that come to us. For example, if it's HTTPS, we're going to end it, and we're going to reissue new requests. So the same, private keys and stuff will not flow past the reverse proxy. You might have heard about other popular reverse proxy in the industry, Nginx, HA proxy, Envoy, Ocelot. Again, what distinguishes us from those is like in those, when you do customization, it's usually like config first, and like when you do customization, it's usually like either C++, Lua, or kind of some type of scripting. Our yet another reverse proxy, our YARP proxy, was actually designed with extensibility and customizability in mind, and C#.NET is the language that we used. So let's look actually a little bit what is a reverse proxy in case you're not quite familiar with that. So imagine that you have this public internet that's hitting your endpoints, and the reverse proxy is basically a choke point or a public endpoint that you're gonna expose, and you're gonna hide all your servers behind it. So that's what we have on this picture, right? Reverse proxy is there, and you have like multiple services that you're gonna expose through kind of different APIs via the reverse proxy. We have the woodgrovebank.com. Hopefully, it's a fake name like Contoso and nothing existing. But you can imagine that you have like different names, different services from different teams, something large scale. Reverse proxy is something that kind of puts it out. Obviously, it doesn't hide only that. It can do things like load balancing. It can offload stuff from your servers like authentication, encryption, compression, caching, anything you want. So that's it. And we can actually look at a little bit more. What else can reverse proxy do to you? For you. So here's actually a list of the classic things that you can see from reverse proxies, that you can use them. Like either it's load balancing. So imagine that you have multiple services or multiple servers that can scale out, and you want to kind of make sure that they get equal share of stuff. Like pretty simple. All reverse proxies do that. A/B testing is another popular request. When you imagine that you have a new version that you would like to test out, but you're not quite sure, maybe you're kind of testing if users like this web UI or that web UI or menu or how something works, or you want to do version rollout, right? You have a new version and you slowly want to kind of take it out, because if you put it out there and you made a mistake, it would blast all your users, maybe render your service not working. That's not good. So for that, reverse proxies are useful. Other benefits, health checks, either active or passive. Active, that like reverse proxy pings the backend server, or passive, that it monitors like which request kind of succeeded or failed and whatnot, and kind of keeps track of that. And if the backend or specific machine seems to be a little bit too unhealthy or not responding, maybe timing out, then you're gonna send less traffic or eventually kick it out entirely. So again, all the goodness that you get from reverse proxies. The other thing actually I alluded to in previous slide is kind of API management. But basically, you have the choke point, the public endpoint of the API. And over there, you basically can have consistent API, and whatever you do on the backends, if you split services into two or in microservices, or if you create some kind of deep nesting over there, it doesn't matter, because everything is hidden behind the reverse proxy. So it kind of creates this indirection between the URL space or the public API and whatever is on the backend. And as I mentioned, offloading to the back from the backends, that's another useful thing. So let's look actually at some advanced scenarios. And we believe that some of these, not all of them, are unique actually as well to YARP. So one interesting thing that we saw is, for example, authentication migration. We saw customers having multiple services. Maybe they bought a company, a bunch of services came, or over time there was like separate services. They decided to kind of have unified endpoint for their like APIs or for the company. And suddenly they're facing like, oh, they have different authentication and it's hard to migrate the services. So they basically put new authentication on the reverse proxy, which handles the authentication and then just talks with the old authentications to the services, and they have more time to upgrade. Another interesting one is the cloud to on-prem communication. So normally on-prem in enterprise scenario, if you're on premises, you can go to the cloud. That's easy, right? But the cloud cannot come to you because you're hidden behind the firewall. So sometimes you want to punch a hole and basically say like, hey, for this specific machine or maybe set of machines, I want them to actually be able to reach out back. Something like VPN, but you don't want to set up VPN for whatever reason. So that's actually doable today with, for example, with YARP. It's 100 lines of code. You want to make it more streamlined in future. Other things which are, again, more traditional things are Kubernetes or Service Fabric ingress controls. For both, we have plugins. Kubernetes is still in beta. Service Fabric is actually used by a couple of customers already. And we're going to show later on, in the second demo, actually .NET Framework migration to .NET Core, which is a little bit unique to .NET. And that's actually where YARP, even though it was not designed for that, actually shines quite well and allows you to slowly migrate, components from one framework to the other. And with that, actually, I'm going to pass the word to Miha, because he's going to show the first demo, which is going to be about app services and how you can do discovering of new services. So, Miha.
Hey everyone. So for this demo, I have two services running in Azure App Service, and I want to expose them in a unified way. For example, I want one endpoint that users will connect to, and then if they, for example, put /todo in the path, I want that request to be handled by my to-do service, and if they go to /weather, I want that to be handled by my weather service. So let's take a look at how that actually works with YARP. In here, I have a few projects. This is the to-do service. It's a very basic ASP.NET Core project using minimal APIs. You can get the list of all the to-do entries, or you can post an update to them. Normally, you would use a database here, but for the purpose of sort of the demo, I'm just using a dictionary. It's all in memory. And then the other service, I have a weather app. This is something that most of you are probably familiar with. It's just the default template whenever you create a new ASP.NET project. Now, how do I get that to work together with YARP? So I've created a new ASP.NET Core project, and I've added the YARP reverse proxy NuGet package to the package references. Now, as with many other packages, how to actually include them in your project, you would add something to your services. In this case, we call add reverse proxy to register everything in DI. And then we call map reverse proxy to register all the middleware. Now, YARP configuration can come from anywhere, be it config, for example, config files. But for this demo, I want to show how you can actually generate the configuration dynamically at runtime via just code. So I have only 2 services right now. I could hard code them, but I might have 10 services later on. So I would like that discovery of those services and the configuration to happen automatically, and I just have to write the code once. So to do that, I'll use one of the extension points that YARP offers me, which is the iProxy config provider interface. And that gives me full control over creating the configuration as I want. If we look at the implementation, I just have a timer, and every 30 seconds, I'll reach out to the Azure Resource Manager API to get the list of all the web apps running in my resource group in Azure. And I'll take those names and hosts, and I'll generate the YARP configuration that corresponds to them. And once I have that list of routes and clusters, I'll call an update method on my configuration to take all those objects and recreate the configuration, reload the routes, and YARP takes care of all of that. Now, all the details about what you can configure in code and configuration is explained in a lot more detail in our documentation, and we also have a few more samples available on our GitHub. But for this demo, all I'm doing is I want my service, for example, to be reachable at /todo. So I'm specifying that the route begins with a / the name of the service URL. And then as the cluster, I'm defining the set of destinations that I want the YARP to proxy to. In this case, I just have one destination. So I'm creating a dictionary with just a single entry, which is the host of that service. So I can now show. This is the YARP application that I've just shown, deployed in Azure Web Apps. If I now query the /todo endpoint, I will get a response back from my to-do service. And if I query the weather endpoint, I will get back a response from the weather service. And if I added a new service now, it would automatically get picked up by this configuration and get automatically loaded. Now, it might seem silly to write this code for just 2 destinations, But you can imagine that you can pull this information from anywhere you could imagine, and you have full control via code. And something that Carl mentioned is that you can also use YARP as a Kubernetes ingress controller. Now, how that is implemented is actually pretty similar. It's also implementing the iProxy config provider interface, but instead of fetching information from Azure Resource Manager, it's talking to the Kubernetes API to get the list of ingress resources that way. And with that, I'll hand it back to Carl.
All right. So speaking back about YARP, so what you saw from Miha, we as YARP are a library. We are not an executable. It is something that we want to do eventually, but it's actually not our primary goal. So it's a library that you can kind of create in your ASP.NET application, and you can customize it. You have seen actually customization even of the configuration and whatnot. We have many and as you heard, actually, even the Kubernetes is using the default customization and extensibility points. So it's not something special that we would do for Kubernetes. We just have to go and implement certain interfaces and grab the information from somewhere. Right now, at free releases 1.0 to 2.0. And as I mentioned, extensibility in C#, we have seen that. We are designed layered. So there's a bunch of layers. You can actually use two types. Either you have the default route, when you have health checks, you have the routing, obviously routing, health checks. Then you have things like transforms and whatnot. And then you eventually issue the request somewhere else. So there's basically a huge, not huge, but a pipeline that you can follow. There's as well advanced mode, which actually a couple of largest services we're going to talk about later use. When you can basically say I don't like this kind of pipeline because I have even more demands. I want even more extensibility. I'm just going to use parts of that and reuse parts, so they can actually build their own pipeline and just use hey, I'm going to send a request over here. And in their own pipeline, they can leverage bits and pieces, for example, health checks, and they can replace all the rest, or they can only use routing and stuff and do their own pipeline. So highly customizable, layered for general reuse. We are cross-platform because it's .NET, Windows, Linux, all free platform, all free architectures. It makes sense. Again, Mac is not here because I think it actually might work on Mac, but the primary is server-side. Mac is more for development, right? We have a great perf, so you're gonna see this as well testimonies from our top customers. But we're highly comparable actually with other reverse proxies. We have perflab where we measure things to make sure that we don't neglect some things and some stuff. And you have as well availability of the latest protocol, so gRPC, HTTP3, or HTTP2 WebSockets with the 2.0 YARP. Most actually of these protocols, as soon as they light up in .NET, they will automatically light up as well in YARP. HTTP2 WebSockets was a small exception, and it needed few lines of code changes in YARP, but it was not that we would have to rewrite YARP or do something really magical. It was really kind of small touches. So whatever new protocols and stuff .NET is going to bring, they're going to show up automatically in YARP. The interesting thing that how we're using internal YARP is as well not only to kind of deliver to our customers, either internal customers or external customers, but we as well use learnings from it to kind of improve performance of the .NET itself, because it's a kind of high performance scenario, and we have actually now a comparison with other reverse proxies. We can see actually where things are kind of not so great and where we can even get improvements. So over the last actually 2-3 releases, you have seen a bunch of things coming to .NET itself, making improvements not only to YARP scenarios, but in general to networking and in general to .NET developers. So let's move on to next slide. All right, and that's that's actually YARP in production. So we listed 2 internal partners or customers that we have data from, the most interesting. So Upservice is one of them. So that's actually what Miha just showed. He used Upservice. Whenever you use Upservice, not only Miha, under the hood, you're actually using YARP. They blogged about that on .NET blog. So there's a .NET blog post from August 2022. So just recently, half a year, let's say. And they have lots of statistics and things that you can go through in details, but highlights is that they have actually pretty impressive RPS. It's in average, if you don't count spikes and anything, it's almost 2 million RPS. That's actually a lot. 14 million host names. They're running on .NET 6 plus YARP. I believe they have plans actually to upgrade to .NET 7 and obviously later to .NET 8. Now, why would some large service like Upservice move to YARP? So here's actually the benefits they got, and they, obviously they kind of looked at it upfront, and so are we going to get benefit or not? But first thing that actually they used to have IIS plus ARR, and on Windows and on Linux they use Nginx. So they had this kind of dual thing, dual configuration, different way. Keeping it the same was kind of a little bit not so nice. And YARP was something that actually worked the same way on both things. So that was actually one of the benefits. Including the fact that like some of the new protocols were tied to the IIS, the support, and that is actually tied to the operating system. So it took a little bit longer sometimes to get like, for example, gRPC or HTTP free. Given that .NET is user mode, like you get those things very quickly as soon as .NET supports them. Obviously, they got actually good perf improvements, 80% throughput on perf tests. So again, it's just perf tests, but those were targeted perf tests for app service. They didn't get that huge improvement in the kind of real life traffic, but it was significant enough to actually deliver some like lower CPU usage. And lower CPU usage means that obviously you're paying less money for running your service, which means you can earn more money. That's useful for any service out there. They got more extensibility, as I mentioned, and the new customer scenarios. So the protocols that I mentioned, gRPC, HTTP free, something that they didn't get before, suddenly with YARP lit up immediately. They got actually some new features from us as well, or not only from us, but by migrating to YARP, per host cipher suit configuration or customer pages and those things. So that's actually all beautiful. Again, check out the blog post to kind of learn more about that. The other team and larger service that kind of is using YARP these days is Dynamics 365. They actually announced their support in .NET Conf last year, or not last year, but year ago, year and a little bit more, so 2021 November. And as of today, actually, I updated today. I got permission to share updated numbers. If you remember what was there, probably not, but if you look at that, these numbers are actually 2 times or 3 times larger than was a year ago, which is actually pretty impressive for that service to grow. So right now they're actually at like, roughly, if you don't count spikes again, 112K RPS, 1,000 RPS, which is pretty impressive as well. Obviously, if you compare it to the 2 millions, it's 20 times smaller, but hey, like not everything is up service. Even the 100,000 RPS is pretty big service. They have 13 petabytes of data transferred per month, and actually they run kind of amazing 1,500 instances of YARP. It's kind of a couple of layers and whatnot, and they're getting kind of like a really good success rate on like 7 nines, which is again impressive availability. All that with like high scale, high performance cloud data infrastructure. So looking at that, they're actually the original authors. They are running on .NET 6, so we kind of took the code from them. We generalized it more. It was at the time when we were kind of looking to kind of leverage something or like write something from scratch. So we kind of learned from their designs what they need, and then generalize it for more customers. We have actually more partners and even external customers using YARP, Bing, and other services. We don't have data from them yet to share, but like something that might come in future. So let's move on to the next thing. So if you want to get started with YARP, where do you get started? As I mentioned, it's the GitHub.io/reverse proxy or Microsoft/GitHub.io. You're gonna hit this page where you can see there's actually the code that you can start with, the middleware. You can see it on the left side and as well on the bottom right bottom side of the screenshot from the page from the articles. It's actually very similar, or it's almost identical with what you've seen Miha showing and demonstrating, except that this one loads configuration from config file instead of having it dynamic, like he already showed you kind of some of the extensibility. Most customers actually use, well, most, depends. Many customers use the config and then kind of customize other things like, for example, transforms of headers and these type of things, or authentication and other stuff with code. You can see there's lots of topics that are like, specialized into what people might want. So health checks, tracing, code balancing, session affinity. So go and read it up. And with that, actually, we're gonna head to second demo, which is about migrating applications from .NET Framework to .NET Core. It's part of larger migration of ASP.NET migration. You can see the link below. And Miha is gonna walk you through demo. So if we can switch to Miha's desktop, screen. He will talk about the rest.
Hey again. Yeah, so it's a very common problem that our customers face is that they have services, large services running on .NET Framework using ASP.NET that they're trying to migrate to ASP.NET Core. but migrating a huge service all at once is sometimes next to impossible, just because of the sheer amount of logic that the service is using. So we have some tooling that will help you do that migration incrementally. So for this demo, I have here a .NET Framework app using 2 controllers. Now, in the previous demo, I had a similar to-do and weather service running as 2 separate services. In this case, I have those as just 2 separate controllers in the same project. So we see the same sort of to-do application running in memory and a weather controller. And then the tooling also comes with a Visual Studio extension. And I've used that extension to automatically generate my ASP.NET Core project that I'll be migrating all of my logic into. And I have that over here. I've taken the time also to migrate one of these endpoints. So I've moved the to-do controller, used all the nice features of ASP.NET Core and newer C# versions. And what I would now like to happen is that if I direct all of my traffic to the new ASP.NET Core application, I would like requests to the controller, which I've already migrated, to end up in my new application. But for example, if a request comes in for the /weather API, which I haven't migrated yet, I would like that to be handled by the old application. But I would want all of that to happen transparently to the user that actually calls these APIs. And how this migration scenario achieves that is by using YARP to proxy those requests back to the old application. So if I show here, I have the ASP.NET Core application running. And if I issue a request to the to-do endpoint, I can see that the response headers indicate that the server that handled this request is Kestrel, since Kestrel is the default web server whenever you create a modern ASP.NET application now. And if I query the weather endpoint instead, I see 2 things. One is that now the server that responded with the request is Microsoft IIS, because the request was handled by the old framework application. And also in my console logs for the new ASP.NET Core application, I can see a few entries here telling me that the request was proxied back to the old framework application. Now, how does this configuration actually look like for YARP? The tooling generated this program file for us. And similar to the previous demo, to make use of YARP, we're calling add HTTP forwarder to register all the necessary services in DI. And then we're mapping the routes. In this case, all we care about is just the catch-all route. So anything that is not implemented yet in our new application, we want to proxy those requests back to the old application. So we register a catch-all route, but set the priority to lowest, the lowest possible thing. Now, the tooling doesn't stop here. It can help you as well with, for example, sharing session state between your new ASP.NET Core and the old ASP.NET application. It can help you with authentication and so on. But this demo is just here to highlight the YARP portion of this scenario. And as you can see, we've made one call to register the services and then used 2 lines to configure YARP. And we're already getting a lot of functionality out of that. And also another thing worth highlighting here is that YARP is a library. You can add it to any ASP.NET project. So in this case, we don't have to deploy a separate service. We don't have a separate process to manage this migration. It's all happening just as yet another middleware, yet another service inside of your existing project. And once you're done with migration, you move everything over. You can just remove this little bit of configuration, and you're all set to go with the new, with your migrated app running on ASP.NET Core. And if you want to learn about more information about what this tooling can do for you, you should visit aka.ms/ASP.NET Core migration. And that should be it for our demo. And I think we should have some time to take a few questions.
Awesome. Thank you so much, Miha and Karel, as well. So we do have some questions. I know that the one and only David Fowler hopped into the chat, but it's always good to reiterate as well. So good question here. Does YARP support request response body streaming for use cases when API consumes/produces a large file?
It sure does. Yeah, you can stream large content through it, or for example, if you have a long-lived WebSocket session, all of that will just happen transparently with default configuration.
Or gRPC requests are another long-running sessions as an example. Yeah.
Perfect. And a follow-up they had to that was also if it does chunked responses as well.
Yeah, so all the protocol details, such as whether the response was chunked, it had a content length header, and so on, that's all handled for you. Of course, you have sensibility points, right? You can write code at any point in this request to modify things if you wish. But by default, if you have a compliant browser, for example, that's reaching your service, all of these scenarios will just work.
One way how to look at it, if .NET supports it, and it does and tries to support every part of the protocols, right, then YARP supports it. Like that's the beauty actually of YARP being on top of .NET, that you don't have to do your own protocol parsing and that stuff. You just rely on the networking over there.
Gotcha. So kind of the follow-up question of sticky sessions, I guess, kind of to your point there, if it supports it, and how does YARP work with that specifically?
Well, by sticky session, I think that person meant probably session affinity. For that, I actually, on the page that I showed, I actually called it out. That's one of the topics we have. Like, yes, we do support that. That's actually not part of the protocol, HTTP protocol itself. It's built on top of that. And yes, we do support that. And you can even probably customize it. Miha, do you have something to add on that?
Yeah, it's built in. It's enabled by default. And of course, as Karel mentioned, you can customize it. So you want it in a cookie, you want it in a different header, so on. You can configure anything.
Perfect. I guess also to that point, I guess if it works with .NET, it should work. So Angelo is asking here, does YARP support SignalR?
It does, yes. SignalR, if you're using WebSockets, or now even HTTP2 WebSockets, all of that will just work through YARP.
Very cool. And this is kind of a bigger probably topic and discussion point, but SNDA was asking, if you're using IIS, does YARP eliminate the need for IIS in certain scenarios?
Yes, it does, right? Because that's the benefit of the ASP.NET Core. ASP.NET Core eliminates the reason to do IIS, and YARP is on .NET Core or ASP.NET Core. So with that, unless you want to, you don't have to use IIS. Kestrel is, for the cool kids, I guess.
Cool. All right. Well, I think that we have all the questions answered. A lot of the good stuff in there, and I appreciate David Fowler, the one and only, popping in to answer questions as well. So Karel and Miha, thank you so much for the awesome session on YARP. I appreciate it.
All right. Thank
Cheers.
you.
Have a great one. Well, thanks everyone for the great questions. We are live streaming on YouTube and Twitch. So wherever you're at, don't forget to mash on that subscribe button and that like button and share with all your friends and coworkers. We're here for the next several hours talking about all the amazing things that you can build with .NET and Azure. So there's tons of stuff that has been going on throughout the day, talking about app dev and now cloud native applications. We're kind of going to get into more different topics, and there's all sorts of good stuff happening. Now, if you are interested in any of these topics, we have great resources available at this aka.ms, which we've shared throughout the day. Over here, you'll find an entire collection of live streams, episodes, documentation, all sorts of things on the different services inside of Azure. So make sure you head over to that Learn collection. There's tons of great learning modules available for anything that you need. So definitely take a look at that. And of course, don't forget to subscribe and follow, like I've been talking about. We're here on YouTube, Twitch, and on Twitter at Azure Developers, and MS Azure Dev. And we have a link tree with even more great resources. So if you're looking to stay up to date with Azure content, these are great places to go, not only for .NET, but for anything that you're building in Azure. All right, next up is another one of my favorite people in the world. I'm really excited about this as we talk about machine learning and AI and so much more. Luis is going to come on to talk about training and deploying machine learning models with ML.NET, which is super duper cool, and Azure Container Apps, which is also super duper cool. So with that, I'm going to hand it over to Luis.
Awesome. Thanks, James. Hey, folks. Super excited to be here talking to you about machine learning and how you can leverage some of the different offerings that we have in Azure to sort of train and deploy models. So with that, let me just jump into the session here and bring up the screen. Perfect. Thanks so much. All right. So again, my name is Luis. I am a program manager on the .NET team working on machine learning and AI. And if you want to contact me, here is the contact information. You can just find that on my site. So what I'm going to be talking about today, first of all, we'll sort of level set, talk a little bit about what machine learning is, AI, that sort of stuff. Then we're going to get into machine learning and how you can do machine learning in .NET. Then we're going to get into some demos, how you can train machine learning models for different types of tasks using ML.NET. And then last but not least, we'll do a quick introduction to Azure Container Apps and how you can take the model that we just trained and deploy it into Azure Container Apps. So with that, let's get started. All right, so some terminology. You may have heard different terms being tossed around, such as artificial intelligence or AI, machine learning, deep learning. So how can we make sense out of all of these terms? Well, they're all kind of related. They're sort of subsets of each other. So if we look at AI at a high level, that's sort of the overall umbrella here. And AI generally means just automating tasks that are normally performed by humans. So an example of this could be, for example, classifying spams or setting rules for your email inbox, right? So you are going through the process of applying some sort of labels or tags to your email inbox. And then after the fact, anytime an email comes from a certain person or the subject headline says something, right, it will automatically be categorized for you based on the criteria and the rules that you sort of defined. Now, in that case, AI is not necessarily doing anything smart. You're the one who's telling your email inbox or your email program how exactly things should be classified, right? So you're defining what the rules are. Now, that works fairly well, but after a while, you may find that it's very difficult to sort of write a whole bunch of if statements to try to perform some of these tasks. So you like to do a little bit better and you like to automate this process a little bit more. And that's sort of where machine learning comes in. So with machine learning, instead of you being the one that defines what the rules are for how things should be categorized or how certain tasks need to be performed, you leverage data, historical data, and representative samples of the data that you're going to be working with. And then you use algorithms on that data to try to find patterns from it. And then from that, you create a model. And this model contains the rules that it's learned based on the data that you have given it. And then last but not least, deep learning, which is probably what you've been hearing a lot about lately with sort of these large language models, right? It effectively is a subset of machine learning, and it does a lot of the same tasks. The difference being is that it uses different types of algorithms known as neural networks, specifically deep neural networks, okay? So now that you have some of the terminology down, what exactly can you do with machine learning? Well, there's actually tons of stuff, and this is actually where you often first start when you're getting started with machine learning is, well, I have a problem. Maybe AI can help me here. And so if we were to look at on the left-hand side here, there's a few examples of problems that you might have in your business or organization. For example, if you're an e-commerce site and you have a bunch of reviews, maybe you'd like to classify the sentiment of those reviews to get an overall sense of how do people feel about my products or about my company. All right. Similar with predicting ratings, forecasting sales, recommending products, identifying objects and images. These are all examples of things that you could use machine learning for, and there's tons of others. And on the right-hand side, these are examples of the machine learning tasks that these typically map to, right? So for example, in the classifying reviews example, it's a classification task for predicting ratings. Because you're working with numerical values, that's sort of regression, right? Typically, that's how you go when you're trying to evaluate which sort of task or how do I go about building machine learning applications. It's you have a problem that you identify, and then you try to map that back to some sort of machine learning related task here. So now that you, for example, identified a problem, which is, again, the first step here, what exactly does it take to build a machine learning application? And at a high level, this is the machine learning lifecycle. This is typically divided into two phases. One is the model training, which is what we're going to be doing in the first part of this talk. And then model consumption, which is I have a model now and I would like to deploy it so that others can consume it and actually start using it to make predictions, so on and so forth. All right. So if we look at the model training phase first, again, it starts with identifying the problem. What sort of problem do I have? Can I solve this with machine learning? And if so, more or less, what does this map to in terms of a machine learning related task? Once you sort of have that, then you go through the process of collecting and preparing data, which is extremely important, right? So data is at the center of all of this. So if your data is not representative, if it's incomplete, if it's actually not helpful to solving the problem that you're trying to solve, right? Then even though you could probably train a model, how well that model performs in the real world won't be very good, right? Because it's not going to be making the predictions or actually getting the correct results here. All right. So collecting and making sure that your data, that you remove nulls, that your data is balanced, those sorts of things. That's what you do in this collect and prepare data phase. Then you get into the model training and evaluation phase. And so the model training is basically, now that you have identified your problem, you have your data, and you know more or less which task it is that you'd like to use to solve your problem, right? So that's classification, regression, so on and so forth. You try different algorithms to see which ones sort of, perform the best, right? And so you train an algorithm on your data, and then you evaluate it to make sure, does my model perform the way that I would expect it to? And this is not a sort of a one-shot sort of process, right? Like you iterate on this, and as you evaluate your model, you may find, well, maybe this data isn't useful to my model, or maybe this algorithm itself is not, particularly useful. And so there's a repetitive process that you go back and forth on until you land on the model that you feel comfortable with, and that you feel and have verified actually performs as it's supposed to. Here, right? So once you're done with the model training phase, it's time to productionize that model. And so that's what we're going to talk about in the second half here with Azure Container Apps. But the model essentially is just a serialized file which contains the patterns that it has learned throughout the training process. And so with that file, you can then just use that inside of web applications, desktop applications, wherever it is that you want to sort of use it and deploy your model inside of. You can certainly do that. And then inferencing, that's just a step where you're using the model to actually make predictions. So now that you have a general idea of what AI and ML is, what the process is for building apps, what types of problems you can solve with machine learning, let's take a look at how you could use machine learning in .NET. And so a place that you might want to start is by asking yourself, what am I trying to do here? So if you want to use a pre-trained model, meaning that somebody else trained a model on a set of data, and all you want to do is focus on that consumption phase, you're not too concerned with the model training aspect of things. A way that you can leverage pre-trained models is cognitive services, right? So in Azure, you have a suite of services for speech. You have them for images. And what these services contain is just a set of pre-trained models that you can just call, whether it's using the SDKs or REST APIs, and just perform the consumption part of sort of the machine learning lifecycle. Now, one of the challenges or something that you may find is that if you have data that is unique to your business, to your organization, to your industry, right, you may run into a scenario where pre-trained models may not contain enough or may not know enough about the domain in which you're trying to use the model inside of to actually to perform well, right? And so out of the box, they'll work really well, but then once you get into sort of more niche or more specific scenarios to your use case, you're going to find that you may need to train a custom machine learning model, right? And in the .NET space, at a high level, one of the ways that you could do that is with ML.NET, which I'll talk about in a bit. And this is going to be the focus of the conversation today. So what is ML.NET? It's open source cross-platform machine learning framework for .NET, where you can train custom models, right? So you can train them for regression, classification, whatever task it is that you want to use these models for, you can essentially do that inside of ML.NET. The other thing that I sort of noted here, we'll note here, is that you can also consume pre-trained models. So if you remember, the models themselves are just a sort of binary file, right? And as a serialized file. So In that case, what you can do is if you have trained a model in other frameworks like TensorFlow or Onyx, for example, or converted to a model to Onyx, you can just bring them into ML.NET and consume them as well. So this is another way that you could also consume pre-trained models. But the focus here is that you can actually make the most of this by training your own custom models. Now, ML.NET was built for .NET developers, so because it's .NET all up, it means that you can stay within the ecosystem. You can reuse your existing skills, the tools like Visual Studio that you are familiar and productive in, and sort of everything that you're familiar with, you can just continue using that. Now, when we're going through the machine learning lifecycle, you may have noticed that some of these parts were not clear. Like, for example, which algorithms are the best? Which parameters do I need to tune so that my model performs better? How do I evaluate my model? And so there's a lot of things that you need to consider as you're training a model. But one of the things that we've tried to focus with in ML.NET is making that process easier with things like tooling and with things like automated machine learning, which helps, as the name implies, automate some of these sort of repetitive and difficult steps that are associated with the process. So data science and machine learning experience is not required. Obviously, if you have that, it helps, it's helpful. But to start off, it's not required. And then last but not least, because you're training in the same language and using the same tools that you're going to be using for deployment, the process of going from experimentation all the way into production is relatively easy. And I'll kind of show that in a little bit here. Okay, so this other point that I kind of want to highlight, again, ML.NET, because it's cross-platform, it basically runs anywhere, and it's built with .NET. It runs anywhere that .NET runs, right? So that could be cross-platform from the standpoint of it runs on Windows, Linux, or Mac OS, all the way to you could run this on premises, you can run cloud. So anywhere that .NET runs, ML.NET will run as well. So what types of problems can I solve with ML.NET? And you'll see here in this list, it's basically a lot of the same things that we sort of saw earlier, things like classification, object detection, text classification, so on and so forth. And then last but not least here, I'll sort of talk about how can you use ML.NET, how can you get started? And we offer a lot of different ways for you to get started. And this is not an either or. You can, if you feel more comfortable in sort of the code first sort of environments, right? You can certainly get started with this bottom layer here, which is just an API. And this is just a set of, .NET, C# APIs that you can leverage to build your applications from, beginning to end using ML.NET and then using code first. Now, the AutoML API layer sort of sits on top of this. And what AutoML does is it will automate a lot of the tasks like choosing the algorithm, choosing which parameters to tune. It can also help you with identifying what data transformations you need to make for your data before training your model, right? So it will automate a lot of those repetitive tasks that are part of the model training phase of the model machine learning lifecycle. And then last but not least, we have Model Builder and the CLI, which depending on which frameworks you're working in, right, can sort of take the AutoML API and make it accessible for you to not have to get down into the code, but you can just focus on solving your problem. So with Model Builder, it's a Visual Studio extension that you can use to train your machine learning models. And then the ML.NET CLI, if you're on Windows or any Unix environment like Mac OS or Linux, you can leverage the ML.NET CLI again to train these custom machine learning models here. So with that, let me jump into the demo of training a model to predict a star rating for a review, right, or product review. So let me kind of pull up Visual Studio here, and you're going to notice what I have here is just a C# class library. And what I want to do is I want to create a machine learning model. So to do that, we're going to be using some of our tooling. In this case, it's going to be Model Builder because I am inside of Visual Studio here. So if all I need to do is right click on my project here, this is my my class library, and then just click Add Machine Learning Model. Now, what this is going to do is it's going to ask me to provide a name for my model. And then we can certainly go ahead and do that, review model. Okay, and you can notice here that there's this mbconfig file or mbconfig extension. That essentially is just a way for us to store state and configurations as you go through the process from loading your data all the way to training and consuming your model. So that's what this file is for. Now, in a second here, what's going to happen is Model Builder is going to launch, and it's going to just pop up a few scenarios. So you're going to see here that I now have the option to choose which scenario, and there's a brief description. So for example, here, if I want to classify tabular data like flowers based on their different measurements, I might want to use data classification. Or if I'm trying to predict things like the price of a house, I might be using value prediction. We also have computer vision scenarios, again, like image classification and object detection. And most recently, we've introduced these different natural language processing scenarios, such as text classification and sense of similarity, which are actually based on transformer-based architecture. So all of these computer vision and natural language processing scenarios, they're built sort of using the sort of deep learning models, right? And so in this case, I'm going to choose value prediction because the thing that I'm trying to predict is a star rating, a numerical star rating, which most closely aligns with this value prediction. For environment, in this case, we only support local CPU, but you're going to notice here that for some example, especially those that are a little bit more resource intensive, like those deep learning scenarios, not only can you use sort of local scenarios, not only can you use GPUs, but you could also use Azure as well, right? So you can use Azure as sort of your compute engine for training some of these deep learning models that we provide here. So in this case, local CPU is the only option. You're going to see here that this is that data loading and preparation step. In this case, I can choose either loading my data from a file or from SQL Server. If I go to browse here, I'm going to pull up a subset of my data, and you're going to see here what that data looks like. And so what I have here are just 1,000 reviews for fine food, right? And you're going to see here that there's information such as product ID, user IDs. There's information about the score. That's basically the star rating that we're going to be looking to predict. There's also information, a summary, like a title for the review, and then the text, which is just a free form text for the review. Okay. So now that we can see what our data looks like, let's take a look at what we want to predict. So in this case, I want to predict the score. That's the sort of the star rating we're looking to predict. And by default, it's going to use everything here, that every single column, as a feature or as input to try to determine the relationships between these inputs and the star rating. Now, not all of this data is useful. So what I can do here is I can click into advanced data options, and I can configure a few things. So for example, the ID, things like product IDs, profile names, this is not really useful to me. So I can just go ahead and ignore those. And I'll do that for pretty much each of them. You're going to see that the score is already marked as a label here. It's the data type is single. You're going to notice that you have a few options here to choose from. And then let's ignore this last two. And then so the only things that we're going to be using here are the text, which is the free form review, and the score, which is our label or the thing that we're trying to predict here. Okay. So let's go ahead and save that. And you're going to see that already this preview sort of updates for me. And my data is basically ready to go at this point. Now, in a training step, I can choose how long I want to train for. Now, in this case, what we're using is AutoML, or the Automated ML API, to try to iterate over different algorithms, different configurations to try to find the best model for your data. So in this case, by default, it chooses 10 for me because one of the heuristics we use here is the file size. It's not a very large file, so let's go for 30 seconds here and start training. And so what's going to happen here is over the next 30 seconds, AutoML is going to go and try a different set of algorithms and configurations, hyperparameters, to train the best model for my review data set here. And it's going to be using the raw form input text as input. And the thing that it's going to be measuring the performance of each of these models against is how well it's predicting that score value or the star rating. Okay. So we're going to see here that it found one. It actually just found one. So if we would have given it more time, it actually would have iterated over even more algorithms to try to find it, to try to find more, different configurations here. But in this case, it seemed that it found one in the 23 seconds that we gave it. And then it also did a few things. So you'll notice here that here's our mbconfig file. And then if I zoom in, let me try to zoom in here just to make it easier to see. I don't think that's any better. Yeah, it's not better. But essentially, you have a few files here that are generated as sort of code behind in this, behind this mbconfig file. So one of them is this file with the mlnet extension. Now, this is that serialized file that I was mentioning, which is basically just your model, right? So now when you want to use it, you just sort of carry this mlnet file around, and you can just load that into your application and use it to make predictions. We also try to make it easier for you to either consume or train this model. So this is what I was mentioning in terms of like, it's not either or. You could start with the tooling, but then if you wanted to switch and sort of config, do a little bit more customization on the code side of things, you certainly can do that. So if we look at the consumption file here, for example, you're going to notice that we generated a few things for you. Number one is we've generated the classes that contain the schema for the inputs that are coming into the model, as well as the outputs that are being generated by the model, right? And you see here that these are show the outputs here. You're going to notice that we also create helper methods here. In this case, where it takes an input, it uses the model to make a prediction, and then it returns that prediction. We've sort of done that here for you as well. We've also included some code here to evaluate the model. So this is important if you want to understand what are the things that are impacting my model, right? In this case, it's not that important because we only gave it free-form text, but you could imagine if you were using more than one column as your input, you might want to determine what are the factors that are actually driving my model. And that's kind of what the contents of this evaluate page have here. And then last but not least, as you get more data, you're probably going to want to retrain the model on that new data. So we've given you the code here, for example, here to train your model, right? And we've also given you the pipeline or the series of transformations, as well as the algorithm that you're going to need to retrain your model on new data. You're going to notice here that I didn't have to set any of these parameters. I didn't have to tell it which transformations I needed to make. AutoML sort of just did that for me, right? And so with that, that basically just shows how you can train a model. Let me just show you one last thing. Now, one of the things that you can also do here is you can try it out. So if you give it a piece of text, it will try to sort of predict, what the star rating is. In this case, I think it was a negative review. Features were small size. And in a few seconds here, you see that it's a 2.89 star rating, right? So this, you can kind of ballpark to see whether it works or not. And then last but not least, one of the other things that we'll do is if you want to sort of deploy your application, we'll sort of scaffold applications for you. In this case, you could either use it as to create a console app or a web API. In this case, what I've done here is created a web API, and you're going to notice that mbconfig file gets generated. It also brings over the model and any sort of code behind that you might need. And if we take a look at the actual application that gets scaffolded, it's just a minimal web API here, right? And a lot of this is just your boilerplate web API stuff. But the only things that I want to kind of call out here are this prediction engine pool, which is what we use to train the model. Again, we're using that mlnet file here. And then we just create an endpoint predict, which uses that prediction engine pool to predict inputs, model inputs coming in. Okay. So with that, let me kind of switch over, and I realize we're running a bit low on time here. So let me just kind of show you, now that you've trained your model, now that you've scaffolded an application or it's been scaffolded for you, how can you take this and deploy it to Azure Container Apps? So it's actually not that more difficult. So you start off where we started for training the model, right? So we started off with right-click, add, except in this case, what we're going to do on our ML API, we're just going to right-click, publish, and basically go through the process of sort of generating an application. So let me try to mock as if I was going to create a sort of container app here. So if you right click, you select Azure, you can select Azure Container Apps. You go through this process of filling out all of this here, but I'm going to see if I can skip to the end because there is something that I kind of wanted to show here. It's actually really cool. Okay, guess not. So let me just kind of go here. Let me choose my registry. Sure. All right, so this is the part that I kind of want to show you that I think is really cool here, right? So if you have an application that you're adding these models to, and you already got Docker configured, and you want to go through the Docker path, right? You can certainly do that with this Docker desktop option. But if you just want to use the built-in support for containers in the .NET SDK, you can just select this. You don't need a Docker file. You don't need to really worry too much about that. By selecting this, everything you sort of need to sort of package and containerize your application is going to be done automatically for you, and it's going to be handled for you with Visual Studio. And at that point, once you have your application configured for deployment, you just hit publish, and this creates an Azure Container App for you. Right. Now, if we were to go ahead and test out sort of, I have an endpoint here, Azure Container App that's running, and I wanted to test out my application to make sure it's actually performing well. Let's take a look at sending a post request here to that predict endpoint, what based on this review, what it would say. So for example, I'm telling here that the text or the review is, this product has significantly improved my well-being. If I were to send this over to my container app that's running, you're going to see that the score, or that predicted star rating, is 476, right? So this is a pretty good review, and this makes sense. Now, what happens if I didn't have this sort of review here? What if I said, the box was broken and there were no instructions? Would not recommend. So if I were to hit that endpoint, you can see now that the star rating for this particular review has changed, and now it's on the lower end. It's a 2.37. All right. So you can see here that training a machine learning model is not that difficult, at least to get started, right? You can just right-click, add a machine learning, and just go through the wizard here, go through Model Builder to train your application, to train your model using your own data. If you're looking to deploy to the web, you can just leverage some of the components that Model Builder gives you here, so that you can scaffold a web API solution, which is just going to be web API project that's just going to be added to your solution. And once you have that solution, when it comes to deploying, you can just go through that same right-click publish workflow and really quickly, without leaving Visual Studio, train your models and then get them into production quickly and easily. So this kind of, again, sort of reinforces that sort of fact where it's very easy to go from that experimentation step all the way to production. So I'll kind of pause there and open it up to see if there are any questions.
Awesome. Thank you, Luis, so much for showing that all off. One question I had for you specifically when it comes to ML.NET, you said that you could take in other models that are out there. Can you talk about that process? Is there any standard formats that are required, any conversions or things like that?
Yeah, totally. So some really good places. So Onyx, which is, let me just go back to my slides here real quick. Onyx here, right? So that stands for the Open Neural Network Exchange, and that is just a common format. So let's say that you're working with data scientists that are using Python for training. They can just take the models that they've trained, convert them into this standard Onyx format, and then once they have it in this Onyx format, you can just import that into ML.NET in this very similar way, like we sort of imported our models here, our standard ML.NET models. And there's a lot of different converters out there that you can sort of use for this, depending on which framework, right? Because this is dependent on which framework you're using, but there's a ton of them out there. And also there's the Onyx Model Zoo, which is a collection of models that are already converted for you. So you just need to grab the file, the Onyx file, bring it into your .NET application, and it just works out of the box.
Very cool. That's awesome.
Yeah.
Jay says Model Builder, super duper cool, which I totally agree. And last one here for you, Mohammed is asking, how big was the data file in your example? How many rows, for example?
Yeah, so it was only 1,000. The entire file, the actual data set, it's an Amazon Find Food Reviews. It's got about 500 and something thousand. So it's like a 300 meg file, which if I would have done that as part of the demo, it would have taken forever. But the file size that I was using is just 1,000 reviews, and I think it was like a few kilobytes. So it wasn't that big, but it is a good question, right? In the sense that like the more data, specifically data that's representative of things that you're going to be seeing, your model's going to be seeing out in the real world, the better, right? So yeah.
Perfect. Awesome. And I also want to remind everyone that you can find Luisa and team over on the .NET YouTube, youtube.com/.net. Every other Wednesday or so, you're doing an ML.NET community stand-up, talking about all sorts of cool stuff as well. So Luis, thank you so much. I really appreciate it.
Thanks so much.
Awesome.
Thanks, folks.
Cheers. Awesome. Well, thanks everyone for sticking with us and learning all about ML.NET and Azure Container Apps to build and train machine learning models. Up next is two of my favorites. All the services are sort of my favorite services in Azure, but some of my favorite services and databases out there, Azure Cosmos DB and Azure Functions. I use Azure Functions almost every single day at work, personal life, so much. I love the functions, and I connect Cosmos DB up to it all the time. And I'm excited because Matias is here to show us how to build dynamically scalable event-driven services using those two things, Azure Cosmos DB and Azure Functions. Take it away, Matias.
Hey, James, thank you so much. I'm really super happy to be here. My name is Matias Quaranta. I work on the Cosmos DB Azure Cosmos DB team as a software engineer. And we'll be talking about, as James said, about building this scalable event-driven application using Cosmos DB and Azure Functions. We recently did a release of the new Azure Function extension, what we call the V4 or 4.x version. And I wanted to first go through the most important of highlights that this new version comes with. And then we'll be delving into kind of popping the hood out of the extension to learn how the trigger or event-driven hook that we have works. And then building a dashboard on top of it to learn about monitoring. And finally, I have kind of like a bonus or gift for everyone here that is attending. So hopefully we'll get this through. So let's start with the highlights. Most important things that you will look or you will find in the new version. If you're currently using the extension, the V3 extension, you should be looking into upgrading. If you haven't built any Cosmos DB event-driven applications using Azure Functions, this is the new version that you should be using. We support managed identities out of the box, which means that you don't need to deal with connection strings anymore. You don't have to build weird Azure Key Vault wirings. You can just use the managed identity that is on the function app and assign RBAC permissions to that identity on Cosmos DB, and that will just work. We added and extended the login that we produce on the extension, so for you to debug and even check performance on different scenarios. We'll be taking a look at that in a minute. We added a custom serialization engine for JSON. So we know that Cosmos DB stores documents as JSON. So there is a process, and we'll see it in a bit where that raw JSON travels into your Azure function code. That goes through a JSON deserialization process. Or if you're saving data, that goes through a serialization process. We enable on .NET, as a developer, you can customize completely the JSON serialization engine. You can replace it with system.json, Newtons of JSON, whatever JSON engine that you want. Any custom settings, you can use it there, and it will apply to all the extension interactions. We added support as one of other Azure Function services, Azure services, added support for retry polysize. That means that you can set up a specific amount of fixed retries or even exponential retries in the case that the code that you're building in your Azure function fails in a transient way or in an unexpected way. We'll be also taking a look at that. And finally, you have access to the latest and more recent Azure Cosmos DB.NET SDK when you're using the latest extension. Now, those are the highlights. Those are the main reasons that you want to use this new extension. And we know that Azure Functions extensions allow for three main things. We have the input bindings, which allow you to read data. You have the output bindings, which allow you to write data. And we have the triggers. I want to focus on the trigger because it's probably one of the most interesting parts, and that will allow you to build these event-driven applications. So let's start with how does the event flow work. So you have a Cosmos DB account, you went into the portal, you created your account, you selected your regions that you want your data to be replicated to, and you start by creating an Azure function. And that's when we are going to jump into the code. You'll start obviously by creating your Azure Functions project. You want to add the Azure Cosmos DB extension and you want to use any of the most recent 4.x versions to use the latest extension version, and you will probably start by writing something like this. You will have your function name, and then this is the syntax for the trigger. So you will start with decorating it as a Cosmos DB trigger, and you want to first define 3 key things, which is the database name, which is the container name, and which is the connection. The connection will take care of, obviously, connecting to your Cosmos DB account. You can use connection strings, but you could also leverage managed identities. And then what are these databases and container names? Well, but when going back to the slides, we have the concept of a container in Cosmos DB. The container holds all your documents, all your data that you are saving and storing in Cosmos DB. This container, when you create it, you define what we call a partition key definition. In this case, in the example that we are seeing on the screen, we have defined that for this container, the city, let's say that we are storing telemetry coming from different regions in the world or different cities. I'm storing data, and this data, this piece of information, contains one property called the city. This is a concept of the logical partition key. Each document that you're saving will contain a city value. Within Cosmos DB, within the container, we have also the concept of physical partition key, and that is how the data that you are storing gets stored physically in partitions. So what we'll see is, in this example, we are seeing a container that has 4 physical partitions tracking ranges of these logical partition keys. So the first physical partition will hold documents that, for the city property, contains values that range from A to H, and the second physical partition contains values from H to L, the third one to L to R, from L to R, and then so on and so forth. So the number of physical partitions is driven by the volume of data that you are storing. So as your container grows, these more partitions will be provisioned for you automatically and transparently. You don't need to do anything, and the container will scale dynamically for you. So if we are building a project that wants to react, a function app that wants to react to any new document or event that happens on this particular monitor container, I will grab the database name and container name, and that's what I'm going to save or write into these 2 pieces of information. And what I'm telling is I want to trigger this Azure function whenever there are any new changes on this particular container, in this database, in this Cosmos DB account. Now, going back to the slides, we have this container. Let's say that it has, for the sake of example, 4 physical partitions. Now, there is this concept of the change field processor. What is happening underneath, under this function or this simplicity that is just writing Cosmos DB trigger, is that we are running the Azure Cosmos DB .NET SDK. The .NET SDK has this concept of the change field processor, which is a construct that what it will do is it will hook into the container that you want to listen to, and then it will start to read, and we'll see in a second how it does it, but it will start to read the changes from a feature or an endpoint called the change field. This change field endpoint is available on all in all containers in Cosmos DB. You don't need to enable anything extra. So the change field processor will hook into this change field on this container, and it will use something that we call the list container. The list container is also present here in the configuration, and you need to define this second container where we'll store something we call the list documents. These list documents, what they track is what's the last point in time that your function has successfully processed the events that are happening in this monitor container per physical partition. So in a container that has, in this case, 4 physical partitions, this list container will have 4 documents, each one tracking the progress of each individual of these 4 physical partitions. The name of the list container is completely up to you. I mean, we have a default value of lists, but you can call it whatever you want. Another interesting setting that we have on the trigger extension is the portfolio locations. When you create a Cosmos DB account, you can define, to have your account in multiple regions. That means that your data, including the change field events, is also replicated across all your regions. So you could deploy your function app in multiple regions or in just one, and define which is the preferred locations you want to read the data from. Ideally, you want to read local data, which means that if I'm, for example, deploying my function app in West US, I want to make sure that my preferred location is in West US. And one very cool thing that function has is that the actual values of this property, I don't need to hard code them. I could use a syntax like this, which will say, okay, here is going to have a value, but I'm going to define the value on the function app configuration itself. So the code will grab this value on runtime. This enables me to have multiple versions of my trigger or deployed in multiple regions, and each one might have a different region value. And that applies to any parameter, right? I can even have multiple versions of the same trigger pointing to different monitor containers if I wanted to. And I can make this without touching the source code. I can deploy the same bits across multiple regions and have different configurations and apply those configurations on runtime. Then I have the max item frame invocation. What it does is it defines what's the max batch size that I want these events to be triggered on my function app. As you are probably seeing here, the trigger input, what is given to your function code, is a list of changes that happen on your monitor container. The size of these events can vary. So depending on what you're doing in your function app, this size, you can increase it or decrease it depending on your own workload, but you can customize that value using this optional property. And finally, we have this called the list container prefix. What this does is it gives a unique identifier to these list documents. I could reuse the same list container for cost purposes for many function app triggers. Ideally, what I want to do is I want to have a unique identifier for this particular function app. This also can be a setting that can vary dynamically, but I want to have a unique identifier to define this set of lists that is meant to track the changes that are happening on this particular container. So up until this point, what we have is I have written a Cosmos DB trigger. I'm telling it, hey, I want to hook into the changes that are happening into this container. I'm going to track changes in this list container. I want to read the changes from this region. And I want to store all my lists with this unique identifier. All of these changes, all of these attributes are actually optional. The most critical ones are just these three. The rest have default values, but I'm trying to showcase like a more advanced configuration. Once I deploy this to function apps, what is going to happen is my function app will wake up and trigger whenever there is anything happening on the monitor container. But let's actually take a look at the entire process. So once I deploy my function app, let's assume that I'm deploying a single instance. So I toss it over on Azure, it's running. The first thing that will happen is the chief processor will acquire these lists. So let's assume that we have these 4 lists. It will acquire each of the lists. So that instance will acquire these lists and will start to process them. One of the things that I was mentioning on the highlights was that we added more logging. So if you have your function app hooked into application insights, one thing that you can do is you can even check the different traces with different levels. And one of the things that you will see is whenever an instance, one of your function app instances, starts to process one of the lists. So you can actually track when a particular machine starts to process a particular list. In this case, you will see these traces. We have different levels of traces in our documentation. We have error traces, warning traces, information traces, debug traces, and we explain all the different levels, which critical pieces of information they can give you for debugging purposes, for investigating performance, or only for tracking critical issues that are happening while your function is running. For this case, for this talk, what I'm doing is I'm enabling them all, so we can see all the potential logs that we are producing. In this case, this is the first one. So the GenFi processor is running in your function app. It sees all these lists, it starts to acquire the lists. Once the list is acquired, what the processor will do is start to read the change feed for each of the acquired partitions for each of the lists that it has acquired. This is a request that is done on to your Cosmos DB endpoint, and we will get this list of raw JSON documents. Once we get these changes, we send it, we first deserialize these documents. We deserialize this raw JSON, and here is the part where we look into how we go from raw JSON into whatever POCO or type that you will define here. You will see that I created this, I have this device telemetry. I have a function app that is receiving events that are telemetry from different devices. And I have this C# class here that has just two properties. Now this, I mentioned at the beginning that we enable custom serialization and custom serialization engines. So what you can do is you can go into your startup.cs file in your function project, and you can use dependency injection, and we enable this new interface called Cosmos DB Serializer Factory. What you can do is you can define a custom implementation that will give the extension and custom implementation of the Cosmos Serializer interface. The Cosmos Serializer is the API that the Azure Cosmos DB.NET SDK will use to serialize and deserialize all raw JSON. This API is really simple. It just has two methods, which is from stream, which is basically the part when we receive the raw JSON and we convert that into an instance of your class, and then the opposite, which is we grab an instance of your class and we convert it to a stream. You can use whatever serializer you want, whatever technology. In this case, in this example, I'm just using a custom system text JSON serializer that has these particular custom options using property name cases as insensitive, but you can actually do whatever you want as long as you implement the Cosmos serializer interface. And this will inject your custom serializer into these interactions. So once once we send we receive this raw JSON on the chain feed processor that is running underneath your function app, we'll use your custom serializer and we'll deserialize. And when that happens, we'll send those changes to your function app. And that is also something that you can see on your attached application insights. For example, I can see that these are logs that are showing that events were delivered to list 5. And we can also include the actual diagnostics. The diagnostics are the traces that the SDK emits that show, for example, let's look at the custom dimensions. They show the actual network requests and how long those network requests took to actually obtain those events and then pass them over to the serialization process and into your function app. So if you are looking into troubleshooting network latency or performance, you want to look at, okay, is there anything happening on the networking layer that is making my delivery of changes slower? You can take a look at how many milliseconds the entire network process took in order for your function app to receive these changes. Now, once we deserialize these changes, we send it to your function app, and that's when you do whatever you want. Like in this case, this function app, what it's doing is just also using an output binding, grabbing all these events, grouping them by device, and applying a summarization. This is very simple, but for the case of this example, what it's showing is how you can grab some trigger events, process them, and then use an output binding that is also using the same extension to save a summary of those events into another container. Now, whatever code you're writing here, it could fail. I mean, there could be transient issues. You could even have a bug, right? Or something might go wrong. It would be ideal for your function to be resilient to these potential transient issues. So one way to do that is we have these decorators that are supported for multiple Azure services, including Cosmos DB, that can let you define retry polysize. So this one, for example, is saying I want to retry up to 3 times with 5 seconds in between for a fixed amount of time. But there are others. There is one that is an exponential backoff. So depending on what you are doing, you can define your custom retry polysize. And in the case of an exception, what you will see in your logs is something like this. So you will get exceptions in your application insights logs, and you can see these exceptions that are happening. And at some point, you can even see that the function app execution in this case failed after 3 retries. So what happens is there is an exception. The exception gets logged. The function app will take the same batch of changes and re-trigger your Azure function with the exact same batch of changes, hoping that that was a transient issue. If the issue persists, well, in this case, it will retry again and again and again until all retries are exhausted. But this gives you at least a guard with transient failures. And everything here is also logged in your application insights monitoring. Okay, next one is assuming that the whole process succeeds and everything is great, what we do is we checkpoint. So we save, okay, up until this particular point, all the changes in this particular partition have been successfully processed. Let's move to the next one. So we repeat the process of going back to reading the changes, deserializing, sending them, checkpoint, reading, deserializing, checkpoint, and that's how the whole process works. Now, this lives inside an instance, right? And we have these multiple leases. In this case, there are 4. There could be way more. Now, when you create a function app, you can define different types of plans. One of them could be the consumption plan that dynamically scales. You could even go and define manual scaling rules and mechanisms, or even control manually. Okay, I want to have only 3 instances of this particular function app. What will happen is that dynamically, the function app extension, it will distribute the leases that, equally to an equal distribution algorithm across all your existing function apps instances. So in this case, if I scale either dynamically or manually my function app into 2 instances, it will grab these 4 leases and it will split them into these 2 instances. And this happens dynamically either up or down. If I go back to having 1 instance, then now this instance is owning these 4 leases and we'll start to process them all. Or if I increase, it goes back to dynamically distributing them. Now, this whole process of delivering events is based on this feature that I mentioned earlier called the change feed. You can see the change feed as a timeline. So at some point, your trigger has a cursor, which is defined by these leases that are maintaining the checkpoints. But your container, the container that you're monitoring, might be progressing and having more events. So the biggest question that some of I've seen most commonly asked is, but how far behind is my trigger? Like, am I processing real time? Do I have any delays? So wouldn't it be cool if you could have a measure of how far behind your trigger is? So that's when, as part of this talk, I wanted to showcase how you can actually build this. So you can take a timer trigger, define this timer trigger to fire as frequently as you want, and then use something that I will show that is part of the Cosmos DB SDK called the change feed estimator. The change feed estimator will look at these leases and calculate how far behind each of the leases is from the actual live container. And then we can grab this estimation and push it into application insights to eventually create something like an Azure dashboard. So going back to the code, this is basically what you could do. So you can create a timer trigger. In this case, I'm defining it every 30 seconds. I'm using the Cosmos DB binding, so I'm using the same authentication mechanism. But in this case, I'm pulling the actual SDK client. So as an advanced scenario, I can actually access the .NET SDK client, and I can call this estimator. The change feed estimator, it takes 3 pieces of information. It takes the monitor container, which is the container that I want to listen for changes on, which is basically this one here. It takes the list container, which is the one that is storing the leases, and it takes the identifier of the change feed leases that I was using. So if we look at the previous trigger, this maps to the list container prefix. So I can create this change feed estimator. I created as we are using a iterator pattern, and then we iterate on this estimator, and each item on this estimator will give us for each list which is the estimator in terms of the estimated lag between the current point that we have and the live partition on the actual container. So we can produce this sort of metric, which in application insights looks like this. So it's it can tell for each of the leases. In this case, I have a container that has 9 partitions. For each of the leases, which is the estimated lag, and who is the instance that is owning it. Now, why would you want to know who is the instance that is owning it? Because you can build something like this. So you can grab this application instance data and build some queries that I will share with you in a minute. And you can produce a dashboard that can show you, for example, for each of the instances, in this case, my function app has 3 instances, what is the lag that each machine, each instance is experiencing for this particular monitor container. Or I can go and say and apply the same thing for each of the leases. I can identify, hey, is there a particular lease that has more lag than the rest? And the key here is identifying patterns where the lag is increasing. Like, you will never be real time. You will always be lagging behind a bit. But the part that you want to use these dashboards and these metrics for is identifying patterns where the lag might be increasing for a particular machine or a particular set of leases, which would point for the case of the leases, any hot partitions where you are maybe, instead of distributing your data across the entire container, you are maybe sending too many writes, too many documents to a single subset of partitions, and that is causing your processing to lag behind. Or maybe there is something in particular to one of the instances that is having issues. Maybe it's you want to investigate maybe CPU or networking constraints, and you want to take a look at, okay, this particular machine is undergoing some particular problem. So maybe I want to investigate, and maybe I want to restart this machine. Maybe I want to take a look at what is going on. And finally, one other thing that I can do with this actual set of data is look at the distribution. In this case, I have 9 leases. I can actually see that each of my 3 instances is owning exactly 3 leases. So as my instances grow and shrink, I can see what's the dynamic distribution of the leases across the existing running machines. So just to wrap everything up, I want to share with you the entirety of my talk, including all the source code. And even the Azure dashboard is available on GitHub right now. You can go to this repo, you can clone this repo, you can reference this repo. It contains not only the source code, a README to guide you on how to actually duplicate exactly what I did today. And one cool thing about Azure dashboards is that you can actually export them. So it contains a JSON file. This JSON file is the actual same dashboard, the same queries that I was just showing you. The only thing that you need to do is you need to make sure that you are adjusting based on the documentation the actual resource path for your application insights that is storing these metrics. But once you do that, you can just grab that JSON and create automatically your own dashboard to track the progress of your function apps. I hope that this content was useful for you, and you can take this monitoring to the next level and create useful dashboards on your Azure Function apps.
I love getting great examples where we can take it and run with it and edit it ourselves and figure it out. It's a great way to get started, learn the functionality, get to play around with it and figure out how it works. Thanks, Matthias.
My pleasure.
All right, so we have a couple questions for you. Can we start with, here's a quick one. Is the Cosmos DB example available in all language workers?
Right, so one cool thing is that how Azure Function works is we build the C# extension. But on top of that, we have the Azure Function has the concept of bundles. So this same C# extension that is running is available in other languages on top using the bundles. The bundles are also versioned with the same values. I think it's the 4.x bundles will contain the 4.x extension of the Cosmos DB extension.
Awesome. Seems like people are already forking your examples.
Awesome. Hopefully it's useful.
Yeah. Can we talk about how partitions are set up in Cosmos real quick? I think we had a couple questions. They got answered in chat, I think, but it would be good to just cover it real quick here.
Sure. So partitioning in Cosmos DB is automatic. So what you do is you create the container, you define your partition key. This is just an example trying to explain how a potential distribution could be. But what happens under the covers is when you store a document, the service grabs that partition key value, in this case, the city, and applies a hash algorithm. So your data will be evenly distributed across all physical partitions, assuming that you are using a distribution of frugal values of your partition keys. It's not actually, or potentially not using actual A to H, like it's ordering letters. The letters was just a representation of a potential distribution algorithm, but the services may be way more smarter, using a different hashing algorithm to make sure that the values are evenly distributed across all physical partitions.
Awesome. Thanks. All right. Well, those were the questions that we had. Thank you so much for joining us today.
My pleasure.
Have a great rest of your afternoon.
You too.
So we are more than halfway done with the day. We only have a couple sessions left here. And so next we're going to move into accelerate .NET web applications performance with Azure Redis Cache. Before we jump into that, I want to remind everyone that we have the Azure Developer live streams happening. And so every third Tuesday is the Azure Functions one, which I'll mention specifically because we just had the session on Cosmos DB and Azure Functions. So if you want to learn more about all of that and all the Azure Functions goodness, join us every third Tuesday at 10 a.m. right here on Azure Developers YouTube and get all the insights and connect with the team. So let's pull up Catherine here. How are you?
Hello, Haley. I'm good. How are you?
I'm awesome. Thanks for joining us today.
Yeah, thanks for inviting me.
I love your background.
It's for .NET.
Absolutely.
Okay, so should I start presenting?
Go for it.
Cool. So thanks everyone who's joining. Today we are taking a look at Azure Cache for Redis. So we will look at how to follow the patterns and best practices applying Azure Redis Cache to your .NET web app, and we'll have a demo for it. We will also look into how Microsoft has worked with the open sources communities in projects such as Stack Exchange.Redis to improve the overall developer experience. And then we'll look into how Redis Enterprise offers various capabilities to enable the integration with machine learning and AI projects such as OpenAI. So what is Azure Redis Cache? Well, Redis is an open source project developed by Redis Inc. It's essentially an in-memory key-value NoSQL database store, and the nature of it makes it very suitable for being a data cache, alongside with a few other scenarios. Azure Cache for Redis is developed in partnership with Redis Inc. It is first-party hosted, fully managed, so developers don't have to worry about the operational overheads. Everyone can just focus on business logics when coding with Redis Cache. A few highlights for using Azure Cache for Redis. It makes your app performant and scalable. It's very cost-effective when working along with database. It has the network integrations to ensure everything is secure. And it integrates seamlessly with other Azure services if you host your entire solution in Azure. Now, you may wonder, where do I get started using Azure Cache for Redis? So if you go to Azure portal, say create a resource, and search for Azure Cache Redis Cache. You will see the first two images, Azure Cache for Redis Enterprise and Azure Cache for Redis. This is the second one is the community version hosted for the basic and premium tiers. So we always recommend starting with Enterprise for a bunch of advantages that we will talk about later. But even if you start with the second image, you can still choose enterprise when you set the SKU for it. So after we create an Azure Redis Cache instance in Azure, what can we do with it? Well, there are a few scenarios. The most common one, we would use Redis Cache as the distributed cache alongside with your application to accelerate the data performance. For example, a well-known pattern is the cache set pattern for your applications to always try reading from the cache first before accessing to database. And then the key value in-memory nature makes it a very fast data store. We usually put web application session data in cache. Also for other types of data like shopping cart, which does not have to be persisted all the times. Putting it in cache is a very effective way to do it. And then extending the data store scenario, Redis Cache is very fast for data stream processing. So for the real-time analytical type of applications like fraud detection, stock market, and IoT, Redis is a very good choice for storing those data. And finally, Redis can also be used as a message broker. So in cloud-native applications, if you have one microservice talking to the data store backend, usually use a pub/sub pattern to have a message queue for communication, and Redis does a very good job with that. So for all these scenarios, we may wonder, like, do we have to start from scratch when we implement all these? The answer is no. So we recently shipped the reliable web patterns for .NET. It's basically a collection of patterns and the best practices, uses various Azure services to implement efficient data access, well-designed data structures, together with security, performance, monitoring guidances. And there are small components and assets you can reuse. So in the overall guidance, you'll see Azure Cache for Redis here. It's used alongside with SQL for the cache set pattern. So that is what we should always consider when designing our web applications. So let's zoom in to take a look at the demo using cache with the web applications. So I'll start with a web app talking to SQL, and then let's see how to transform it by adding cache to it. So here I have a small e-commerce application. It basically shows different products that you can view or purchase. Right now, everything's loaded directly from the database. While browsing through the items, maybe I want to take a look at the detail and then decide to shop later, in which case this item will be bubbled up on top of the page for me to conveniently add to cart if I make a purchase decision. And I can add various items. Now, if I go to my shopping cart, I see the items all added here. I'm not logged in yet, so maybe I'm a member of the site earlier, and maybe I have other items also in the shopping cart. So I can log in now. So after logging in, I see the previous items are already transferred to my logged in account. So now I can decide to continue shopping or simply check out. Now, since this web app is talking to database directly, for now it's fine. I'm just a single user. But what would happen if we have a lot of load put on the web app? Like, will it still be scalable? What are the potential problems? So right now, all the data information like products, shopping cart, and identity are all in SQL Server. This is fine for now, but as my application starts to receive a lot more traffic, this may not be scalable. And then for session data, everything currently is stored in memory in the web app server. Potential problems are in-memory session data would require sticky session to be configured, which means each client, once it established a connection to a server node, that server node stays with the client throughout the session. In the case of failover or scale out, data might be lost, which is not good for resilience and app maintenance. In addition, memory is a scarce resource, and we really want to have some control on how much of it is used before we start to get out of memory errors. That's why we're adding Redis Cache into this overall topology. So now we can cache the product's information in Redis Cache for faster access. We can move the entire shopping cart data into Redis Cache. Because when people were shopping, they can make decisions on adding new items, editing items, or even maybe they put a bunch of things in the shopping cart and then they decide to come back later. So there's really no point to persist this data until they decide to check out. And for session data, we'll also store it in the Redis cache outside of the web server for app resiliency reasons. And in the database, we will still have copies of the products data and the identity. So you may wonder, like, the second topology looks very different from the first one. Like, do I have to recode everything? It's like almost like starting a new project from scratch. Well, the answer is no. You can actually reuse a lot of code from the previous topology. So this is my web app project, and this is the program.cs file where we configure the web host startup. Redis Cache can easily be added as a distributed cache service by the web app host builder. I just have to add one NuGet package, microsoft.extensions.caching.stack-exchange-redis. I made sure it is the latest version. And then with simple configurations like get the connection to Redis, I can establish this service connection. Following that, .NET has default session services and is designed to work with any choice of distributed cache added to the host startup process. So I don't have to do any additional code or configuration for the session to know there's a Redis cache added to the app and start to store things in it. So as you will see earlier, I was using memory cache. Now I decided to use Redis cache. I could just comment out the previous line and exchange it with the distributed cache service. And thanks to the dependencies injection pattern, for my cart service and the product service, I can simply switch the implementations to use cache for data access. And here I can leverage the dependency injection to choose which implementation of the interfaces I will use for my web app. So after all this, I didn't really have to change anything for my web app to pick up cache and start using it to improve the performance. And Another feature I really liked is the distributed cache tag. It's very common to embed C# code within the Razor web app. So the distributed cache tag allows me to save any information as the output from my C# code into the configured cache directly. I can configure properties for the data information, such as like how long do I want to persist it, or as cache attributes, the tag attributes here. So after all these changes, how my web app looks like now. So this is the cache version of my web app. I can still browse different items and see the items I just viewed will be pop up here. This is the time management feature I built with the distributed cache tag, so customers can know when their shopping session started, and that helps them make a decision if to make a purchase or not. And then everything else stays the same. So when I add items to cart, now it writes directly to cache, which feels much faster than earlier. And all the shopping cart related operations are much faster. But I'm just one single user here. So how will this work under load? I did an experiment with the Azure load testing service. It's a recently released load testing service available in Azure portal, good for running quick load test by sending traffic to a URL, as well as integrations with the JMeter test. Like you can upload the test script for more complicated load testing scenarios. So I just ran a quick load test on my homepage with 1,000 users for 5 minutes. My throughput with cache was 459 requests per second, and without cache was 180 requests per second. So we can see by adding cache, just the read operation is having like more than 2 times improvement. So in the earlier demo, we talked about the Stack Exchange.Redis. This is the library we built the distributed cache service providers implementation on top of it. And also for advanced user scenarios, for example, if you want to batch multiple calls to Redis Cache and you want to reduce the network latency, this is very good for like grouping those calls together and just make one single request to make your app even faster. So if you are advanced developers looking for like making your web app super optimized, you can use Stack Exchange.Redis directly in your app. So this library is developed by Stack Exchange Company, open source. It was designed for busy sites like Stack Overflow. Microsoft has been collaborating with Stack Exchange.Redis maintainers to enhance the .NET developer experience with Redis Cache. And over the past years, we collaborated and worked on quite a few features to improve the reliability, application resiliency, and extensibilities. So let's take a look at the details for these features we together collaborated on. The first one, command queuing. This is to improve the reliability and the transient error handling in your app. Basically, this means in the case of a Redis client connection failure, if there were commands just about to be sent out, we will queue it in a buffer. So when client connection restores, these commands will be sent out. So without this, if the commands were to be sent out and there's a client crash, the command will just be throwing failures, and developers will have to write code to handle the retry logics and error handling and so on. So with this feature, developers can further just focus on the business logic without having to worry about the connections, the clients, and so on. The second one, automatic topology update. This means the Redis client actually will maintain a real-time topology on where the shards of the data is stored, which primary or secondary node to read on. So this improves the success rate and further boosts the performance for real-time distributed cloud applications. This feature right now is optimized for Azure Redis Cache because we did something in the hosting platform in Azure, but it's adaptable by other vendors. As long as you send some message when topology changes on your server side, and the Redis client can subscribe to a channel and respond to it. And then extensibility. This enables customizations and help establishing standard for how Redis client configurations will be set. So for example, you can define the connections to be always SSL enabled, which is a good policy enforced for compliance reasons. Microsoft created the extensibility features, so we could work on the Azure flavor of the client, azure.stackexchange.redis, which is coming very soon. And then one last thing I wish to mention is please remember it's very important to keep your Redis stackexchange.redis client up to date. And in the earlier demo, we also saw in the topology, there's the web app connected to Redis Cache and also to the SQL database. The entire environment was secured by Azure networking. And developers may wonder what it takes to provision this whole environment. So we are shipping a feature in Azure Portal to enable one-click provisioning such an environment. It will be an option on top of the current web app plus databases template. You can choose to provision the environment in Azure Portal directly or download a template for infrastructure as code. This is also coming very soon. So in the topology, we have one cache and one database, both storing data. How do we keep the data consistency? There are 3 caching strategies. The first one, cache invalidating. This means every time a change made to the data store, like the persistent data store, we will remove the corresponding cache entry. So this would force the application to read the new data from database next time. And then we can put the new value in cache for future access. This is a very reliable strategy, but the shortcoming is it might be a little bit inefficient to always delete cache and read from database again and then update it. So the next 2 strategies, write behind and write through, would both update cache directly and rely on cache to update the data store behind it. And write behind means the update happens synchronously. Write through means the update happens asynchronously, which would allow even a greater scale. Now the question is, how can we make sure the cache can update the data store reliably? What happens if the client update to cache succeed, but the cache to data store fails, and so on. So in order to make sure the cache and the database stays in sync, we are shipping another feature for Azure Function integration. This is exactly what we needed for the read behind and write through cache scenarios, where an Azure function can be triggered by things in cache, and then corresponding to that, do a write or some additional data processing in the SQL Server. So beyond the consistency story, even for event-based architecture, like in IoT scenarios, millions of devices sending data to cache, we can have an Azure function there too to do the data processing. So that will be helpful in this scenario too. So cache can be having multiple nodes as well, and can be distributed across multiple geolocations. How do we keep each node of cache consistent? That's where Redis Enterprise comes into play. We have the active distribution. It has local latency, seamless conflict resolution, and uninterrupted downtimes to make sure like the node in different geolocations can also keep consistent with each other. So without this feature, you may have to do something in your application logic code to keep the consistency happening, or do extra configuration on your infrastructures. With Redis Enterprise, this all comes in as part of the product. It also has unparalleled SLA 5.9. This is like really valuable for cloud-hosted services. It means like almost no downtime within 1 year using the service, and brings your application really up to enterprise scale. And it offers the zone redundancy to create cache copies in separate availability zones that can be failed over to in case of an outage. That's a further guarantee to make sure your app is always available to your customers. And it offers extended scenarios with rich data extensions. So there are a few extensions, Redis Bloom for probabilistic data. Redis time series is good for like real-time data processing IoT scenarios. Redis search for the searching, querying, index analytical applications, and Redis JSON for storing entire JSON document, or like full or partial querying, updating to it. Those are really helpful with the big data scenarios, real-time applications, analytical scenarios, and so on. So this all sounds very theoretical. Let's take a look at an example for how these analytical features can be applied in the AI and machine learning scenarios. So vector similarity search is one feature with the Redis search data extension. Maybe we should firstly talk about like the overall story. So there are times in the AI machine learning scenarios where we may want to compare how two pictures are similar or different from each other, or going through a bunch of unstructured text as the feedback data, for example, and we want to draw some insights by grouping all these feedback data. Or maybe it's audio streams, and we just want to compare like what are the anomalies in the audios. So all this, how do we like compare those type of input? That's what embeddings come into play. It's essentially a vector of floating point numbers. You can think of it as a numbers representation of the previous input content types, like images, long text input, audios, and so on. So we have like engines like OpenAI available to transform the input into the embeddings. So now we have a like numbers representation of input from like various sources, various types. Now, with all these embeddings, it will become easier to compare the similarities and differences. So here is an example from the OpenAI website where we are using the text input from product review data. And then figure 2 shows examples of embeddings. It's like literally a vector of floating numbers. And with this numbers representation, we can plot it on graphs. And now it's like, if 2 dots are close to each other, they are very similar. If they are far away, they are different. And then we can leverage some other capabilities to compare like how different or what are the anomalies and so on. But we need rich query interfaces on top of all these like embeddings, right? So that's where the vector similarity search in Redis search comes into play. It has very rich analytics querying capabilities to compare like similarity, ranking, anomaly detections, and so on. And Redis as a very fast data store is also good for storing these embeddings, especially for the unstructured data like images, audios, long piece of text, and so on. And if you want to try it out with the Redis search, we have a .NET client library available. It's a flavor of the Stack Exchange.Redis called Redis Stack, available on NuGet. You can download and take a look. And we have a GitHub reference for how the demo works.
Hey, Catherine. Okay, cool. You're at time. Perfect. Never mind. Perfect. Okay, good.
So we have the references if you want to take a detailed look into the points we talked about.
Awesome. Yeah, I want to just pull up this one question before we move on to Mike's session. But we wanted to know if we could see the code for the example that you gave. So I believe that it will be shared soon, but can you give us more information on that?
Yes. So see the demo app on the in the reference list. That is the demo we were just seeing.
Awesome. And we will put that link in the chat here in a minute so that you can all link to it. Thank you so much, Catherine. This was awesome.
Thank you.
Have a great day. I will use this as an opportunity just to remind everyone that here we have a whole bunch of resources available in case you want to learn more about anything. Here's specifically Azure Cache for Redis, which we just talked about. And for each of the sessions, we have so many resources on getting started and learning more resources on what's going on with the products. So with that, I will pull up Mike, who is, I think we've said this several times today, but one of the my favorite people that I've ever worked with. How you doing, Mike? What's up?
I'm doing great. Thanks, Haley. How you doing?
I'm awesome.
Great. Well, hey, thanks for having me today. I'm going to start right away because I have a ton of content. In fact, you should probably warn the next people. I think it's Frank and David that I'm going to definitely go long. So, but I'm going to go fast as I can. Slow me down, either you or the audience, if I go too fast. But I want to make sure I get a lot of great content. And I'll start with my slides here, Haley, if you don't mind, unless you had any more questions.
No, let's go. Let's roll with it.
All right. So this session is how to use container apps to build, deploy, diagnose.
Your slides are not up. If you are thinking,
my slides are not up.
They are not up yet.
I'll present again. It does look like it didn't take. And there we go. I'll try that again. How about now?
Now they are showing. Here we go. Now they've been added to the screen. Cool.
Thank you. All right. So again, big long title. It's actually not the title I sent in to Haley, but she wouldn't allow me to use this title. So here we go. How about that title? There we go. That's the one where Container Apps is awesome. And that's me over there, Big Morty. I don't quite look like that, but I'm good looking like that picture shows. So anyways, Azure Container Apps. If you haven't used Azure Container Apps before, it's a great serverless environment or service to run your containers. We really are great for microservices, but we do support a number of other payloads, and I'll go over those. It's built on modern apps and open source to make sure you're building those cloud native apps with modern services. And it really allows you to focus on the apps rather than the infrastructure. You're not having to manage a Kubernetes cluster. It really takes a lot of the burden from doing that without giving up the power to be able to scale and run lots of apps and instances of those apps, what we call replicas. And we use Kata to scale dynamically based on events, whether that's HTTP events, based on your CPU and memory, pretty much any Kata scaler we support. And then here's a list of some other things we use. Envoy for our ingress, and Dapper, of course, is built into the platform. Don't have to install anything. You don't have to use it, but it's there for you to use, which is a great runtime. It's a distributed application runtime. Makes it really easy to build your microservices. And of course, we're completely based on Kubernetes. Under the covers, we're using a lot of that technology. I mentioned you can build microservices. We're really great at that. You can deploy 1, 2, 5, whatever number, 100 microservices. You'll deploy those inside of what we call an environment. I'll touch on that in a minute. And they can automatically talk to each other if they want to. They're all in a secured VNet. So there's a great way to run your microservices. That said, we do support just all your APIs. So any APIs that you want to run, it says public APIs here, but you can secure APIs also. You can put other Microsoft services, front door, things like that in front of Azure Container Apps to regulate some of that traffic that's coming in. Of course, we support web apps also. Event-driven processing is really popular, where you're pulling things off of a queue. And then, of course, background processing. And we're working on some big improvements to that are coming out soon. So stay tuned for that. Okay, I only have like 1 or 2 more slides. I'm going to go through this pretty quick. You can always come back and reference this slide. I'm sure Haley will figure out a way to share all the slides, excuse me, with everyone. So I mentioned that environment. It's that virtual network boundary where all of your apps run within. You can, of course, have multiple environments, and it's very common to have maybe a developer, a test, and a prod environment. And then you'll deploy all of your apps into that environment or environments. As it shows here, each app can have 1 or more revisions. We default you to single revision mode, where you just have 1 revision that replaces itself all the time whenever you deploy it or update it. But you can have multiple, which allows some cool things like traffic sharing or traffic splitting. If you want to do maybe a canary deployment, that's a great way to use a multi-revision. Put out a second revision, maybe send 5% of the traffic there. We use Envoy again that does that. And then move the traffic over as you feel good about it. Each revision can have what we call replicas. Those are instances of your app, basically, of your application code, which is made up of 1 or more containers. Typically, it's a single container. You can have what we call sidecar containers. If you have maybe a logging or an authentication custom thing that you need to go along with your main container. But more often than not, you're just going to have a single container that makes up your app. Now, there are other system level things such as Dapper and some of our system services, let's call them, that we actually use sidecar containers for. But you as the developer typically will just have the 1 container. All right. And with that, I'm going to pause just to make sure everything's good. Okay, Haley, I don't see any crazy questions there. I'm going to jump over to Visual Studio, and we'll take a peek at what Visual Studio can do and help you get started with Azure Container Apps. Here, I have opened up a real simple API app. It literally has just this one main method here. excuse me, which is the /albums. And then all it does is it comes down here and returns a static list of albums, titles and authors or artists, and price and a link to the logo. So real simple API. It's a great thing for demoing here. What you'll see over here on the right, and this came from GitHub, by the way, and the reason I mentioned that, I'll touch on that in a moment. But over here on the right, you'll see I don't have a Docker file. So all I've done is I've said file new, added a little code to my API, and now I'd like to publish it to Container Apps. And it's very easy to do that first publish up to Container Apps. I'm going to right click on the project. I'm going to click publish. And we're going to present you with a wizard that you've probably seen if you're a .NET Visual Studio user. And I'm going to choose Azure, and I'm going to choose Azure Container Apps here at the top. And then I'm going to select either an existing container app that I'd like to update with this code, or I can create a new container app. So let's create a new container app. And with this a little easier name to read, I'll name this -VS. And I am going to put it into that same resource group that works. And I already have an environment here. If you take a peek here, you can see that I have an existing env. I did that just to speed this this process up so we can get up to the portal and look at some of the great ways that you can diagnose and monitor your app. So if I needed to, I could create a new resource group right here. If I didn't have one, I could create a new environment right here, just right within Visual Studio. If I didn't have one, we'll use the ones I have. And then this last one, this is the container name. So remember, you could have multiple containers in your container app. Typically, you're just going to have your main container. So I usually just call this main. You can name it whatever you want. And I'll go ahead and create that. Now, hopefully, the people running the demo behind the scenes, that would be Azure, will create this container app fairly quickly. It usually takes 20 to 30 seconds. We have a backup plan, though. If this takes more than a few seconds, I'll use an existing app that I've already created. But I have a feeling this is about to finish. All right. Haley, are you pedaling faster? Could you pedal faster?
I am doing my best.
All righty.
While we're waiting, can we see what's the repo URL?
I will show you that in a moment. I can't. Actually, you know, I have that. No, I have that right here. Actually, I don't know if it's public, to be honest, but if not, if it is, yes, it is. Big Morty albums, and so feel free to go up there on GitHub/BigMorty/albums. Good question.
That's awesome. Thanks, Mike.
So here we just created that container app. So the app has actually been created in that environment up in the container app service. I'm going to click next. And this is where we're going to pick a Azure Container Registry to store the image that's going to be built. If I don't have one of those, I can also create one of those right here within Visual Studio. So with this process, you can create all of the pieces that you need up in Azure to get started. So it's really easy. I'm going to go ahead and choose, you can probably guess, this .NET Day ACR, which I also created yesterday. And then the last couple questions, these are really interesting. I mentioned earlier I don't have a Docker file, and I don't even have to have Docker desktop installed if I'm not doing interactive local debugging. I can just ask .NET SDK to build an image for me, and it will do that, again, without Docker desktop and without a Docker file. So you don't have to be a container expert to get started. I can choose to use Docker desktop if I want to. I would need a Docker file. I don't have one, so we'll choose that. And then lastly, because this project came from GitHub, I'm actually going to have a choice here. I have a choice to publish this interactively, which is what we're going to do here in a minute. Or I can have Visual Studio create a GitHub Actions workflow up in my GitHub repository. And by default, it's going to run that workflow every time I commit and push up a new change. So typically what I do is I do my first publish or two with a really basic app, just kind of the bare bones of the app. And then I'll come in here and I'll generate a CI/CD workflow. And from that point on, excuse me, I will just I'll just push up my changes each time, and GitHub will take care of building the image and deploying it into my Azure Container App environment. So we'll go ahead and choose that, hit finish. It's creating a profile right here. Visual Studio works with published profiles, which is really handy because the next time if I wanted to do an interactive publish from Visual Studio, I wouldn't need to go through all of these steps. What I'll have is I'll have a publish file, a published profile, and I'll be able to come straight to this next screen that is going to show up any moment. My machine might be chugging along, but anyways, so there's going to be a screen that comes up in a moment. I'll have a big publish button, big, but it is there. All I need to do now is click this, but with the speed, and then, like I said, on future publish actions, I'll come right to this screen and just hit one button. I'm not going to hit that button because I know that can take a bit, even when my machine is running wonderfully. So what I did yesterday is I created not only that environment. So here we are up in the portal. I created this environment here, and I actually deployed the exact code studio using .NET to build that image. I didn't use Docker Desktop or Dockerfile, so the exact same scenario. And you will see I have an app here. So this is the app that I deployed yesterday. This is actually the app that we just created. And when an app is created, you have to give it some image. So what Visual Studio does is it gives it the quick start image. And so I actually have a running app that we created from within Visual Studio, but it's not the app with the code I wanted because I didn't hit that publish button. But I did do that yesterday to the other app. We'll go back to that list and we'll go into the Album API. And here is the Album API code, and we'll just click on the URL up here. This is the application URL. Holler if you can't see anything, and I'll definitely zoom in as needed. And then, of course, you'll also see here's that environment that I just didn't mean to scratch up. I'll go ahead and click on the application URL, and it's going to fire up that application. It actually did a cold start on that app, and if we have time towards the end, we can talk about the different scaling philosophies that you can use inside of Azure Container Apps. But that's why it took a second or two. It needed to pull the image from my ACR. It needed to spin up the app, and before it was ready. And so it took a couple seconds. You have options. You don't have to let it go into that cold start state if you don't want to. And there we go. We have our albums that have come back. So that's how easy it was to get started in Visual Studio. Took my file, new API code, added what, maybe 10, 12 lines of code, right-click, publish. .NET did all the work for me to build the image, push the image to my container registry up in Azure, and then deployed it to Visual Studio. I'm sorry, deployed it to Azure Container Apps. And here we go. Here's some great albums. I mean, who doesn't? Oh, this is one of my favorites right here. You, Me, and an App ID. Famous artist at Dapper Eyes. So yeah, we got some great albums coming back here. Okay, back to how I can now. So we've done the build and publish using Visual Studio, and now the second part of the session is going to be more around how do I monitor and diagnose. So keep an eye on my app. How's it running? What kind of resources is it using? And also when I run into problems, how do I diagnose that? So we have a lot of great things we can do over here. I'm going to skip this whole section here, but you can see this is where you can come to set up authentication, define secrets, set up your ingress, which by default, I will click on this. I set this up when I deployed this to enable ingress from anywhere. You can have other options, such as if you only want this to be able, this URL to be able to be hit from within the container environment, like from an app to another app in a microservice way, you can limit that. You can choose your protocol, HTTP or TCP. You can even choose your transport if you want, but auto usually works because it'll detect, and so on and so forth. I won't read all these. Obviously, you have your target port. That's the port inside of your container that your app is listening for traffic. And we now support session affinity, and we can even restrict. So that's an important one. Ingress has a lot of options. What I want to do is I want to jump down. Excuse me. And you can see, I mentioned that multi-revision versus single revision. By default, we are in single revision mode. That's really easy to change. If I want to, I just click on the pencil, click to multiple, and then apply. I'm not going to do that. It only takes 5 or 10 seconds. You can see I have that one. I have one revision deployed, and it's getting all the traffic over here. If I had multiple revisions, I could split that traffic however I wanted to in 1% increments. Here's the container that I defined. By default, actually, I raised this. I did a deployment on top of the first deployment and raised the CPU and memory to 1.5 and 3 gig of memory. But you can come here and you can look at your health probes and stuff like that in your environment variables. And then scale and replica. This is really interesting and powerful. The default, I believe, when Visual Studio creates an app is a min and max of 1. But then you can come in and change this to whatever you want. I've actually allowed it to scale to 0, which means after 5 or 6 minutes, if it doesn't have any traffic, it's actually scaled to 0, and it will cost me nothing. When I'm using the consumption plan in container apps, and it'll cost me nothing if it scales to 0. But it also can scale up to 20 different replicas if I get a lot of traffic going there. And actually, we probably still have one replica running, because I went over here and was hitting this. So I'll actually click a few more times just to keep that alive. And so down here, this is where we get into, actually, this will be fun. Let's go to logs. So here we are. I didn't want logs. I wanted log stream, actually. Log stream is your real-time logs that you can view. So here we go. We're connected by default. What I'm going to do is I'm actually going to drag this window over here. Let's make that a little smaller. And then we'll go back to our log stream. I'll go ahead and clear this log stream. And then I'll come back to here and I'll just hit refresh a few times on this. Boop, boop. You can see every time I hit F5 over here, this spins and I get more logs. So this is a great way to interactively look at your logs. Again, these are your real-time logs that are coming out. I can look at both my console logs. I can also switch to system logs. I have a feeling someone has got a hold of my URL and is having fun with me because I'm seeing a lot of logs come by, and that's fine. You want to scale up. I think that's your aim. Go ahead, keep going. We'll see that scale up if enough of you hit that. But while we're waiting for that fun, you'll actually see here where I get system logs. These are log messages that are coming out of the container app system itself. And so you can look at both of those really easily. If I have multiple replicas, which we can also see that here, I bet we have more than one. We still only have one because people can't hit F5 fast enough. Yes, I dare you. Spend my money. Come on, let's get that to scale up to at least 20 replicas. As we can see, we're still at 1. So one way to measure that. So I'm sorry, I got a little distracted. Logs is a great way. I'm running out of time, so I got to hurry. We also, our log stream, logs is another great way to look at your logs further back. So this will let you look back in history at your logs. What you want to do that is come down here. Here's your console logs. I can just run the simplest of queries, which is give me all my logs. And now I can see those, I'll see those logs come up. It's the same logs. It's just these can go back days and days and days, where your log stream isn't going to go back as far. It's only going to hold a certain number of megabytes of logs. This is running a little slow. So what I can do is I can actually say, let's just look for the last 30 minutes. And you can build these queries to only look at certain columns. You can see each of these console logs and system logs have certain columns that you can select. We're not going to wait for this because we're running out of time. So I covered log stream, logs. I also want to point out console. This is a really, don't want to save that query. This is really powerful also. We're still at 1 replica, by the way, folks. Maybe I was wrong.Maybe people weren't hitting it. But I can choose the replica, and I can even change the container. So if I have more than 1 container, like if I had my own sidecar, or if I'm using Dapper, Dapper would show here too. And I can actually connect using a shell or bash or something custom. It has to be a shell that exists. I apologize, just getting over cold. That exists inside of your container. We'll go ahead and connect here. And this is going to connect to that running container up in Azure, and it is. And I can do simple command here. I can ls to see all of the files. If I wanted to, I could even cat the app settings.json file just to show you. So whatever you need to do here, you have a console connected to it, and you can have at it. Okay, lastly, let's see if we have gotten more scale going on our replicas. And we're still at just 1. Okay. Another way to look at that is I can come here to metrics, and I can look at my replica count, and I can say, show me my replica count. There we go. In fact, I'll tighten that up to just the last 30 minutes. And we can see how my replica went from 0 to 1, and it stayed at 1 because we have enough stuff keeping it busy. If there were no requests again, it would scale to 0 after about 5 or 6 minutes. There are many other metrics if you want to look at maybe your reserved cores. So how many cores am I actually using? And if you remember, I set this to 1.5 for each replica. If we did go to a second replica, my reserved cores would go up to 3 because I'd have two replicas going. So again, lots of things here. You can actually generate alert rules. So when certain conditions are hit, you'll get an alert. You can do that for querying of your logs also. So alerts is another great thing that you can do. All right, we're running out of time. I know I'm supposed to say 5 minutes, and I will save at least a couple, 2 or 3 minutes for questions. One thing I wanted to do, actually, Haley, I'm gonna ask you, are there any burning questions there that maybe I can answer by showing something in the portal?
So the question we have on deck here is a container app versus web app. So I say you show what you're going to show, and we can touch on that if we have extra time here.
Okay, and that is a great question.
It is,
and it's actually not the easiest to answer. Well, I'll tell you what. If you're looking to build microservices, I think first of all, if you're using containers to solve your problem and to run your payloads up in the cloud, Container Apps is a great place. If you're not using containers and you just want to hand code to a Azure service, App Service offers a great way to run your code, which doesn't have to be containerized. For web apps and APIs, they do a great job doing that. But again, if you're containerized, especially if you're a microservice, based solution where you want to deploy multiple apps closely, tightly knit together, so they can call each other really easily. If you want to take advantage of built-in Dapper or the scaling using any of the Kata scaling rules, and of course built on top of a lot of open source projects like Kubernetes and and some of the others I listed, that's where Container Apps is great. We actually have an article up here. I just switched over to the learn.microsoft.com. We actually have a compare container options. It touches on what I just said, but you can come here and read about, when Container Apps and when some of these other things. So head up to the documentation and hopefully that will help. I did want to show if I needed to change any of this, I could go and submit YAML or ARM or use the CLI, or I could come to the portal. And this is where I could easily change or update maybe. Let's say I wanted to update my image. I could click on that main container. And now I can pick a different image rather than my album API, or more likely, probably just a different tag. So I could switch to a different image or tag from either ACR or Docker Hub or MCR or any Docker Hub like registry that we can access or that you can access. I can also change the CPU in the core. You'll see here I have an environment variable. I could just create a second one, and I can pull those either from a secret or a manual entry. I'm showing you this because .NET developers love their environment variables. I'd actually say all developers do. So this is a really easy way to put in a variable or change the value of an environment variable. What do we want here? We're just going to use Haley. Why not, right? We'll put Haley there. What else can I do here real quick? We can define health probes. So I can come here and I can use a liveness probe. Actually, yesterday when I was testing, I went ahead and did that. I didn't set the path, but I could set the path because if you happen to see in my code, I actually have a couple of health endpoints. I have a health good that returns right away, and I have a health slow that takes, it looks like 60 seconds to return. So I could go and I could put health good right here. I'm not going to do that because I'm going to hit publish and it'll probably break. But anyways, I'm going to save that. I think the only change I made was to add an environment variable, but I can also come here to scale and say, you know what? I want to make sure there's always at least one running, one replica, and I want to go all the way up to 30. And by the way, this max number is going to change really soon. That was a horrible. It was supposed to be this. And actually, it was supposed to be this, I think. That's going to change to a much larger number. And so you can scale to massive numbers of replicas. Okay, we've made some changes here. I'm just going to hit create. And this is going to create a second revision. Remember, I'm in single revision mode, so it's going to replace the existing revision. Whoa, wait a minute. I have two revisions. I'm in single revision mode. Why did that happen? I don't know why that happened either. But actually, that was expected to have two revisions because what it's doing is something we call zero downtime deployment. It's actually spinning up that new revision. It's pulling down the image, spinning it up, and actually running all the health probes. Once it's happy and that is provisioned successfully and it's hit the liveness and readiness probes, it will then switch the traffic. And that way, no requests are lost in that time between the two replicas. So in about 30, 50 seconds, you'll see this go to 1, and then we'll be running on our new replica, which could be a different image, more CPU memory, whatever. All right, I'm going to end there unless there's questions that bring us back to the portal. I just want to say thank you very much. It was a pleasure to present to you. And here are some great resources that you can look up, all the docs, samples, our GitHub page where you can ask questions in the issues list. But we also have a Discord channel, which I try to look at every day. So if you want to just chat with Big Morty, that's me, come on over to our Discord channel.
I will get these links added to the chat so everyone can access them.
Thank you.
I also wanted to mention, so there is a live stream tomorrow. So if you enjoyed hearing from Mike and the Container Apps topics, tomorrow there is a Container Apps. Oh no, sorry, not tomorrow. The 13th is the Container Apps live stream, and then every month it's the first Tuesday of each month at 11 a.m. I believe. And so if you enjoyed Mike's content, we got more of that coming at you.
And do you remember the title of that live stream?
I don't, but I know it's a big one.
It is. It has a special topic. It's like come hear some big announcements that we have. So we have some big announcements. We're releasing some awesome features to public preview in the very near future. So yeah, come join us next Thursday, I believe.
Yes, next Thursday, April 13th. And so you can follow, like, subscribe to the Azure Developers YouTube. That's where you will find all of that content.
And we won't show any of these demos here. They're all new demos, so don't think you'll be bored.
We could never be bored with you, Mike. Never.
Oh, thanks, Haley. So no questions.
I think we just got a fan club for you.
Oh, I don't know about that. Oh, I wish I had a few more minutes because I would show you. I use this cheesy tool called DDoSify, and you're going to kick me off, aren't you? But what I could have done is I could have went here. I'm just not going to have time. Never mind. I won't even take away from Jeff and folks' time.
We can save it for the live stream next week. So this is a teaser that you guys have to join for the live stream next 13th.
No, we have a full other stuff to show you. So I was just going to show you how I can throw 20,000 requests at this endpoint, and we could watch that scale. And I could come to the metrics and watch the replicas go up. It's actually a fun demo, but I think you get it. And if not, reach out to me.
I'm sure everyone will.
Thank you so much, Haley. It's great to see you.
All right, moving on, just to make sure we have time, I want to bring on David, who's going to talk about our next session here. Hi, David. How are you?
Hey, Haley. How are you doing?
I'm doing really well. Very excited to have you here.
Thank you. Thank you. It's going to be a big show to follow after Mike, but we're going to try our best to do it.
Oh, I'm excited. I'm excited.
Awesome. So ready to kick off then? Let's do it. Boom. So, hey, everyone. Today, I'll be presenting to you on the topic of an SMS generator. We're going to be showing you how to build an SMS generator that leverages short URLs, and we're going to be using Azure Functions, Azure Storage, and Azure Communication Services to do this. This presentation is by myself, as well as Frank, who couldn't be here due to some issues. So I'm David. I am a product manager on the Azure Communication Services team, and I'm excited to walk you through this topic. So what is the problem that we're trying to solve to start with? So you might imagine in different types of customer engagement scenarios where you might need to send a URL out to your customers, either through SMS, email, or through some type of other channel. URLs sometimes look like what we have on the left. We have a bunch of query parameters. We have a bunch of information that's all getting trickled in, and we need to be able to send it in less than 160 characters through SMS. And so what we're going to be showing you today is how do you use the power of Azure to build out your own URL shortener, as well as how do you integrate it with Azure Communication Services to send that SMS. So before we get too deep in, I want to show you kind of what I'm talking about. And so what I'll do here is I have a running endpoint already with our URL shortener hooked up to our Azure Communication Services. And so what I'm going to do is just quickly send myself a text message with a short URL. And so here I'm going to send myself a URL that's it's not as long as the one I showed you, but it's somewhat long. And I'm going to go ahead and send it to myself on my phone. And so I'm going to just through Postman hit send. And what we'll see on my phone in just a second is that the SMS comes in with a shortened URL on it. If I click on the short URL, you can see it takes me into that page that we just encrypted. And so, and this page is actually a tutorial that I will be sharing with all of you who want to follow along by yourselves and perform the same exercise that we're doing today. So before I show you how to build that, let's go and I'll take you through a bit of the architecture that we're using. So we're using a couple of different components to build this type of experience. First off, we have an application that's running in .NET using our Azure Functions that becomes our endpoint where we are able to hit it to be able to trigger that the shortening of the URL as well as the sending of that URL. We then have a URL shortener that we're going to be sharing with all of you that runs on Azure using Azure Functions and Azure Storage. It allows us to shorten the URLs. It helps us keep track of clicks on those URLs and makes sure that we have something that's scalable, cheap, and easy to run on Azure to perform the URL shortening task. And then finally, we have Azure Communication Services, where we are using our SMS service to push through SMSs into our customers' phones. So let's take a look at how all of this comes together. Let's get out of the PowerPoint and let's start showing you some stuff. So the first stop that I wanted to take is just give you a bit of a overview of what Azure Communication Services is, as not everyone might be familiar with it. So Azure Communication Services is a managed communications platform. It sits on top of the same infrastructure that powers products like Skype and Teams. And we leverage a number of different channels that we provide, all the way from chat, email, phone calling, voice and video, and SMS. Today, we'll be focusing most of our time on SMS, but if you're interested in any of these other channels, be sure to take a look. And what we're going to do to get us started is that we're going to create an Azure Communication Services resource on Azure. I've pre-generated one that we're going to be using for the demo, but I will show you sort of how it's done. So pretty straightforward. We provided a subscription, a resource group, a resource name, and we're able to review and create that resource. And once we actually have the resource created, and as I mentioned, I already have one here, you get a resource that enables you to access all those different primitives that we just talked about. And specifically for SMS, which is what we're going to be using today, we provide you the ability to purchase phone numbers through Azure Communication Services. These phone numbers allow you to be able to both make phone calls as well as send and receive SMS through them. And we're going to be using a phone number today as part of our demo so that we can actually send texts to a phone number. The other part of our demo that we're going to be focusing on today is the actual URL shortening itself. And so for that URL shortening, we are going to be leveraging a sample, open source, available to everyone, that enables you to quickly deploy that architecture that I just described, of having that Azure function and Azure storage working together to help you shorten URLs. This sample, as I mentioned, is fully open source, so it's available to everyone, and it's now officially a part of the Microsoft open source program. So we're very excited about that. This sample is as easy to use as a one-click deploy. So when you do a one-click deploy, you're able to go directly into Azure and start the deployment process for the sample. Looks like we just hit a small error there. So once you go through that one-click deploy, you're able to have the sample running on your Azure on your Azure subscription. Once it's running, the sample actually provides multiple different endpoints that you're able to leverage, and it enables you to be able to not only create URLs, manage them, and do other things with them. We also provide an entire UI on top of it so that you can manage the URLs manually as well, as if you want it. And so now that we've kind of introduced all of the different pieces that are coming together for the demo, we're now gonna actually jump over to showing you how it's built. And so for this, we're gonna throw away the PowerPoint completely, and I'll quickly just mention that, just give a shout out to the tutorial that we'll be providing. So everything that we're covering today is available to you on learn.microsoft.com. There is a link on the chat as well as on all of the slides that you can access to get access to this tutorial, and so that you can follow along yourself if you wanna do that. And throughout the presentation, I'm going to be leveraging this tutorial to help us along. So let's jump over to the code. So to start with, what I have here is that I've set up an Azure function in .NET. I've done it using the Azure extension directly on Visual Studio Code, where I'm able to create an Azure function very easily. And so here I just have the kind of the vanilla Azure function that gets created, which we're going to be extending as part of this demo. And the first thing that we're going to be doing as part of this demo is that we're going to be making changes to our local settings.json file. I'm not going to open mine because I've actually already gone through and gotten my connection strings and whatnot added. But generally, the idea is to add into that local.settings.json file a couple of environmental variables that we're going to be uploading as part of our Azure functions. Things like our connection string for Azure Communication Services, the phone number that we're going to be using, as well as the URL to that URL shortener that we deployed earlier. Once I've done that, I can now start to build up my function itself. And we're going to start by adding a couple of query parameters that we're going to be parsing out of the request. And so in order to send that SMS to the right person and to actually shorten a URL, we're going to be adding two query parameters, one for the phone number that we want to send the message to, and one for the URL that we want to shorten. Once we've added those two query parameters, we're now going to focus on the exciting part of it, which is we're going to now shorten that URL, and then we're going to send a text message with it. We're going to start by shortening the URL. And what we're going to do is I'm going to add some additional imports here to help us with the post request that we're going to be making to our Azure function for the URL shortener, and as well as some JSON helpers so that we can actually parse it out. In order to parse out the response that we receive from that URL shortener, I'm also going to add a class that we're going to be using to deserialize it in just a second. So now we start with the process of getting that URL shortened. And so we have an endpoint that we can use to get the URL shortened. And what we're going to do is that we're going to hit that, and that URL that endpoint is actually what we've already configured as part of our local settings.json. And so I will start by configuring our HTTP client right here. With our HTTP client, we're going to be sending some request data with the URL that we want to shorten. And then we're going to be making the post request and deserializing the response back. So we're going to do that right here. So we serialize the request data that we're sending. We go ahead and we send it, and then we go ahead and we send it, and then we read what comes back. Something that the little error I'm getting there is one thing I forgot to do, which is super important, which is to declare our environmental variable. So as I mentioned, we need to get that environmental variable that we declared on the local settings.json file. And so now that I've declared this, we now have the URL for us to make the request to. So with those couple lines of code, we're now parsing out the information out of the request. We're serializing the request data that we're going to send to the URL shortener sample that we have running. That will shorten our URL and send it back, and we're going to deserialize that using the class that we had added just above right here. So let's go ahead now and go to the next section, which is for me the most fun part, which is like we get to send the SMS to customers. So the first thing that we need to do is we actually need to add the package that we're going to be using. And so we need to add the Azure.communication.sms package. And I've already done this, so it'll probably tell me that that's already existing in my environment. But just as easy, we can add the package in, which we will need. And the next step is to update some of our imports so that we actually are able to use that package. So I want to add in our Azure.communications.sms import. Next, we're now ready to get started with sending it. And the way that Azure Communication Services SMS works is that we need to initiate an SMS client. That SMS client requires a connection string to get started. So we're going to go ahead and leverage those environmental variables that we had already declared, our Azure Communication Services connection string and the phone number for it. And we're going to initialize our SMS client directly. We're then going to go ahead and use that SMS client to send out the SMS directly. And we're going to be using the send method to do that. We're going to be populating that send method with a phone number. So the phone number that we're sending from, that is the Azure Communication Services procured phone number. And then the phone number that we're sending to, which is the number that we've parsed out of the query parameters. And then we're just embedding a very simple message here. And just to kind of prove out that like this is real, I will add a timestamp to it. So it's 1:46 here. There was no way I would know what time I was getting to this. So we'll add a 1:46 so you know it's true that we're doing this live. We're then finally just going to go ahead and pass back the response that we get so that we know whether the SMS was successfully sent or not. And we're done. We've actually configured the Azure function to do what we wanted. So the next step is that we're going to go ahead and run it. And once it's running, we will test out that same demo we did at the beginning to make sure that it's working and that we're getting that SMS back. So let's go ahead and run it. So we're going to hit F5 in our keyboard. Let's see. F5. Looks like I already had one running. Let me kill that one. Okay. Now we're just going to run it manually if the F5 is not working. Okay, we're just going to run it manually. Looks like my terminal was being funny. Okay, that's fun. Yeah, let's try this again. We'll just start it manually. So what we'll have here in a second is we'll build our Azure function, and we'll have it running locally, so that we can test it out. One important thing that I'll mention as we're waiting for this to happen is that URLs are tricky to work with within within SMS environments, because SMS carriers tend to want to block URLs to limit spam. And so one of the things that Azure Communication Services provides you out of the box is the ability for you to verify those phone numbers. It is an additional extra step that takes a couple days to go through to get the initial verification, as well as then a couple weeks to get the full verification. But it's important to do not only for your customers so that they can receive your communications, but it's really important for you because by doing that verification, you will unlock additional thresholds to be able to send more SMSs, as well as unlock things like sending URLs, which can be very important in certain scenarios like this. So you can see that now we have things running. So I'm going to go ahead and go back to Postman, and I have here ready a call. So we're going to be calling a local host. We're going to be texting the number again, and we're going to be sending that same URL that we had before. We're going to go ahead and send. Okay, so let's go in my phone to see. Okay, looks like it's just coming in right now. And so let's go over to the phone, and you can see that 146 number is right there. If I click the URL, we get taken again to that site that you'll have access to. So great. It looks like things are working. So yeah, in conclusion, so with Azure Communication Services, as well as the Azure URL shortener that we showcased, you're able to very easily put together these types of experiences to help augment your customer engagement interactions. As always, you can always take these types of Azure functions and deploy them out to Azure. There's very great documentation from the Azure Functions team on doing that. And if you are curious on what to do next or trying it out, please visit ak.ms/SMS short URL to learn more. And I'm excited to answer any questions that you might have on the chat now. Thank you.
Thanks, David. So we have a couple questions here, especially just around the cost of it. So we'll start with here. I think in the chat we linked the full scale, like what the costs are and things like that. But if we want to talk about that just for a second, that would be awesome.
Yeah. So Azure Communication Services is completely consumption based. So you only pay for what you use. I can quickly just navigate into some of the pricing documentation we have. So for each of the primitives, we have different pricings. But for example, for SMS, you pay you pay a monthly fee for the actual phone number, but then for the actual text messages that you're sending, you're paying by message. So it's fully consumption based, depending on the geo that you're sending in.
Is there a limited quota for the free services? So like, is there a certain number of SMS messages that can be sent for free before you get charged?
Is that question related to like using free Azure credits? Is the question?
I believe so.
That is a good question. I might need to double check on that. I believe that we have some limitations in terms of phone number acquisition with free subscriptions. There's some carrier-related limitations that we have there. But when it comes to the sending, I believe that you're able to leverage those credits for it.
Cool. The last question we have here is, can Azure Communication Services be used without purchasing a phone number?
No. Well, depends. Sorry. So when it comes to SMS, you do need to purchase a phone number in order to leverage it. But when it comes to our other primitives, like if you wanted to do like voice and video, like through VoIP, or if you want to do email or chat, that does not require a phone number. So you can get up and running with things like email, chat, and voice and video calling without needing to purchase any phone number. We do require a phone number when it comes to SMS, for example, where we need to have a phone number to send from, as well as our telephony offering. So if you wanted to call call phones to their actual number, then we do require a phone number to do that.
Very cool. Well, thank you so much, David. It was great having you here today.
Awesome. Thank you very much, Haley. And I will. I saw there was a couple other questions, so I'll answer those in the chat later. But thank you very much for everyone for those questions.
We actually do have time, so we can pull these up right now.
Sure. Let's go through some additional ones.
Yep. So what does a program look like this look in action? What does it look like for a client?
So in action, what this looks like is you're able to like, for example, some of the very common scenarios that we see from customers are things like appointment reminders, for example. So in action, you would have some type of service that might be generating appointment reminders, or like ETAs. Like, imagine your DoorDash, you need to send ETAs to your customers, or like tracking links. So you would have some type of service that's generating those links. And then you would be able to pass those links through a URL shortener like what we just showed, to then be able to package them and send them through SMS. So there's definitely like an added component that is really more scenario specific that would come into play, depending on what information is it that you want to send. And that's why the way that we've packaged kind of the solution today is that it's an endpoint, so that you could call that endpoint from another service that's dealing with like appointment reminders again, and like have that service call this one to help with the shortening of the URL and then sending it out to the right customer.
I've seen the answer to this question in chat, but I think it's always just good to mention and pull this one up here. What about international numbers?
So we do have support today for some for different geos. We are continuing our geo expansion as we speak, and so there will be more announcements coming soon. And so as we expand geos, we will be adding additional country support. So today we do have some limitations there in terms of what countries we're supporting, but additional support is being added pretty consistently. So we'll be excited to share more information with you very soon. If there's any specific countries that you're interested in, drop them in the chat. We would love to know what everyone's thinking about and what countries would you like support for.
Cool. Where can we figure out which countries are supported right now?
So in this same documentation that I have here, you can find some of the country support. I believe we even have some documentation that's specific to the country eligibility. And so I will try to get it added or show it here. But if one of my coworkers who is in the chat actually has the link and drops it, that would be even better. But I'll try to kind of just look for the number for the specific documentation. I believe it might be right here, where we have some of the restrictions. Yeah.
Awesome. Very helpful.
Cool.
And as we wrap up, we have another question. Can a purchased phone number be used for call forwarding if a user tries to call it or reply to the SMS?
That's a really good question. So we do have, we've recently public previewed a new service within Azure Communication Services that we call Call Automation, that enables you to do call forwarding. So you're able to receive phone calls and be able to forward them to any other number that you prefer. On the SMS side, you do have the ability to receive SMSs and be able to, it's pretty open. You can do whatever you want with that SMS and decide where you're forwarding it to. We don't, for SMS, I believe we don't have like a built-in forwarding system. So it would be, you would have to add a bit of that glue between them to make that happen.
We keep having such great questions come in. Every time I think we're done with the session, we get another great question. We'll just keep rolling until we're at time here. How do I ensure deliverability of SMS to my customers? URLs can sometimes get blocked.
That is an excellent question. Thank you. Thank you for asking it. So one thing that I briefly touched on, but I'll maybe spend like a couple minutes on it because I think it's really important. I'll kind of navigate to the doc where we talk about this. Is when we talk about toll-free verification. So the key to deliverability is verification. So ensuring that the carriers know that the phone number that you're using is real and it's being used for business purposes rather than to spam or cause issues for customers. And so that's why before even getting started with like building something like this, it's really key to start with verification as one of the first steps. Ensure that the phone number that you're using is already either in a pending verification stage or fully verified, so that carriers know that the traffic that's going to get sent through that phone number is valid, that it's business oriented, and that you're providing your customers with the right tools to be able to do things like unsubscribe or stop messages, which are are part of the requirements that we require for verification. And so this is really kind of the key to it. If you want if you want high deliverability and you want URLs to not get blocked, this is what we recommend doing. And it's even though it might seem like an extra step that you need to go through, it's really a benefit to your business, making sure that you're not going to get those blocked SMSs and losing business because of it.
Regarding sending mails using Azure Communication Services, how would it be different from MS Graph or Exchange API?
So the Azure Communication Services email service is agnostic. So you're able to do things like use Azure managed domains or even bring your own custom domain. It is fully consumption based. It also allows for higher limits, so you can do like bulk email sends. So it's definitely more targeted towards marketing and notification scenarios, where you're sending maybe emails to hundreds of thousands, even millions of people at the same time, and you need like high deliverability, scale. So that's really the differentiator versus some of those other services that Microsoft also offers.
And the final question we'll answer before moving on here is, would this be considered a microservice?
The solution we built, yes, I guess so. Yes, it is running in its own microservice within an Azure function, so it does allow you to be able to. It would be part of kind of a microservice architecture. Yes.
Awesome. Thanks so much, David.
Thank you very much for having me, Haley. Have a great rest of your day, everyone else, and we'll see you soon.
Yep. Bye. All right, we are moving on to the developer productivity portion of our day. And so here we have 2 sessions left before we wrap up for the day. Thank you so much for hanging in there with us. I hope this content has been great and informative for you. Please remember all of the resources that we've been showing, in addition to more learn documentation modules to go through to get started, can be found at this link here. Please like and subscribe. I just got to keep plugging this. Without further ado, let me welcome on Gaurav. How are you today?
I'm good. How about you, Haley?
I'm doing awesome. We're almost through with the day, unfortunately.
Yeah. Yeah, and it's a bright day today.
It is.
Okay, so without further ado, my name is Gaurav, and I'm a product manager on App Services team. Now, in next 30 minutes, what actually I'm going to talk about is how do you migrate and modernize your ASP.NET web applications using Azure App Services. So before I get into the whole modernization piece, I just quickly want to talk about what if I have a bunch of ASP.NET applications on-prem, how do I migrate them to App Services in the first place? And there are multiple different tools which are available for you to use. And as many of you might be aware, that Azure Migrate is pretty much the centerpiece of all migration tooling when it comes to Azure today. And as part of Azure Migrate, again, we have this whole integrated experience using which you can perform like at-scale discovery, assessment, and migration of your web apps. And quickly, if I talk about the whole at-scale discovery, so it starts with like you downloading an appliance and configuring the appliance in your on-prem data center. So remember, the whole Azure Migrate experience is about at-scale discovery, assessment, and migration of your web apps. And by at-scale, it could even be your entire data center. So talking of which, currently from a tech stack point of view, we support ASP.NET and Java Tomcat web apps for at-scale discovery. And again, it's there on VMware, Hyper-V, or even physical server environment. So once you download the appliance and you configure the appliance, after that, the discovery process is pretty much automated. And what we do is we basically give you a very nice interactive dashboard of what all apps we have discovered on every individual server with some of the underlying infrastructure details. Once the discovery is done, the next step is assessment, and you as a user pretty much go ahead and define a tons of attributes that you want to assess against. And by assessment, basically what we are trying to ensure is that your web application, once you migrate it to app service, I mean, is it ready to be migrated, or is there any of the like post migration configurations that may be required? So once you have chosen the Azure region that you would want to migrate to, and maybe you required an isolated deployment using app services environment, we go ahead and kickstart the assessment, and we do a bunch of configuration check against your web app for a suitability to be migrated to app service. And what we do is we come back and give you a result in terms of apps which are ready for migration, apps which may be ready with conditions, meaning apps will get migrated, but you will definitely require some like post-migration configuration changes, and then apps which are currently not ready for migration. Now, once you're done with discovery and assessment, actually it's the final step, which is the actual migration. And what we allow there is you can basically package multiple different web apps and configurations along with it, and then migrate them to app service. Now, at a time, you can like create 5 app service plans and go ahead and migrate your web applications. And as part of the whole migration flow, we also allow you to go ahead and change the suggested SKUs that we give you at the time of assessment, or if you want to turn around and change some of the packing density, which we suggested part of assessment. So yeah, all those flexibilities are there, and this is all about the at scale discovery, assessment, and migration. Moving on, what if you want to just migrate your web applications out of a single IS server? That's where you use PowerShell scripts, and this is exactly the demo I'm going to show in a little while from now. Again, the fundamental building blocks in terms of discovery, assessment, and migration are consistent across whether it's Azure Migrate at scale or it's for a single IS web server using PowerShell scripts. Now, another important point to note, especially for PowerShell scripts, is that you can even use them on, say, you already have .NET applications on Azure VMs, and you still want to move out of Azure VMs to say app service. It's doable. Or you have a .NET application running on a cloud server service web roles. I mean, you can again use these PowerShell scripts to migrate your web application from web role to app service. And finally, we also have this whole like wizard based experience, which is about what if I just want to like have a look and feel about what the migration means, and I just want to migrate one single web application out of my web server. That's where the standalone tool comes into the picture. So the idea here is you want to do an entire data center migration, or you want to do a single server migration, or even a single site migration. We have tools to support all different scopes. So moving on from PowerPoint to the actual demo. So this is a classic IS server where I have a bunch of ASP.NET applications, and now I plan to migrate these to app service, and I plan to use PowerShell scripts. So basically the idea here is that you typically go ahead and you can download that. Once you download the script, simply unzip the script. That's it. There is no installation required. It's just downloading and unzipping the PowerShell scripts. Once you have these scripts ready, you can see and start executing the scripts. Again, in the interest of time, what I've done is I've just got some of these commands simplified so that
Can we zoom
now
in
what the
just a little
first
bit
command?
so we can see these?
Okay.
If that's possible, that would be great.
Let me try and increase the font further. Hope this helps.
Awesome. That's super awesome. Thanks.
Yes. Thank you. So now what is happening behind the scene, as you can see, basically what the PowerShell script is doing, it talks to the IS server, and then it runs a host of readiness checks against every single website that we had on the IS server. And that comes back and gives me different errors or warnings against every single check. Now, if you see for one of the site, it's telling me that there is basically a framework or a TCP port check which has failed, because you remember Azure App Service allows incoming traffic only on HTTP and HTTPS. Now I had one of the site intentionally which was running on TCP. So basically that's not a site which is ready for migration. So moving on to the next step, once I have pretty much the readiness available for my PowerShell script, what I do next is I go ahead and create a package. Now, what's happening behind the scene is all the web applications which were reported as ready or ready with conditions will be basically packaged. And by packaging, what's happening here is we will package the content and the configuration of your web apps. And then in the final step, we will basically go ahead and kickstart the migration of these applications. So let's give it a few seconds. Yes. So now I have the package ready. And finally, what I do is go ahead and start the migration. Oh, it's still packaging the final site. And the time it takes also depends on the content size. Remember, we support up to 2 gigs of content that can be zipped and deployed to your app service. If you have larger content, I am going to come to that in a little while when we talk about modernization features. But yes, there are ways that we can help you deploy larger content sizes as well. So I'll just wait for this to finish. Yes, and it's done. Now, finally, what I'm doing is I'm starting the migration. So how this whole thing starts, it will start creating an app service plan behind the scene. And once the app service plan is created, it would basically go ahead and then create a web app, and then finally copy the content over and deploy it to the app. And this is the resource group where shortly we'll see a plan being created. I mean, this might take a few seconds. So in the interest of time, what I did, I already migrated a web app in the same PowerShell scripts, and that's the web app for you. Now, again, remember the web app that I am showing you currently on the screen also has a database attached to it. And for database migration, you can use, it's very common for ASP.NET applications to have, say, a SQL database in the backend. I mean, there are enough tools available from Microsoft for you to migrate your SQL databases over to Azure SQL or managed instances, whatever you decide to use. So once you have that, I also want to show you something very, very simple. So it's very common for us to define our connection strings in the web.config in the similar fashion that you have on the screen. Now, the first step in modernization that I would want to call out here, which is pretty simple but super powerful, is you go to my web app and configuration. I could actually move. I'll give it a bit. Yes. So if you see what I've done here is I basically created a connection string using the configuration options for my web app. What this allows me to do is this basically lets me move my connection string out of the web.config as an environment variable. Now, the big benefit for an environment variable approach here is that if I want to change my database server, if I want to connect to an entirely different server, I can make the change here and my web app will get restarted, of course, and then post that it will start talking to the new database. So basically, I'm avoiding a new deployment by using this scenario. So this is like one of the very common modernization approach that you can take, like with your, not only with your connection string, maybe with your other app settings in the web.config as well. Now let's take this concept a bit further. Now over here, if you see, I have the database connection string available pretty much like in like, a text form. What if I want to securely store my connection string in Azure Key Vault? Now, how do I start that? Basically, I go to Key Vault, I create a new Key Vault, I go to secrets, and I go ahead and create a new secret. Now, I've created a secret called DB connection string. And as you can see that I basically get an identifier for my secret and I have the secret enabled, and this is where the secret value exists. So this basically is your actual connection string for your database. Now it is basically available in my Key Vault. Now another important point to understand here is before I can have a Key Vault reference work with my app service, I just go back. I basically use references with my app. What I need to do is I need to have a system managed identity available, because it's basically this Azure Active Directory. Basically, it is this principal object against which I will provide access to make a call to the Azure Key Vault reference. So what happens here is, if you see, this is the managed identity that I have created, and then I go back to the Key Vault, and I go to the access policies of the Key Vault. And you can see that basically what I've done is I basically created a access policy over here where I have granted a get permission, a policy for the secret. So basically what I'm saying is that using the managed identity that I've created against my web application, I want that identity to have access to this Key Vault to basically list the secret or get the secret for my web application to use. Now, once this is done, what I do is I come back to my app, again go to configuration, and now I will edit the DB connection string, and instead of using the value here, what I would do is I would basically use a Key Vault reference. Now remember, this is a secret URI that you get that I just showed you from the Key Vault, and how app service identifies that this is a Key Vault reference is basically you add the @Microsoft.keyvault just before the secret URI. That is it. You say okay, you save. Behind the scene, your app would be restarted once this is done. Now, just a couple of seconds. And you can see now, once I click on the URL, my app just loads. So what I have done without making any changes to the code, I have basically changed my DB connection string all the way. I moved it out all the way from my configuration, from a web.config file, stored it in a key vault securely, and then I have hooked my web application to basically use the key vault based database connection string. Similarly, if you remember, I just said about larger content sizes. Now, it is again very common that my on-prem web application is using a virtual directory. Now, as some of you might be aware, that we already have something called as bring your own storage for app services, and how that works. Again, if I go back to configuration, for some reason, my screen refresh time is taking a bit longer, so please bear with me. Yes, and if I go to path mappings, I can basically go ahead and create a new storage mount. Now, what this means is that if I have a storage account with a file share, for example, something similar to this. So this is my storage account that I have created. And what I've done within the storage account, I've actually created an Azure file share. If I go further within there, basically, this is my file share where I would have just uploaded. I mean, I can upload whatever content I want, either manually or programmatically, or using something like as AZ copy. I mean, it's up to me how I move my content from on-prem to this Azure file share. Once I've done that, basically what I can do now is if I come back to my web app, I can again just mount this Azure file share as a local network mount for my web app. I mean, I can just give it a name like some file share. I can make a choice of the storage account that I want. And then what it does, it lists all the file shares which I have created within this storage account. Now remember, for Windows applications on app service, basically my mount path would always start with /mount. So I need to give this mount path a name like /mounts/ maybe my file mount, whatever name I want. I can even declare it as a deployment slot setting if I need. So what I did, I basically created a storage mount. Oops. So what I created a storage mount, and additionally, now you can also create a virtual directory pointing to this storage mount. So if you look here, what I've done is I basically created a virtual path /images pointing to the physical path for my web application, which is /mount/web image. And if I want to verify this, I can just go to kudu. I can go to a command shell. And if you see file mount that I created. Now what that means is basically I can go to my web app and I can now browse an image. Now this is basically how I'm actually loading all my static content onto the web application, the demo web application that I'm showing here. So this is how, if you see, I have an Azure file share which I mounted as a local mount for my web application, local file share for my web application. And I've then gone ahead and created a virtual directory pointing to this physical path now, which is again in turn pointing to an Azure file share. So that's how the entire thing works. Now, it's not that I only can like upload content manually. I can even access the virtual directory programmatically. So if I just show you a simple piece of code, this is how you pretty much like, upload or download files from your web applications. And that is still the same piece of code that you can use with virtual directories when you deploy your web applications to Azure App Service. So you see, I'm still doing server.map/path/images. So I mean, pretty much without making much changes, I mean, I'm having the same functionalities available for my web application, even within Azure App Service. Now, moving on to some other great options when it comes to modernizing your web applications. The other important thing I want to talk about is logs. Now, the way you look at logs is, what if I want to look at the antivirus audit logs for my web applications, or I want to look at the console logs or the app log itself. Basically, you start by creating a new diagnostic setting. And what I do here, the diagnostic setting is, I first make a choice of which logs I want to capture for my application. So I basically went ahead and chose all the logs which are available for my web application and even the metrics. And then you have the option to either send these logs to a log analytics workspace. So I had a log analytics workspace created, so I configured that, or you can archive these logs to a storage account. You can stream them to an event hub, or you can send them to a partner solution. So again, it depends how you want to consume the logs which are generated by your web application, but we provide you many different options to do that. Now, because I already created the diagnostic setting, and look at some of the logs which are generated by my web application. So the moment this loads, yes. And once you click on logs, basically we have some of the queries which are already defined for you. I mean, you can always write your own design. I just want some app logs for my web application. And what this query does, it's basically going to give me a bar chart of app log severities over a period of time. So let's give it a few seconds. Okay, we'll move on to the next option. I also want to show you something super exciting that we are working on and should be available in next few weeks. So as you guys are aware that when it comes to app service, in terms of scaling, we provide you many different options, right? Like you could do a manual scaling by just drag of a slider, or we already have the existing capability, what we call as auto scale, which is like a rule-based scaling engine. So you could either set up like a timer-based schedule. Like I can say that I want my web application to be running on extra instances, or maybe during the daytime, and I want to like scale in during the evening time, and I expect that my application will not be under load conditions. So in addition to that, we are also working on enabling a brand new scaling capability for our web applications, and we are calling it automatic scaling. Now, the big difference between the automatic scaling and the existing auto scale is that in automatic scaling, you really don't need to define any rules per se. What you just need to define is, you need to define that for my app service plan, because remember, an app service plan is basically a logical construct which gives you the underlying infrastructure and features for your web application, and you could deploy multiple web application to a single app service plan. So what I define is I basically say that my app service plan at maximum can scale up to n number of instances. Now for my premium plans, I can maximum in app service, I can go up to is 30. So I can say that my app service plan under load conditions can scale up to 30. In addition to that, I can also define how many always ready or warm instances I want available for this specific app. Now, again, this setting can be different for different apps. So if you see here, I am saying 1, I can drag the slider, and what this means now is that at all times, I will have at least 4 always ready or warm instances available for this web application. If I want, I can also say that although my app service plan can scale to 30, but I still want this individual web application to only scale up to 4, so that I don't get into bottlenecks behind the scene, maybe with my database or stuff. Now, quickly to test out this, let's go ahead and run a load test against this application. Maybe I'm running just a 5th one. I'll run the load, and it will take few seconds before the test starts to run. You can see here that I have hooked on my web application to App Insights. And right now, I only have one server online. Once the test starts to run and you experience load on this web application, you will actually see the number of servers which I already had defined as 4. If I discard the changes, I already had the app scale limit as 4 and the maximum burst for my plan as 5. You should see the number go up to 4. I will just wait for this test to start. Yes. So the test is configured. It's a load test. It's just starting to execute. And if you see, the number went up from 1 to 2, it's now 3 servers, and shortly it will go up to 4, but it won't go beyond 4 for the simple reason that I said I just want to go up to 4. I can go up to 5 because the maximum burst for the app is 5, for the app service plan is 5. Now, if you see with this kind of a scaling option, I can basically take an existing .NET web application, migrate it to app service, and configure automatic scaling, which I simply put as like, a cruise mode scaling for your web applications. I hope you guys enjoyed the different modernization capabilities that I just showcased. And I'm almost at time. So any questions, Haley?
No, we just have a couple comments on great presentation from, I think, your twin here, who almost has the exact same name. Thank you so much. This was awesome.
Thank you. Thanks, everyone. Have a great rest of your day. Thanks.
Yeah,
Bye.
you as well. Bye now. All right, on to the very last session of the day. This has been super exciting, and I hope all of this content has been very helpful. So we will be moving on, and I will be introducing our next 2 presenters here. Hi, how are y'all?
Hi.
Hello, doing good. Thank you.
Nice to see you.
Yeah, great to see you. Matt used to be on my same team, so it's great connecting again. So, all right, whose screen would we like to present right now?
We'll start with just Syed and myself, and then we can go to the presentation.
Sounds good. All right.
Would you kick us off?
All right. Yeah, so today we'll be discussing static web apps here, Azure Static Web Apps, and we'll talk about getting started with, we'll be actually using Blazor WebAssembly project here and end up publishing that to Azure Static Web Apps and Visual Studio, and I'll be doing that part of the demo, and Matt Hernandez will be taking up from there and showing you how to get a CI/CD flow for Azure Static Web Apps using the Azure portal. And then I believe if we have time, Matt might talk about some backend options there and also some time for Q&A. So yeah.
Yeah, so hi, I'm Matt Hernandez. I'm a product manager on the Azure Static Web Apps team. And yeah, as I had said, we're going to go through some of these items here. We're going to start with why you might want to choose static web apps, especially for Blazor front ends, but just in general, TypeScript, JavaScript, Python, all of that stuff is going to be supported on the back end. That'll make more sense as I get further along. If you take away one thing from this whole presentation, it's that static web apps is a complete solution for modern web apps. By default, you're going to get a globally distributed front end. You're going to get API integrations such as our serverless functions, the app service paths, or even container apps for our containers as a service option. You have data API generation. All of that stuff is just kind of built into the product. Authentication provider integration, so GitHub auth, Twitter auth. Think we actually got rid of Facebook, but GitHub and Twitter are going to be the big ones in there. Customizable authorization. So if you drop just a JSON config file in there, you can say what level of auth is required to access certain routes. And best practices by default. That's something that I'll go into a little bit later, but you're going to get CI/CD out of the box. And the other big thing, which is honestly one of my favorite things, is the generated staging environments. Okay, so I promise this is like the only slide that I have that is like full of text. The rest is just going to be graphics. So what all of this means in practice is you may have built something that looks similar to this model here, where you have your static content is stored in like a blob storage container. You either FTP that in or you use some sort of custom CI/CD that you've written with GitHub Actions or whatever. You front that with Azure Front Door for your CDN to make sure that that front end is globally available. And then you have your API routing through API management to your various regions on the back end. Now, in this case, what I've always done is app service web apps that are essentially just wrappers for the database. That's our data API. And then for authentication, we bring in Azure Active Directory, and that we use that manually to set up authentication and authorization. Now, when it comes to static web apps, all of that stuff is just built right into the product. I know that sounds like a lot, but I promise you, it is built into the product. All of these pieces just kind of come right out of the box. You can, as soon as you deploy, you can hit .auth/login/GitHub, and suddenly you're logging in with GitHub. The database piece, you just connect a database and we will create an API for you on the back end. Now, as I said before, it's not just your front end. We have direct integration with functions. So you can actually have your front end and your serverless back end in the same repo and hook that up to automatically build and deploy just immediately. But you can also do what we call bring your own API. So if you have like an existing ASP.NET backend hosted on app service, either Windows or Linux, doesn't matter, you can connect that to your static web app front end. Same thing with container apps. If you have a backend running over in container apps, just link it in. It's just a handful of clicks and you're good to go. And the other thing that I didn't point out that I would like to point out is that we do have a very generous free tier. There are a handful of features that you have to pay up to our production level tier. The biggest of which, honestly, is the SLA, the 4.9 SLA. But yes, and then I am going to hand it off to Syed for the first demo.
Okay, great. Thank you, Matt. So here we are in Visual Studio, and we're gonna for when building a static web app, the project type that we have for that scenario is a Blazor WebAssembly project. And we can create that in the new project dialog here, Blazor WebAssembly app. We can go through this. And then after we go through this process, it'll create us a Blazor WebAssembly project. And with Blazor WebAssembly, you can still write C#, but everything actually gets compiled into a WebAssembly file, and then that will go down to the client. So all the files on the server are static, and there's no need for a backend actually running there. All right, I'm going to switch over to an existing Blazor WebAssembly project that I have here. Let me go ahead and run this with start without debugging. We could also do Control F5 there for that one. All right, so let me go ahead and put these two side by side here. So here is the, actually I'll just make it full screen for now. So this is a recipe app, and it's a .NET 7 app, but it actually originally was created, I believe, with .NET 6. And I think Dan Roth is one of the main people that was working on this project here. All right, so one thing that I'm noticing here is I think Dan must be a fan of the light mode here, because this is a very kind of bright website here. But I'm a fan of the dark mode. So I'm going to go through here and start making some changes here. So as I uncomment these, theoretically, it should have actually updated here. So let me just do that one more time with another Control F5. And if that doesn't work, then we'll just do a refresh. Okay, no problem. Let me just modify these. All right, so let's go ahead and save that. I'll just do a refresh in the browser here. Okay, great. So I changed the background color, and I also inverted the logo here. Let's go ahead and go into a recipe here. Also noticing a couple issues. The tags are not appearing correctly, so we have to fix that. The color of this link is pretty small, and then this text is almost unreadable as well. So let's go to that. That's in recipe details. When you're working with .razor files, you can create standalone view components here. And the solution that I'm working with here, we've got the Blazor WebAssembly project, which is the best for you recipes. And then we also have what's called a Razor class library here. And with Razor class libraries, that's a way that you can take all of your components, put them in a specific library project, and then you could share these components across different ASP.NET Core projects. And they don't necessarily have to be limited to Blazor WebAssembly projects. They could be also reused in regular projects, depending on how it's been implemented. And along with that, when you create components, you get a file that ends with .razor. And if you want a .css file that's associated to that particular component, you would just name it, the name of the file, .razor.css. And now all the styling here is particular to that specific component there. All right, so let me bring this back. Let's go ahead and do another refresh. Okay, so these styles have actually been applied automatically. So we can see that that's been fixed, and then now I can see my tags as well. All right, so that was hot reload that does that automatic pushing of those styles here. I'll go ahead and collapse this because we're not going to use that one anymore. We've got that. Now let's go ahead and go to the publish experience for this. So I'm going to right click on the Razor WebAssembly project. I'll select publish here. In this project, I've already created a couple publish profiles. So when you go in here to begin with, you might see a slightly different experience, but we're going to follow the same exact steps here. So let me click new, and then we have a variety of different targets where you can publish this project, but in this case, we'll pick Azure. We're also going to go ahead and pick Azure Static Web Apps, but of course there's other hosting options available on Azure as well, but for Blazor WebAssembly, we're recommending Azure Static Web Apps. So I'm going to go next here, and in this selection here, I can pick an existing Azure Static Web Apps instance to publish to, or I can go ahead and create a new instance here. So let's go ahead and try this create new. All right, this is going to bring us to the portal here, and from here, what I'll do is we can, pick your subscription, your resource group. Yeah, I just create a new resource group, no problem. For the deployment details, you've got three options here: GitHub, Azure DevOps, or Other. The first two options are if you want a CI/CD flow to be configured, and if we have time, I believe Matt might go through the GitHub workflow there. But if you pick these two, everything happens in the portal. So if you want to do direct publish from Visual Studio, that's where we'll select the other option here. And I don't need to create any tags, so I'll just go directly to review and create. Okay, all right. Just 1 second here. Okay, let me go ahead and pick one. I'll go ahead and pick this one. Oh, a name. Sorry, I forgot to pick my name there. So best for you, demo 02. I've gone through this a few times getting ready for this presentation. We'll go ahead and create this Azure Static Web App. And this will take a minute to go ahead and get ready and deployed. But this step doesn't usually take that long. Okay, so now we can see that the deployment is complete. So at this point, I'll go ahead and go back to Visual Studio, click refresh here. We created it in that resource group, so it was the 02, so I'll go ahead and click next here. In this case, we've got the publish, direct publish. This item is disabled at this time, but that's all taken care of in the Azure portal. So now we've got a publish profile that's been created for us, and it just switched over here. I've got, 2 existing publish profiles here. At this point, I'll go ahead and click publish. And I want to keep an eye out on this output window. So in this particular build that I'm running, for one reason or another, it's not popping up the authentication page. So I need to copy this and then go ahead and sign in on this page. You shouldn't have to worry about this. It should pop up the correct page and paste in the correct code as well. So let me go ahead and do that here. No thanks on that one. Go ahead and continue there. All right, so now we've been authenticated, and then this kind of pops up again. All right, so how much time do we have? All right, so we've got a couple minutes left here. So let me, as this is happening, let me kind of point out a few things that you might, that you should be aware of. So the first thing is, when publishing from Visual Studio, the environment will be set to preview by default, and Azure Static Web Apps will always have a production environment, but then you can create additional environments there. So when publishing from Visual Studio, you'll get a preview environment. And let me show you how to modify that. So in the Solution Explorer, under Properties, we can see we've got a series of the pub.xml files here, one for each published profile. So I go ahead and click on the demo 02. And then here is the environment name. So here we've selected preview, but let's say after you publish your site to preview and everything's working great, then you can go ahead and switch this to production, do another publish, and then that will go to the production endpoint of the production environment for that Azure Static Web App. Let's see if this one's done yet. Okay, great. All right, that was like really perfect timing over there. All right, and then after it's done with that publish process, it should go ahead and load up the website. And there's also a link on the publish page for that website as well. So that's over here for that. All right, and that is a kind of simple demo of how you can take a Blazor WebAssembly project and then go ahead and submit that to Azure Static Web Apps. So let me do great recipe. And I don't know how to spell recipe there, but that's okay. I gave it the 5 stars. All right, I will go back to Matt.
Hi, I am just trying to share my screen for the next part. I think I shared the wrong one, just a second. Screen 1, here we go. Okay, so the experience of deploying within Visual Studio is cool and everything, that's great. But there comes this point where you're doing more. Maybe you have additional people that are working on your team as well. And so that's where we get into the kind of the leveling up and moving on to using CI/CD and stuff like that. So the other entry point into actually creating a static web app, and I saw some really good questions, I'm going to answer some of those here as well, is here directly in the portal. So same kind of setup. I'll pick a resource group. I won't talk too much about this. I did see somebody ask about the region. This region is a little bit confusing. Your front end will be globally distributed, it's not, this right here is only for your backend. If you see, it's for your functions API and staging environments. It's just for your backend. Your front end is globally distributed, period, always. So I've actually taken the recipe app here. I created it's not a fork for a reason, but if you notice, there's nothing in here except the source and stuff like that. And we will connect to that. So 5 is prime. That's me all over the internet if you want to get in touch with me. Recipes, and of course, main. Now, another question that came up was what front ends are supported. And yes, we support all of the most popular front end frameworks. We got you covered. Now I have to remember exactly where this is because it was in source. That's for you recipes. So I'm going to try and copy that. So instead of being in the client, you'll have to, for this one at least, do this. If you have a functions backend, you can specify where that location is, or you can just leave this empty. That's cool. And review and create. So I actually have this running somewhere else so that we don't have to wait for this to build, but I do want to show you exactly what happens. Same screen. Okay, the resource is done. Now let's go back over to our repo. And now you'll notice that I have this commit on my behalf for adding CI/CD. And what this workflow does is creates these build runs. Actually, let me go into the YAML file. You can see exactly what's happening. So on these specific events, it's going to run the build and deploy for static web apps. It's created some secrets in the repo. That is similar to how we create the publish profile in VS. All that stuff is created for you behind the scenes. And if we go into actions, we will see that this app is currently being deployed. There we go. This is all real-time build and stuff like that. It takes a few minutes, so I'm going to switch over to a different repo, which is here. So this is the exact same one that Syed was just demoing. You can see last week I prepared this and ran the actual build and deploy job. But the other thing that I wanted to show off is I mentioned the staging environment situation. And the way that works is I created a branch. I just called it attribution. And I did something I knew was actually going to break this. I just changed one file. And I added a little TM in the name. The name is actually used to pull the images. And you'll see that what happens is there's a build that's run. So the static web app CI CD build deploy. And if I go back over into my static web apps and I look for that one, I now have two environments. So my main environment is my WASM branch, which I can browse to and everything is cool. That's just the default main branch. But that attribution pull request automatically created a totally separate environment. And I can browse to that one. And you'll see that where I added my TM, it actually broke. So I can test this. This also, I mentioned the region piece that you pick up from front. This is where your staging environments will be as well. So this one's in central US. So your staging environments will be region locked, for lack of a better term. But yeah, so at this point, once I have corrected the issue and I merge the pull requests, that will kick off a new build and deployment to the production environment. And everything's good to go. This is probably, like I said, one of my favorite things about this. You can make sure things are running. You can use that as you review the actual PR and ask for changes back, that kind of thing. We have just a few more minutes, so I kind of wanted to jump into the Q&A. I know there were a couple of other questions that I didn't cover.
I saw a question about what is a static web app. I wonder if we can address that one. So Yeah, so let's compare a static web app versus like a typical ASP.NET MVC project. With ASP.NET MVC, those are basically server rendered, right? So you'll send a request, the server will get the request, and then it will actually process that request and then generate the HTML response that will be sent out. Now, with a static website or with a static web app, there is no server-side processing there, right? Literally what's happening is they're just files being transferred over the wire. So, imagine the internet like 10 or 15 years ago, or maybe even more, where there was no server-side frameworks and they're just files sitting on servers. So that's what a static web app is. And maybe Matt has more to add to that. I'm not sure.
Yeah, so there are a couple of other names that people are using for patterns. One I see becoming popular now is like the mock pattern. There's also the Jamstack. It's really about your front end is built. It is static. The files that are actually there in your app are static. All of the processing and runtime rendering stuff happens in the browser, in your customer's browser, that kind of stuff. And if you notice in the agenda item, or in the why static web apps, I didn't want to use the word static. Instead, I used the term modern web apps. So it's all about these modern front-end frameworks. React, Vue is my favorite. Angular, those things where they're single page apps, right? You're rendering in the browser, that kind of thing. It goes beyond that though, with the serverless backend just kind of built in. But yeah, I would like to call it something else just between us. I mean, just between all of us that are watching this right now. Yeah, because now we also support the SSR server-side rendering with things like Next.js and stuff like that. So static has gotten to be a really heavy name, and yeah.
There's also a great video posted by James Montemagno, why to use static web apps, also on the Azure Developers channel. And so I've linked that in the comment section as well, just in case you would like to learn more about that. In addition, Matt and the Static Web Apps team also has their community live streams. So y'all are the 4th Thursday at 9 a.m., I believe. The next one being April 27th to learn more.
Yeah, I did create a link and it has some of that content. It's I don't know where to put it to make it show up on the screen. I'll throw it in this other chat.
Yeah, you can put it in the chat and I'll make sure. There we go. I can get that up there.
But I did put together a list of links. It does include like the This Month in SWA that links out to the community stand up and stuff like that. Yeah, and like I said, I'm 5is Prime everywhere on the internet. Like, you're welcome. DMs are open everywhere. And I did see a question from Za. As soon as we commit and push code changes to the repo, GitHub's workflow kicks in and updates the website. Yes, absolutely. And that YAML file, that GitHub workflow file, you can add other stuff to that as well. So if you have CI or unit tests that you want to run for the CI portion of it, you can npm tests if you're a Node person like me, or whatever it is for other frameworks as part of that as well.
And you can also configure that. The way that it comes out of the box is really like a CI/CD type of flow. So every commit will then get pushed to that preview environment. But you can modify those files to push from particular branches or have certain safeguards and whatnot. Yeah.
Oh, there's another really good question. Yes, thank you so much for putting that up there. There are no APIs or databases used with static web apps. Kind of. So what we've tried to accomplish with static web apps is as little API as you actually need. So for example, if you are just serving like an API that wraps your database, you actually don't need to implement that. So like me personally, I would go and create an Express app that would just make calls over to the database with Mongoose or something. You don't actually have to do that anymore. You can just go into the portal for your app, go to database connections, link your database, and you just magically have an API that accesses that data. Again, the built-in auth and authorization, you can set that for the routes for that data. It's both REST and GraphQL as well. So if you're using React and you want to use GraphQL queries, that's all in there. Yeah, and then of course, like the APIs are not limited to the serverless piece. You can always point to an app service instance or a container app instance. I think there are others, but those are the two that are the main ones that people use.
Yeah. And then on top of the built-in capabilities that Azure Static Web Apps has, when you're building a Blazor WebAssembly project, even though even though these files will be served in a static fashion, you can still write C# because what's happening is we've got that WASM component that comes in, and that will bring you the .NET framework, and then everything is just run inside the browser there. Yeah.
Great. What a way to end the day. This was such a great session and great questions. Loved hearing all of your thoughts.
Thank you for having us here.
Yeah, thanks.
Thank you so much, everyone, for joining us for the very first Azure Developers .NET Day. We will have more of these in the future, different languages all across Azure and how you can get involved. So let's look at just the end of the day wrap up. Please follow us. Oh, there we go. Follow and subscribe to make sure that you are connected with us. We want to make sure that you guys are seeing all the latest content and y'all are getting connected with the community that we are trying to build over here at Azure. We want to make sure that we are bringing you the best content, the newest feature updates and everything like that. And so please follow us on our YouTube, our Twitch, our Twitter, and all of our other social media that you can find on our link tree below here. You can see all of these sessions later. We will be posting them to the site as well, in addition to all of the live streams that we will host on Tuesdays and Thursdays across the different Azure services. Thank you so much for joining us, and I hope y'all have a wonderful day.